Discord. So I would like all of you to join our Discord. The link is on the website GeekCamp.SG. Yeah, so I would like to thank our venue sponsor SP Digital. They are hiring, so you can find their jobs. Find the jobs, job openings on their website, on their LinkedIn. And they will also have a little get banner beside the vending machine. They'll be at during lunchtime. And then also let's also thank our platinum sponsor, I'm Token. They have a booth. You'll see their banner and the booth, and you can check out they're hiring. So check out their website, carriers.token.im. And finally, and also we would like to thank our gold sponsor. They also have a booth, Cake DeFi, and they are also hiring. And then finally, one final shout out to ProLife, a silver sponsor. You can visit their website, prolife.co, to find out more about their services. And also, we would really like to thank our donors, our 27 donors who donated a total of $848 after fees. And I would like to say your names out, if that's okay. In random order, Min, Boon Kiat, Gibson, Henry, Tiam Heng, Tek Chun, Chi An, Jason, Colin, Kenjin, Wei Ti, Henry, Katie, Xiao Hong, Chia Yu, Tim, Leroy, Thomas, Sheldon, Benjamin, Coleman, Wei, Zion, Matthew, Ming Wing, Pritam, and Linda. Let's give a round of applause for them. One nice thing they received is a color-changing mug that will change when it's heated up. Yeah. And we also like to thank our partner communities for bringing some of the for some of their talks to GeekCamp. We have GoSG, RubySG, Python User Group, Geeks Hacking, Hackware, Singapore JS, Singapore CSS, Hackerspace SG, Engineers SG, and iOS Conf. And finally, I'd like to also thank Engineers SG for providing the recording equipment for GeekCamp, and also Force Asia for providing recording equipment for Barcamp. Yes. Engineers SG is a volunteer-run video recording event community. So we go out and record meetups. So if a meetup you want to record it or you want to volunteer, please check out engineers.sg. So I didn't make GeekCamp happen alone. It was all my fellow organizing community that made it happen. It couldn't have happened without them. Yes, woo! So these are all their photos. I'll read out your names: Li Hao, Tai, Jianzhen, Alvin, Brian, Sam Porter, Shao, Hazel, Dawn, Patricia, Sam Tan, Juliana, Sridhar, Tomo, Hong Keng, Elliot, Chiran, Ellen, Peril, Stephanie, Luther, Terrence, Ambrose, Mr. Gee, Wei Tat, Vina, and Nori. Thank you all, and whoever was involved in this process. I'm really grateful that for your hard work. Yep. And finally, I think I'd like to pass the time to Pritam to talk a bit about Barcamp.
Okay, sorry. Yeah, thank you. Thanks, Ambrose. Yeah, okay. Okay, so I'll just quickly tell you how can you post your topic for the Barcamp. Okay, before that, I think some of you guys have attended Barcamps before, isn't it? Have you guys? Yeah, So it's basically we don't have a schedule as such. You just come in and take a piece of paper and then just write down your topic, okay, and then just post it on the topic wall over here, this side, and then the rest of us will go and vote. And you can vote for multiple topics, but don't vote for your own topic. I mean, you can, we won't know. So later we will just count the number of votes and then assign you a room. We have slots. I think each session is 30 minutes, isn't it? I think it's, yeah, so it's 30 minutes, so you must try to finish by 25 minutes, so that 5 minutes we have for like moving around and like maybe attaching your computer. Also, I recommend don't use a presentation, just have a discussion, because you end up spending a lot of time connecting your laptop and so on. Yeah, that's pretty much it. It's very easy. Just put up your topic, and don't worry if you feel shy or something, because you know, like sometimes you worry that nobody will vote for you. I will vote for every topic. Okay, and then also if you don't have a lot of votes, at the end we will do lightning rounds, which is like 5 minutes each, and then we will let everyone share. Anybody wants to add anything? Nothing? That's all. Thanks. Yeah. Okay, sorry, I forgot about that. Like, the question is, what kind of topics can you post? It can be anything. It doesn't have to be technology. So we already have topics on travel. I think there's one on note taking. Can be anything, okay, which is legal in Singapore. So because people are taking photos on this. Okay, thank you. That's it.
Thank you, Vital, for that introduction to Barcamp. So the Barcamp tracks are at the. You can leave it there. You can leave it on the. So the Barcamp tracks are at the end of the corridor on the left side, the last two rooms, last two doors, and yeah. Okay, I'm gonna go through some important messages before we kick things off. So our code of conduct is on our website, GeekcampSG/code of conduct. The key thing is to make sure you do not harass other people. If you are being harassed, please come and find any organizer in the organizer shirt so you can see the pink. Or if you are, oh yes, that's it. Yeah, do not make offensive comments to people relating gender identity, sexual orientation, disability, mental illness, neurotypicality, physical appearance, body size, race, religion. No sexual images and no threats of violence, and no publication of non-harassing private communication or another member's personal information. And this applies to all GeekCamp attendees as well as Barcamp attendees, so please follow our code of conduct. And yeah, in the event, please, if you're on site, find an organizer or head to the registration desk, which is over there, and report a violation. If you're online, you can go through Discord and open a ticket. Our moderators will be monitoring that. And one note on the sticker, do not photograph sticker. When you see that, please do not take a photo of the person. Thank you very much. They might not want to be photographed, so please protect their privacy. And then for COVID-19 rules, we require that all masks be worn at all times unless you are speaking a talk or engaging in a Barcamp conversation. When you're eating or drinking, you can also take off your mask. If you need a mask, please approach the registration desk. They might be able to help you. And we also encourage you to get tested before, during, and after the event. So, and if at any point you feel unwell, please excuse yourself from the venue and go and seek medical attention if necessary. And preferably attend and join us online. Don't worry about that. So some housekeeping rules, safety first. Again, that's everyone knows that, I hope. Let's keep the space clean, so clean up after yourself. And no food allowed in the meeting rooms, which are the rooms behind, after the door on my left. And when discarding bento boxes, please stack them up. So this is the space we have. It's highlighted in green. You can on my right, all the way at the end, there's the food. The drinks will actually be at the back here of track 0. The registration desk is of course there. Here's track 0. Track 1 is the next room is a joint room. There's only one door you can use to access it. Don't use the other door. And then the other 2 doors at the end are track 2 and track 3 for Barcamp. Yes, I think that's all I have to say about the space. If you need help navigating, please let our organizer know. Yes, okay, important information, emergency exits. So key thing is that if you are in the space on the left, there's a staircase all the way at the end. You should be able to open an emergency exit door. In the middle here, we have the main exit beside the lifts, I think. And then if you are somehow stuck in the in my right side of the space. I don't think you should be there in the first place, but if you are, the exit's on the all the way at the end. And the meeting assembly area for that, it will be behind Singapore Shopping Center. Yes, it's not this. Yeah, okay. Regarding Wi-Fi, there's a hidden network called Guest at SP Group. You can join that and register for an account. The security, the authentication method is for the wireless network is none. And you'll find plastic folders around, or you can ask the organizers for help if you need that. Okay, finally, some words on before we start the GeekCamp talks, please check the website for more information on GeekCamp. There's the schedule and other information and our code of conduct. And keep up to date. To keep up to date for us on Twitter, we also have Instagram now, Facebook, and YouTube, where we'll post recorded videos so you can watch them after the event. And for Q&A for GeekCamp, in person, you just shout out your questions. The MC will repeat your question, and then you can answer, and the speaker can answer them. Online, you can open the talk chat on Discord and click on the Slido link. The MC will read out the selected questions. And yeah, so this is how it looks like on Discord. And that's all I have from me. Hope you all have a good GeekCamp, and thank you all for coming. It's amazing. Woo! It's amazing to finally see.
Give it up for Ambrose. All right. So we're moving to our first speaker. So short introduction about the speaker.
Are you doing it? Oh yeah. So before we start, there's actually 2 different tracks. So if you guys are interested in like, what's the other track over there?
Track 1.
There's track 1, which have another speech, which is different from like what we're having in track 0, which is this main hall over here. So if you feel a bit crowded or you're not interested in CSS, you can go over there, right? So track 1 is actually about not being shy and actually asking your senior developers for help when you can't really do anything. So I think like there are people who are over there ready to usher all of you guys ready to go into track 1. Cool. Cool. So track 0 is about CSS. Track 1 is about being a human.
I think we just offended the first speakers. All right. Without further ado, let's give it up for Hui Jing from Shopify and Gao Wei, who is a senior engineer at BlackRock. With Hui Jing and Gao Wei. Woo! All right, give it up for them. All right, so short introduction about the talk. It's called the horizontal overflow problem. Have you ever visited a website on a phone only to find that when you want to scroll down, the entire page also sways from left to right because of some mysterious horizontal overflow? Unintended horizontal overscrolling is not a great experience. Let's break the problem down and also try to solve it.
Right, let's give it up to them again. Oh, okay, so we're going to keep entertaining you until they set up. So have you ever like...
Have I ever?
Yeah, have you ever like created such a problem before?
I've always experienced the problem with like...
Oh
yeah.
So do I pass them the mics? Here you go.
Oh, that's so cool. You're using your own keyboard.
You guys are not mic.
I would also like a Beyonce mic, but I don't have.
Right, so sorry. Okay, thanks.
你要打字吗？你要那个？我打字的时候你帮我拿啊。好。Am I supposed to continue the stand-up comedy routine until we are done here?
Where were we? Where did we left off?
Just asking if you ever have this problem.
I always experience the problem but I don't know how to create the problem because I don't know how to do front end at all.
Use bootstrap, you know.
Bang, 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 bang,
Okay,
bang,
you take over.
bang.
You take over.
Sorry, I think this way.
If you are the next speaker after this, please go and look for the hardware people so you can put on your Beyonce mic. Yeah, otherwise it will become like this. Actually, Hello everybody, welcome to GeekCamp 2022. I don't know why the organizers thought it was a good idea to put us first, but here we are. So like until the mic get put on, you will get a totally nonsense introduction. I have not seen many of you in person because for the past 2 years, I have been hibernating crab. Okay, we're supposed to share the mic now. Okay, so yeah, this will be a nonsense talk. But welcome to GeekCamp. Okay, Cam.
Thank you for volunteering to be the first speaker.
We never want to your own self put us your one. Anyway, who is we? We are Gao Wei and Hui Jing, and we are the co-organizers of the now currently on infinite hiatus meetup Singapore CSS. And we are here to talk about wiggling web pages.
That's a very cute kitten. But I think a website should not do that.
Do what?
Shouldn't wiggle. Wiggle. So the other day, I was at our favorite cafe and I saw this again. As I scrolled through the menu, it doesn't scroll just vertically, it also scrolls horizontally sometimes. And because my thumb isn't a very fine cursor, what I mean when I want to scroll down, I can't really scroll perfectly vertically down. So I actually expect the website to guide me in that direction. Is that too much to ask? Imagine a sliding door. It's supposed to slide in just one direction, the direction restricted by its track. It shouldn't move forward or backward, and it shouldn't get stuck as it slides. Well, I'm not saying that websites should never scroll horizontally. Some websites implement primarily horizontal scroll, and it can be beautiful. But I am expecting it to scroll only in the intended direction. And in most cases, that should be one direction at a time. So I think my comfort about this comes from the desktop time as much as from the physical world. On desktop, we use a mouse, like a scroll wheel, which is a one-dimensional cursor. By default, web pages scroll vertically. And even when the content region may scroll in both directions, the default behavior when you use the mouse is to scroll vertically, and only when you hold shift, it will trigger the other direction and switch mode and scroll horizontally. But standing here today as a web developer, if I am to text my younger self, like in middle school, I don't know, 20 years ago, back then I was using a Symbian phone. Like, hey, you know what? 20 years later, web developers, our generation, cannot implement page scrolling properly because phones now have touch screen. I would feel pretty ashamed myself. So how did we become so ignorant?
Okay, so I think maybe some of you not front end, some of you are front end. So I ask the front end people, do you even test on a real device? You don't answer me? You own self answer your own conscience inside you ask, you got test or not? Because let's say you are like me, and I self-proclaim, one day I resize browser 1,000 times a day. It's still not enough. You know why? Because sometimes you never go down to a sufficiently narrow viewport. And this chart, not I do one, there's credit, it's by someone who wanted to shit on Samsung. But the point is like, you see even today, right, there is like the 4.8 inch and below pool of devices, still quite popular one. Samsung still need to earn money one. So if you have DevTools as a separate window, and I know about a lot of my friends who dev, they just take it out because it's easier, right? There's a hard cap. There's a hard cap on the minimum width with the DevTools undocked one. So for Firefox is about 435. For Chrome is 500. Safari even more generous, like 559, then they don't let you shrink already. So if you dock your DevTools, okay, you can shrink until 0. But if not, it will become like that. Another way is like, oh, okay, then you're like, no, I'm a responsible mobile web developer. I will click on the device simulator button. Ding. I agree, it's quite good. But there are still differences because your hardware, your operating system, your browser engine, all different. So she will explain to you why different, right?
Yeah, so there are quite a lot of intrinsic interaction differences between between a real device and the simulator that we may have more overlooked. So first is that finger touches are not the same as a mouse navigation. a mouse is a fine cursor. You can see and point exactly at your intended spot, but you can't do that on your phone. And the scroll wheel is naturally restricting your scroll direction, but we don't have that on the touch screen. So the second point is there are certain behaviors that are only present on mobile devices. I have one, I don't know, bad example. A few years ago, there's a classic WebKit property that all our web developers need to implement, the WebKit overflow scrolling touch. What it does is that on iOS devices, if you don't have that, when you scroll, it doesn't have the momentum. It's weird if you know what it is, but if you don't, maybe your users don't, and if you didn't implement that, as you scroll, the page will be sticky to your fingers. So that is something that you can only see on a mobile device. And then there's performance considerations. Some gestures are running nicely on our MacBook Pros, but maybe not as performant on lower-end phones. And there's only collapsing headers and layouts, which we really often overlook. Like when you scroll up and down, the header will expand and collapse. And also when you pull out the keyboard, some of the things may be covered, and you get a very, very small viewport. So, oops, technology. Yeah. So yeah, next time if you are about to promise that your website is supported on mobile phone, do test it on your own phone first before you can make that promise.
Just in case you don't know how to test your own phone, I'm here to tell you that you can connect your phone to your computer using a USB cable. USB still can use one. So we have a lot of browsers. If you are a web front-end developer, you must have at least 6 browsers on your phone. Then you qualify. You must, your phone and your desktop. So you must have 2 versions of Firefox, 2 versions of Chrome, 2 versions of Safari, then some random indie browser just to prove a point. Anyway, if you are using an iOS device, then ideally you should have a Mac. If you don't have a Mac, then you should make friends with someone who has a Mac. They're like, hey, I need to test, then let me borrow a computer. So if Mac OS, you check Safari is very good. You will have to turn on the developer-related settings because Apple somehow don't want you to anyhowly touch things. I also don't know why. But generally, the process, because it's the same ecosystem, is very seamless. And then your device will just naturally show up under the develop menu. Actually, it's quite good. This one I admit. Chrome and Android also, same manufacturer, same benefit. They also play very well together. So basically, even though for Android there's 1 million, I keep holding my phone because it's an Android phone. It's a $100 Android phone made in China. Anyway, even though there are 1 million variations of the Android OS, general guidance is you just go and search for developer options, you turn on USB debugging, and then Chrome kind of sort of naturally has it. I can't remember if I got turned on anything, but we'll have one. It's not very pro tip, it's a noob tip. If you connect already, then you're like, hey, why doesn't it show up on the devices menu? You must remember that you must make sure the Chrome on your phone turn on. Because sometimes it's like, I never turn on, then like, hey, why doesn't show up? Why doesn't show up? Then like, hey, it's my home screen. So must make sure Chrome is running on the phone. In theory, Firefox also can run, but Firefox don't have OS manufacturer. So this one a bit GG. Somehow, me personally, it's my problem, not Firefox problem. I cannot turn on USB debugging. Maybe you need some Android SDK thing. So if there's like an Android developer here, then you like, like, hey, this noob never installed the Android ADB, don't know what. Then you can't tell me later. So the most important thing is, like, Alcoholic Anonymous, the first step in the 12-step program is to you must know that you have a problem. So how do you find your problem? There is no good formula to find your problem. So it's very case by case depending on the site that you run into. Also, if my level of Singlish is too Singlish, you raise your hand and ask, dial back the meter. I can go back. It can go from all the way from Singlish, all the way to Queen's English one. I can Queen's English one, trust me. R.I.P. Queen. Anyway, but it's a very case-by-case situation. So if you like consistency, you are not going to like what I'm about to tell you. Usually, if you are very lucky, it's like, this one easy to find. What you do is, you just scroll all the way to, oh no, this is the GeekCamp website. And next year, you won't see us anymore. But anyway, you scroll all the way to the overflow already. Then you just keep scrolling. Scroll until you see something poke out. Then you see the thing poke out, like, I found you. Then that's how you do it. So that's a best case scenario. But sometimes you'll get like invisible elements. Cause I always have ad blocker. So actually a lot of times the offending element is an ad. But then you turn on your ad blocker. Then you cannot see it lor. Wow, sweet liao. But it's like detective work. So if you think about it, if every robbery and every murder in the world was solved the same way, then police department do what? Then you got job for what? Right? This is your job. So you must embrace the difficulty. So the more worst case scenario is you might have to brute force it. So you go to the body element, you go to the first level, right? You open DevTools and then you just start deleting things. You delete like, is the overflow still there? No, next one, delete, it's still there. And then after that, you found, this one. Then you just drill down. You drill down into the children, the grandchildren, the great-grandchildren, some more into the 18th level of hell until you find the offending element. That's the brute force method. So, this unsatisfying answer, sorry. But okay, now that you have discovered that you have found the element and then you investigate, got a lot of reasons. A common reason is like sometimes the layout code is just not written correctly. So got some slight minor issue. Minor issue only. GeekCamp website minor issue only. It's fixed now. If you all check now, don't have already. Just to double check. But sometimes it's because you never let something shrink properly. So this is a contrived example. But like sometimes, where's my cursor? Okay. So sometimes maybe you have a min width value on a grid item. But this is very reasonable. You want a min width on something because especially if it's like image, right? You also don't want it to shrink until like cannot see, and what's the point of putting an image there, right? So this is understandable. But let's say instead of using min width that will prevent like natural shrinkage, you can let the browser do the calculation for you. So if you happen to use grid, right? Grid has this very convenient function called min max. Turn on. This one don't need. Then it will be okay already one. But then you're like, wait, the spacing a bit big. Okay, spacing big. Then okay you tweak. Tweak. Maybe it looks better. But as you can see, right, this kind of tweak, right, is not very reliable because there will always be some point that's like very awkward. Then how? Like there will never be a point that it looks good, eh? Does that mean you don't let the browser do work? No. You must think more open, be more open-mindedly. Just add breakpoint. Dude, as good as it feels to do things in a single line of code, right? Nobody ever said that you cannot write more code. It's not like there's a hard cap on how much code you need to write. Even though I would love to apply this hard cap on some people on some projects that I work with. But I never say who. But adding a breakpoint is actually not terrible because actually the designers will like you also because with additional breakpoints you can be very specific on how nicely the design fits. So if you just feel that there's a very awkward point in your content, right? Just hit one breakpoint in, can already. So yeah, breakpoints are your friends. Then sometimes it's sometimes not really a layout issue per se. Sometimes like your items got like super long string. Then the browser is a very polite piece of software. If you never tell it to break, it won't break one. It's like I think this developer would like this string to be very long, so I'll just display it as a string that's very long. But sometimes then it breaks your layout. But browsers generally are very smart pieces of software. Browsers can speak many languages. And you know why browsers can speak many languages? Because dictionary. So anyway, line breaking and word breaking is very non-trivial. So like there is a dedicated talk for like, I don't know, half an hour on just line breaking that I've linked here. I'm very sure nobody will watch it, but I still put the link there. But generally, if the string doesn't need to stay together, actually honestly URL don't stay together, so never mind one lah. Just let it break, right? So the magic CSS property that you are looking for here is test my type with one hand skill. Oh my god. Ah. Huh? Typo already ah? Aish. You all try type with one hand, see how fast you are. Hi. Okay, it worked. So if you line break all right, then it break nicely, and then my scroll bar disappear. No more horizontal overscroll, no more wiggly website. Excellent. And then because word break is a inheritable property, you want to put on the container also can, you want to put on the item also can. Up to you. OT. Aya, a bit too late for that, bro.
I thought you were gonna do more typing, so.
I think only got like 1 or 2 more. It's okay. If you want to, if you are a speaker who want the Beyonce mic, please approach them before your talk and not during the talk. Pro tip, yo. Anyway, okay, continue with the word thing, right? Hyphenation. Can you hyphenate? What is hyphenate? If your English teacher got teach you hyphenation, you're supposed to hyphenate at the correct syllable. But I never pay attention to English class, so I also don't know. I also don't know where to hyphenate. But because the browser has dictionary capabilities, the browser knows where to hyphenate. But by default, right, hyphenation is set to manual. Like the value, property value is literally manual. Manual means what? Manually means you own self go and hyphenate. So if you want hyphens that are already visible, like they're always visible, right, you use this UTF, like let's call it ampersand dash semicolon. And then there's also invisible dash, whereby if there's enough space, right, you won't see the hyphen. When you need to break, then it will just magically break there, and then wow, got hyphen. That's why it's called invisible hyphen. Then it's ampersand shy semicolon. But this only makes sense if you have complete control over the content and the markup. And I bet you are not the one writing the content. I challenge if you have like an army of content writers, you go and ask them, hey, friend, can you use ampersand shy semicolon in the content when you write hyphen? They'll probably look at you and like, eh? Like cannot. If you can, I clap for you. But even if you can coordinate all your content writers to do this magically, right? What if your system use Markdown? Then you end up have to like Markdown and then HTML, and then it's not so straightforward to just everybody just manually put in your invisible hyphens. No. But browsers actually can do automatic hyphenation. This I tell you this example. Do you know how long it took for me to go and find all the languages? All of these these are actual languages. Okay, it's not gibberish. Okay, but these are. You have to set the lang attribute correctly. Why? Because earlier we said browsers are very smart. Browsers can speak many languages only if they have the correct dictionary. So if you set the lang attribute correctly, then you know to check which dictionary to see where to hyphen. Hyphenation, it makes sense to put it manually, because actually if you incorrectly hyphenate something, it's very hard to read one. It's like even more confusing, better not. So browsers will use dictionary to figure out where the hyphen kick in. So the magic CSS property that I need to not type wrongly is hyphens. Auto? Okay. Then all the language are hyphenated correctly. You can also go and see the source code and see what this language are. I also don't know what language this is, my god. Even though browser support, okay, I play cheat, I'm using Firefox, so the hyphenation look very nice. But you try this on Chrome, you try. I ask you to try, I'm not gonna tell you, no spoilers. Yeah, so that's for words and for layout. So there's a complete demo, I call it the cat demo. It's nicer to open in CodePen and try yourself, then you can do the actual resizing thing. Okay, pass.
Nested scrolling. So nested scrolling happens when both your page and a component inside the page have scrolling. There will be a stacked scroll bar. So when users scroll in the inside component, the page will stay at the same level, which makes sense. And then when the component scroll position is at its bottom, try scrolling the component in the same direction. It should continue scroll in the page direction. But sometimes it doesn't. I think this happens only on iOS. Doesn't happen on Android. But nevertheless, your user who are on iOS may get trapped here. So when this happens, the page is stuck in that scroll position because it constantly triggers the inner component only. So us developers, we are power users. We may be sharp enough to notice that, oh, I'm trapped in the inside component, and so if I carefully scroll the page, I can untrap myself sometimes, but not always. So before trying tackling this problem, I think we can first ask ourselves whether this situation is really necessary. Do we really want an inner component that scrolls vertically at the same time as the page component? So actually, web pages intrinsically grow taller as the content grows, and phone screens are only a palm size. So what's behind the necessity of having the nested region that encapsulate a long content and have the stacked scroll bar situation? Thanks. So if it is, somehow your designer says so, if it is necessary, we need to help our users not get trapped in the stacked scroll bar situation. So make sure that the page have enough margin so the users can scroll outside, and also and also you can differentiate the page a bit more clearly, so users know where they are when they scroll. Sometimes this stacked scroll bar is caused by iframe. For example, in the past 2 years, all the climbing gyms require booking, and normally their static website won't have like a booking functionality, so they embed an iframe for you to book in another website. And then as they load the calendar, sometimes the content grows, and then you have an iframe that is scrolling inside your page, and maybe the iframe even has like full width, and then you can get trapped there. But to my happy surprise, one of my favorite gyms in town, they got this fixed. So now it sets the height of the iframe. So here it's loading the calendar now. And if you notice, after the calendar is loaded, you will still have only one scroll bar. And then the iframe is set to the height that is of the inner content of that web page. So how can you do that? One naive solution is to set the iframe to be a sufficient height for its inner content. This works, of course, only if you already know that the inner content has a fixed height. Otherwise, you may leave the parent page with a lot of empty space. You try to overshoot the height, right? But then, even if you do overshoot the height, there's still no guarantee that your inner page cannot grow past that predetermined height. So a more programmatic solution is to set a height to the iframe height, the inner content of the iframe page, when the embedded page finishes loading. So this is not difficult if it gives you better UI, but there's limitation. If it's the same domain, then you can do it without much of a caveat, because the parent has access to the content window.body.scroll height. So you can do changes only on the parent page, but more often than not, the case is you have to embed a page from a different domain, in which case you can't have access to the content window scroll height. So in this case, you need to leverage the browser communication window.post message, which means your inner page has to implement something for the parent page to receive that information when it update the height of the parent iframe. Nested scrolling can be of different direction. For example, you may have a row of images to be displayed on a narrow screen by introducing an intended horizontal flow scroll. So personally speaking, I think this UI is acceptable only if you don't let me scroll both directions at the same time. If you look at this web page, there's a carousel, and users are supposed to like swipe or click to paginate the carousel. But as I swipe, like I mentioned, my fingers are not a very fine cursor. The page can move vertically as well, and it doesn't feel very stable. So there's actually a CSS property called touch action that lets us block the scrolling in the unintended direction when the component is intended to scroll only in one direction. So here are some demos. touch action none means you cannot scroll at all. And if you pan X, it's only going to scroll in the horizontal direction. And if you pan Y, it's going to scroll vertically. So this is very useful when you implement the carousel component like that. So your users will only be able to trigger the scrolling in one direction. And when you do, the page stays there in the other direction. So here's an example of a site that I think is implemented pretty nicely. So you can swipe left and right on the carousel, and then the page will stay there and feel more stable that way. Another potential situation. Just now, Huijing mentioned how min-width may become a problematic layout, but sometimes we're building a very complex app, and it's not easy for us to, take down the min-width and tackle every single component. So this, even though it is potentially undesirable, perhaps it's a situation we have to deal with. So is there any workaround that can get us some minimally usable web app that doesn't introduce unnecessary horizontal scrolling? So yeah, imagine your app is originally built for a very big desktop screen, perhaps a very complex dashboard, or a highly developed e-commerce app. And for whatever legacy reason it is, the app already assumes min-width that's causing overflow on tablets. And now the app is mature with many intricate features and built and supported by a handful of teams. I see my previous team members here. Cannot see which company it is, but and one day your PM comes to you and say, hey, I think it's time that we ship for tablets. Right? Because from tracking data, many users are using tablets, and probably increasing number of users are using tablets. So they give you an iPad, and the first thing you do, you go and check the app. And this is our very beautiful, complex app, and it's introducing a horizontal overflow. And guess what? Your users can change orientation. Maybe we really hope that they stay horizontally, but no. The iPad is in their hands, not in yours. So your goal is to make it minimally useful on tablets, and horizontal overflow is deemed unacceptable. So how do you go take down that min-width and try to fix every single component that breaks your smaller viewpoint? Maybe you want to, I wanted to, but it wasn't very feasible. I don't even know the developer who, I don't even know the developer who worked on every single feature, and I don't even know all the logical conditions that will trigger certain components to show. It's not possible for me to fix them. So I want to introduce you to one use case of the viewport meta tag, which is often poorly understood, I think. So this is quite often seen in a mobile browser. So it's actually a very ancient technology. Ever since the very early days, mobile browsers come with two viewports, not one. A visual viewport, which is roughly how big your mobile screen is, taking away the header and the footer, perhaps. And users may scroll to change the part of the page that he sees, or zoom in and out to change the scale of the visual viewport. Note that the visual viewport follows the actual screen size. So that's for example, on phone it's probably 375 pixels. That's a visual viewport. And then there is a layout viewport, which the mobile browsers gives your web page for layout purpose. So your CSS media queries will receive the dimensions of the layout viewport, not the visual viewport. And the dimension of the layout viewport can be much bigger than the visual viewport. And that's actually how mobile browsers in the old days shrunk down the very big desktop websites to those tiny screens. There's a very nice article called Tale of Two Viewports. You can take a look. So I want to show you a demo of how that works. This is the app that I just showed you. And without me doing anything, it's causing a horizontal overflow. You can see this. and I can change orientation and it will be even narrower. Here's what happened if I add this viewport meta tag to the HTML head. Do we show this? So in this tag, it says viewport content width is 1006 pixels. So let me show you how it looks like. So I have so here it says the viewport width is 1006 pixels, and my content doesn't scroll horizontally anymore. And if I change orientation, it still says 1006 on the viewport size, even though we know that the visual viewport size has changed. And perhaps the text is too small, but note that users actually have the option to zoom out and zoom in case they feel the font size is too small. Okay. But there are a few caveats for this. First is that by setting the layout viewport for this purpose, it actually invalidates your responsive design, because now your viewport is set at a certain value. So it doesn't matter how small your device is, it will be fixed at that value. So all your CSS media queries will treat the web page as that width. There's also a discrepancy between layout size and actual size. So as developer, we have to constantly bear in mind that, oh, okay, the actual device can be 800 pixels, but in fact, I'm like cheating, and the width that the website receives is actually 1600 pixels. So you have to have that in mind. But it could be an easier thing or a more difficult thing depending on how you see this, because now you only ship for one dimension. And then the final potential problem is you have to sell to your designers. Like, fonts can be too small, but the other side of the story, you have to fix every single component, right? So which problem do you want to tackle? And so we managed to sell to the designer by saying that, users can zoom out and zoom in. So if font's too small, it's still bearable, and it's a very intimate browsing experience that you have on a tablet. So that's how we managed to sell the idea. So yeah, that's the story of the viewport tag. Back to you.
Okay. So we talk a lot about technical solutions, right? We talk about CSS, we talk about viewport tag, we talk about iframe, we talk a lot of things. But there are a lot of times where, like what she said, right? She had to sell to marketing people. That's not. I mean, I know there are some people who can speak very well and are developers, but I just feel in general we're not very good at like selling shit. But I feel that like comparatively, technical solutions are sometimes easier to come up with than the people or business side problems. Like developers, right? We hang out with each other too much. So like we take for granted that like whatever I just say, right? I assume you all know what I'm talking about. Viewport meta tag, yeah, I know what there is actually. If I make my mother sit in front of me and like, hey, your youngest daughter giving talk in front of a lot of people, you can't support. She'll probably she'll like, okay, can. Then she'll look at me and like, explain again. No, explain slower. Don't speak so fast. And then after a while, she'll probably say like, hey, actually, you come and fix my printer problem. That's pretty much what my mother will come and tell me, okay? The point I'm trying to make here is that not everyone that runs a website is a developer, right? Like if, like my mother can cook very well. So maybe like, hey, I'm very bored now. I'm gonna start my own restaurant business. If she does have a website for it, right? She's not a developer. And I don't live at home anymore. She cannot, like, I also don't want her to call me every other day like, hey, this my website I cannot, how do I want to make the button green. So the thing is, what if your website owner is not a technical person and there's no developers? Like, but the point of this chicken gif is that I have no meaningful answer. And basically this is the most unsatisfying talk you'll ever listen to, because like, there are a lot of things got no answer one. It's just, I think, something for a lot of people to ponder about. Like if you have the Like when we browse a website, then I call this occupational hazard. Then you start becoming very judgy, like, hey yo, why who do one? Hey, why ayo, who's gonna test properly? Like, okay lah, don't be so judgy. Maybe the person really like no budget, no time, no developer. Like, yeah, sometimes that's life lah. Huh? Okay. So yeah, thank you everybody. Thank you for sitting through this nonsense opening talk. We have successfully set the bar about this height, right? So all the subsequent speakers, y'all can just roll over it and do better. Okay, thank you everybody. No need MC one ah.
Yeah, hello. We have the first track for Barcamp.
Okay, so
travel hacks. It'll be in the last room over here. Okay, starting now. Who's next?
Okay, so there's
actually
actually Q&A.
There's a few questions.
Yeah, there's a Q&A. Go back. Cool.
Okay lah, there's only one lah.
Is there only one question? Okay, you read it out lah.
Okay.
Read out.
If I'm too it's anonymous.
Okay.
If I'm too tired to find the offending Wrigley child component, does slapping a touch action pen Y on my body let me close the bug and go home?
Again, this is a philosophical answer. You can do it. Nobody say cannot. If never say cannot means can. But then you ask your conscience. Can or not? You people see the thing cut off. You okay or not? You at night can sleep or not? If you can sleep, then okay lor. If you cannot sleep, then work a bit harder lah. Okay, that's the answer. No more, right?
Yeah, no more.
Oh yeah. Okay, bye.
Give it up for first speaker. Is the second speaker ready? I think we're looking for Sam, right?
So cool, like there's still another track if you guys are interested in cryptography. Track 1 will be talking about cryptography. The next talk over here at track 0 will be... Cool, also like this secondary talk, there's still a lot of space in front. Those are people who are just streaming in. Please fill up the empty space in front, thank you.
Yeah, please fill up the empty space.
Move forward. Yeah. Guys, those at the back row, right? Move forward, thanks.
Banning the back row.
Yeah, I'm banning the back row. Come forward. Everyone who's sitting on the benches, come forward. There is a lot of space now. Oh my god, everyone is going to the cryptography one.
Ah, so exciting.
I also want to go to cryptography one.
Yeah, this one. So
for the next speak on track 0, we'll be creating art from databases by Sam, right? So are we gonna start introducing? No, right?
Let me check.
I think it's still the website.
Oh, the website one never changed.
Okay, no problem.
Let us. I guess it's.
Yeah.
Okay. All right. So.
That works too?
All right. Oh, yeah, later. it's this one, right? Like live.
Yeah, that's right. Are you guys ready? I'll introduce you guys. The mics are off. Just press. Yeah, it's cool. So, cool. So using DIY EEG sets, smartwatches, and wearables, data collected over a year was processed through deep learning models to explore the relationships between microclimate and brain activities. Let's learn more about this student-initiated projects, right?
I don't know how to mirror. Okay, so I am using macOS Ventura, and as you know, the UI is different from everything that has gone on before. So I'm still trying to figure out how to mirror my screen, okay? But assuming I can't mirror my screen, can I drag it anywhere else? No, but Ventura is different, no, I tell you.
The preference?
Yeah, they don't even call it preferences anymore. They call it system settings.
Yeah,
okay, see, so it's like a totally different UI from what the old...
Display.
No, but there's no mirroring, see?
Okay.
Whereas last time we could just like...
Okay.
Yeah, you understand what I'm saying? And there's up here, there's no... okay, never mind. We will... Ahmed, use your computer now.
Do you want to try? I think, yeah, I think it's here already. Advanced.
Yeah, I tried. There's nothing here on mirroring, see? Yeah.
Extended.
Yeah, change to mirror. Oh, mirror. Okay, great. Okay, thanks. Okay, good. Okay, good. Okay, excellent. So this is the new UI for Ventura. So, which is like totally different from everything that's gone for.
Four of us, so it's fair.
Okay. Yeah. No need to mic up. Shall? No need to mic up. Just pass the mic. Yeah. Just like what Hui Jing and no. I won't be talking very long. Yeah. Okay. Shao, I'm ready to start. Shall I start, or do you want to? I start. Okay. Fine. Okay. Thank you very much. Okay, I appreciate you all being here, and I'm here today with two of my students, Min An and Min Tuan, as well as my associate Ahmed over there. So, unfortunately, we are not as entertaining as Hui Jing and Gao Wei. We are actually from the university, so I have to be, my default way of speaking is a little bit more formal, okay? So, just like Hui Jing was saying that she can go from the whole spectrum of Singlish to King's English, I can also go from the whole spectrum of Singlish to King's English, except that my default is here. But I know I'm not speaking King's English, but my default is closer on this side rather than on the Singlish side. But just like Hui Jing asked you to trust her that she can speak King's English, I ask you to trust me that I can speak Singlish, except that I'm not speaking Singlish right now. So I apologize for that. Okay, so for the next 45 minutes, my three colleagues here will be sharing with you a project which Minan and Min Tuan devised and conceptualized. And I think briefly, I think I'll just hand over to you and then you take over. Okay, so we'll switch it. Since you are the ones who authored the slides, you do it. Yeah. You do it, and then we will. Okay, so without further ado, I'm just here to let you know that we are from the National Institute of Education, and this is an independent research project authored by my two students from St. Joseph's Institution, who are next year going to Hwa Chong Institution. Okay? Yep. Okay. Thank you. Yeah. Okay. Yeah.
Right, so good morning, everyone. My name is Tuan, it's Minan, and today we are going to share with you our Life to Well project, without frying your brain. So, as you may have known before, microclimate is the climate of a very small restricted area. So, for example, those of us sitting right here in this hall right now is considered a very small microclimate compared to that outside of the street, which can be hotter and different in some aspects. And it affects humans in their physiological well-being. For example, their mood, their concentration, and thermal comfort, which is suggested by Liu and company in 2019. And according also by him, climate change has reduced human thermal comfort and health. Microclimate can also impair our body thermal regulation with serious consequences, and it can lead to many health diseases or damages to our body in the long term. And microclimate also has an impact on the functioning of the brain. And like, for example, you may have been very annoyed by your noisy neighbors who always make a lot of noise at night. Right, so the rise of technology has made EEG research more accessible to the mass, and that is one of the aspects that we're focusing on in our project. And we use it to identify human stress level, as according to a research paper by Holt and company in 2015. And furthermore, EEG can be an indicator of physical health, strongly related to the change in human physiological health, like, for example, in heart rate variability and in heart rate. And EEG at the same time can be sensibly used to investigate human productivity. And in our project, we use the 1020 EEG placement system as seen on the figure right to your right. And we selected channel FP1, FP2, and so on, as you can see in the diagram as well. And these channels have been used in past research to detect fatigue and attentiveness.
Okay. So next, I will talk a bit about our Life to Well system. So Life to Well is our attempt to connect the bridge between our mental and physical well-being, as indicated by our heart rate, our physical response data, which mean the biometric data, as well as the mental data, which is the brain wave, which is measured by the EEG headset or electroencephalogram headset that we ourselves made. And next is to measure the environment, we use devices that we make on our own. As you can see, it's this unit over here, a very small unit that we make with microprocessor as well as some very common sensor to measure the environment around the participant. These devices can be worn on the waist of the participant and to measure various very common factors such as the noise level, light intensity, temperature, humidity, pressure, carbon dioxide concentration, and dust concentration. And one more thing I want to show you is the headset that we make to measure the EEG data. So you can you open it and maybe show our headset. Yes. Okay, so this headset is to be worn on participants in sessions when they were to do their homework or maybe work in different jobs, mostly while they are sitting or doing a specific task that require cognitive abilities. So just this headset alone can measure the brainwave from different regions of the brain. Then we validate this headset against research-grade equipment to ensure that our data is accurate. And then we use the data from our headset in our regression model. And as you can see, this headset is made mostly of tape, which is why we managed to reduce the price of the EEG headset to as low as possible, from devices that only accessible in research lab to something that we, as students, can buy and use. So yeah, this is, as we tell ourselves, is a very important step in citizen science, where we make equipment that once unobtainable for laymen like us to be able, for us now to be able to use in very casual settings. Next is, okay, next slide please. Okay, so this is just the wiring diagram and all the sensor or the microcontroller that we use for our devices, for our this module, environmental module. So this one is just like some info. We also incorporate data from the Singapore Weather Station to incorporate more data points to our data set. Now next is, okay, so there's some information about how we process our data. So the way we process the data is quite, well, it's quite structured. So firstly, we have to process data through Python with standard libraries. Then we use libraries such as NumPy, Pandas, sklearn, and we detect outlier with different algorithm like z-score method to remove unwanted data points. And we draw correlations. We train random forest regression model or CNN model for EEG data, and then we now next one is Chevy summary plots, which we use to interpret our results from our regression model. So as you may know, that the regression model that we train is usually interpreted as a sort of a black box, which is basically we don't know what happened inside them. So we attempt to decipher the black box with Shipley summary plots. And lastly, we also use deep learning to train EEG data. So now is all our talking. So we will move straight to the activities, which will help you to go through our process of Life to Well and how we make the process from scratch. So maybe Mr. Ahmed, you want to continue with the activities.
Hi everyone. So we're gonna present you with 3 activities, which are intended to give you a little bit of hands-on to have a better sense of what our process was in creating this project. Let me shift this over to presentation view. There we go. All right. So as we mentioned before, this project involves data collection from 3 sources. One is data about your local microclimate. The other is biometric data, which we collected using smartwatches. And the third is the EEG data. Just now you saw the headset. So in order to collect microclimate data, we actually designed our own custom, An and Tuan designed their own custom sensor. Let me go through a little bit more about what exactly is involved in this. What you're seeing in my hand is sort of the final product, something which is nice and compact and wearable. If you can see in my hand, it's actually got clips so that you can attach it to your belt. That was the way they did the design, so it would be comfortable to wear with their school uniforms in particular. Let me go through what's inside. So we've got a microcontroller. We use ESP8266, specifically Node MCU. We have a CO2 temperature and humidity sensor. We have a PM2.5 sensor to detect the dust level. We have a barometric pressure sensor, sound sensor, and then we have a hub to help us with all the wiring, and an external power source. Oh, you might have noticed that there's a USB cable dangling from this unit. That's because the power source is not inside the box itself. You have to connect it to like a power bank, which can be in your bag or like in your pocket or anything like that. So what we'd like to spend a few minutes doing right now is to do, let me go through some of the design considerations first. So you can see here, this is a top-down view of how the sensors and electronics components are arranged. There's a couple of important factors. First important factor is heat management. We have to make sure that, for example, the temperature sensor isn't being heated by the microcontroller controller or by another component so that the temperature we are sensing is representative of the outside temperature, not of the temperature inside the box itself. Another consideration is that while most of the sensors need to be exposed to the outside environment, maybe I should take this off. Yeah, because otherwise you're just recording whatever variables are in the box. So you need holes for the different sensors. At the same time, this is a wearable device, so it needs to be somewhat resistant to physical damage. It should be, yeah, should not be so sensitive that if you knock into it, all the connections come loose. And it's Singapore, it rains a lot, so it needs to be, you need to find some way to weatherproof it, basically. And of course, it has to be fairly small so that you can actually wear it. So, we'd like to go through a bit of a design exercise, an interactive one. I think everyone here has at least their own phones as devices. We also have some papers and pencils and some materials. So you can decide whether you want to sketch out your own design on paper, in which case you can get some papers from us, or you can scan this QR code. There's like a Google Jam board which you can use to just sketch online. So the idea here, you can think about things like, if you were going to design a wearable sensor, where would you want to wear it? Like if you don't want to put it on your belt, where would be another good location? Would you want to wear it on your arm? Would you want to connect it to a hat if you wear hats? So it's pretty open, and the nice thing about this kind of DIY design is that we like the fact that people can change the design based on their own needs, basically. So let's try this out. Yeah, you've got the link there. And if anyone wants materials, just come up to us. We can pass you whatever you're interested in using. So let's spend about, until 11:30 on this, and then we'll switch over to the next activity. So it's currently 11:25. So we'll take about 5 minutes on this.
Probably for this design, you may want to consider maybe sometimes maybe the position on the participant waist is not the best one to put it. Maybe you can put it as a sort of a smartwatch, maybe, or as maybe a hat. Can be also acceptable as well. And another consideration maybe you want to consider is where to design the prototype so that the components take the least space as possible. So as this is sort of a wearable devices, we want it to be as small as possible to not basically create any discomfort for the user, as well as to maybe any. So yeah, so for the waterproof, there must be a sort of a layer that cover the sensor face, right? So how to make a layer that sort of is not too thick, that is will affect the recording, but thick enough to make the device maybe a bit resistant to impact or to rain. Tuan, do you have any advice?
Well, I think one way you can do it is actually make, for example, if you want to expose a light sensor to measure light intensity, for example, you might just want to place a thin layer of tape or clear materials over it, such that in a way it doesn't really affect the light intensity that is shown upon the sensor. And in some cases where in some cases where the sensors are not in contact with the environment, for example, you can actually have greater insulation against the environment so that it can protect the sensor. Yeah, so basically those are some of the recommendations and some modifications. We think that it can suit your need in creating your own wearables.
Okay, so
So yeah, just taking a look at the whiteboard. I think there's different frames, so people might be designing on others. You didn't have to remove, but whoever did the design just now, I think someone was conceptualizing something which looked more like a watch. I can share something. There are different designs of sensors available online, but the components we use are, it's one of the limiting factors. So what I'm holding up right now is one of the bigger components. It's actually the CO2 sensor. You can see it's a black block with a blue backing. There are other CO2 sensors available online with different sizes, but roughly you'll run into sizes like this. The dust sensor is also similar in size. Thankfully, the microcontroller is fairly small. This isn't the exact model of ESP8266 that we used, but they're all around the same size. And yeah, they all need to be crammed together. It would be possible to do something which is on your wrist, but it will be quite a bit bigger than a watch. All right. Let's move. Oh, we have a question. Yeah. That's a very good question. So basically, if I understand correctly, your question is, do we need to have all the sensors in our own unit, or can we use some of the readings which are collected from public data sources around Singapore? Do you want to? Okay. Yeah.
The thing is, the reason why we specifically use the word microclimate, because it's a very specific climatic condition around the user, right? So it changes rapidly from one place to another. For example, if you're in an air conditioned room, and of course this place can be much colder than outside, which is below the hot sun. And carbon dioxide concentration is, of course, no exception. Maybe in an air-conditioned room, you would expect the carbon dioxide concentration to be a bit higher due to the aircon. Or if you're in maybe a jungle, perhaps, then maybe the concentration is not too much high. Or when you're near a construction, the carbon dioxide concentration may be much higher than normal. This change in carbon dioxide concentration may affect our mental and physical health, as we will show you in the last activity. Yes, thank you.
So we'll move on to the next activity now. So yeah,
okay.
I'll hand over.
Okay, so the next activity is to interpret EEG results. So as you know, we measure our EEG results with our headset, but to make this recording meaningful, we need to be able to interpret it, or we need to be able to get some useful information from it. So of course, this is just a very simple simulation of our process. Of course, we will have to continue from these results to basically to figure out how the microclimate condition affect our EEG data. So this one is just very simple. So this one helps us to determine whether or not the microclimate factors actually affect our mental state. So we want to determine whether or not there is any correlation at all from the environment to our EEG data. So we'll start from next slide. Okay. So there's actually 9 main periods in our data, each period with differing environmental factors. For example, there will be a period where the door is closed, so maybe it's a bit more suffocating, or there will be a period where the light is off, for example, which make it darker, and for some of the participants, they may feel discomfort from the fact that they have to work a specific task in a dark room. And for some of the period, there is the aircon is on, for some is off. So there's a change in temperature. So these changing environmental factors may lead to the fact that the participant may feel comfort or discomfort mentally and physically. And we want to determine whether or not the discomfort from the changing environmental factors impact the EEG measure from our data. Now, first we have to have maybe a feel of how the participant feel when there's changing environmental factors using self-reported mental and physical state. So the as you can see on the score over here, which is rated from 1 to 10, the participant feel most comfortable in period 1 and periods 7, 8, and 9. And they feel most discomfort in period 4, 5, and 6. And maybe next. Okay, so our EEG data that we collected will be then processed into different features, non-linear features, which is basically so a sort of common features that you may know is, of course, the mean, the average, maximum, and minimum. So those are very common features. Now we want to extract features that are usually used for these type of measurement or these type of tests, which are the trended fluctuation analysis, approximate and sample entropy, and then we perform ANOVA tests on those features to compare between the period. So now I would like to explain what the ANOVA test mean. Maybe next slide. Okay, so an ANOVA test is basically to measure or not whether or not the range of the features between the two periods are similar or not, which means that to determine whether or not the EEG signal between the two periods are similar or not similar. So for example, you can see that, so to determine whether or not it's similar or not, we based on p-values, which is basically values as have a maximum of 1, means that the range of features are the same. So for example, when we compare 1 to 1 is of course 1, which means that the data, EEG data in period 1 is the same as the EEG data in period 1 because it's the same data set. So if the value is high, for example, 1 and 7, this is high, which means that the EEG data are very similar, which means that the participant may feel very similar between the periods. So it is either discomfort or concentration or attentiveness is very similar for the two periods, which means that, so if there is any effect between the environmental factors to our mental state, then there will be a correlation between the periods that has the same environmental factors, as well as the same p-value. So high p-value when compared 1 to 7. So low p-values, of course, means the reverse, which means that the two periods are very different. So this means that there's a drastic change in our EEG signal between the two periods. For example, when it's 0, for example, 1 and 5 for this one, which means that period 1 and period 5 has no similar EEG sort of signal, which means that the participant feel very different when compared period 1 and period 5. So next slide, please. So this is our, so as you can see, this is our procedure here. And for example, for period 1, we have got the light is on, and period 2, there's the lights on and doors open, but the aircon is off. So based on this one, we can see that there's changing environmental factors throughout period 1 and 9. So if there is an influence of the environment to our mental state, there should be a correlation between this and our EEG signal to see if there's any, to see if the changing in the period leads to any similar p-values, high p-values, when comparing the two similar period with the environmental signal. So with all this information, what can be interpreted from the table, from a given table, as well as what you think is the most comfortable period for the participants based on these signal, based on these table, as well as what environmental factors that impact the participants' comfort level the most. So maybe I will give you maybe 1 or 2 minutes to look through all the table to see if you can interpret anything from the tables, and what maybe and answer some of this question as well.
The top left section is actually showing you the experimental setup. So the periods from 1 to 9, each represents a period of 5 minutes. And the participants were doing a set of tasks, the same task throughout the whole time, basically. It's just that we change the environmental conditions every 5 minutes. So for example, period 1, is it the door is closed? Yeah, period 1, door is closed, light is on. Period 2, door is open. Period 3, the light is off, and then so on. But yeah, you can see the changes listed. And for the self-reported data, in terms of the numbers, basically, high is good. High means they feel better, basically, for the self-reported mental state and physical state.
Okay, so any of you have any interpretation or anything yet you want to tell us about? What can you say from these? What can you conclude from these tables? Any of you have any idea or any conclusion that you made up about the table? Okay, so maybe I would just give you one clue. Maybe pay attention to the one that's sort of more red than others. So, which means that they are similar, right? Maybe we can just check if the period 1 and period 7 are similar. So we have to check that with the table over in here. Maybe our setup. We see that period 1 and period 7, although they are different in terms of like aircon and door opening or closing, but they are very similar in the fact that both of them have the light on. And this is and it's interesting to see that when the light's on, it seems that period 1 and period 7, 8, and 9 are very similar, because as you can see in the data over here, 1 is very similar to 7, 8, 9. 7 is very similar to 8 and 9, which means that there are very high similarity between 1, 7, 8, and 9. So as you can see here, it's correlated with the fact that all of these 1, 7, 8, and 9 all have the lights on, which means that the participant feel very comfortable and are very concentrated on a task when the light is on. And it shows in both in our self-report data as well as the result of our EEG data, which means that there is a correlation between the participant, how the participant feel with the environmental factors. Any of you have any conclusion, any other conclusion that you can make up? Okay, yes. Yes? Yes. Yes, they are working like very simple geographical task, which is basically to calculate the mean of the data and determining what is the best location to grow like different type of food, example. And so yes, they will have to repeat the same task 1 time and 2 times to determine whether or not there is any changes, just based on environment factors, because the task will be the same throughout. Yes. Yes, having the lights off seems to not only decrease their comfort in the self-reported data, but as you can see in the ANOVA results as well, 4, 5, and 6 actually have very high correlation, which means that yes, when the lights off, there is certain discomfort that the participant feel, and it's also confirmed to us, particularly that our model does mean something. There's certain correlation between the environment factors. In this time, is the light, and to our EEG data, which means that we can proceed with the data processing as well as interpretation and regression model, etc. So yes, so this is our second activities, and this is basically just the start of how we deal with our EEG data. So next, I will invite Tuan to host the third activities.
Right, so ultimately, our goal in this project is to find out the effect of the microclimate on our well-being, both in our physical health and our mental health. So after collecting and comparing of the preliminary data that in the step that Anne has mentioned before, we now use those data and train a machine learning model. And after training the machine learning model, we use the Shipley summary plot to interpret the results. So as you can see on your right, here's a Shipley summary plot. In this case, is a model for our heart rate. So in Shipley summary plot, the variables are ranked in descending order of importance. So this is the feature importance. For example, as you can see on the left of the diagram, we have the CO2 underscore, the sound underscore, CO2, and so on. And based on the order, we can say that the concentration, carbon dioxide concentration is more important than sound, more significant than sound in affecting our heart rate. So and furthermore, right, we do some simple exponential smoothing on the models. So each environmental feature had its smooth counterpart, which you may wonder why we have CO2 underscore and CO2 and sound underscore, dust underscore, as well as the normal variable without the underscore. So it's derived from the values of the feature from the preceding hours, with older values being exponentially less important than the current value. So for example, for the feature ft, right, we have ft minus 1, which is directly right before it. ft minus 2 is directly before ft minus 1, affecting the current ft, but ft minus 1 will be more important to ft than ft minus 2, ft minus 3, and so on. And you may be wondering what are the numbers 2021, 17, 19, 16 means. So the features, the numbers from 0 to 23 represent the hours of the date that the data points were taken. While number 31 to 37 represents the day of the week from Monday to Sunday. And these features are binaries, so 1 or high means that it is true, or 0 or low means false. So for example, if a data point was recorded at 6 a.m. on a Monday, then 6 and 31 would be 1, and the remaining binary features would be 0. And finally, the color, as you can see from the scale right here, a blue color would mean the low, a low value of the observation, and the red color or the dark pink color would mean a high value of that observation. And in this way, right, Shipley summary plots combine the feature importance with the feature effects, which is how the variables such as carbon dioxide concentration, sound, dust, and so on affects our heart rate, and as well as the magnitude, which how it affects. Okay, so from this, what can you interpret from the figure? Having all of the points with different colors and the Shipley value, and as well as the different feature importance. So maybe I will give you please have 1 or 2 minutes to think about this. Okay, so maybe I'll just answer that question as well. So as you can see, the middle line right in the middle is the normal or the average value of that feature. So for example, for carbon dioxide concentration is 580 parts per million. Towards the right of the axis, it will be a value greater than 580 parts per million, and towards the left of the vertical axis will be less than 580 parts per million. And similarly, we have calculated other values for sound and dust and temperature as well. So as you can see, in order of descending importance, heart rate is affected the most by carbon dioxide concentration, followed by ambient sound, then ambient temperature, dust concentration, and air pressure. So for the magnitude of how these feature affects our heart rate, carbon dioxide concentration, if it is lower than 580 parts per million, as you can see by to the left side of the middle vertical axis, can either lower or higher heart rate. It can lead to lower or higher heart rate. For ambient sound, if it's higher than 10, which is our calculated value, it is higher. It leads to higher heart rate. And in terms of other factors, inhaled dust, or otherwise PM2.5, it increases stress response, and in turn the inflammation of lungs and narrowing airways, and finally it increased the heart rate, which is similar to what we have found out in the Shipley summary plot as well. And this is research done by Breacher in 1999, which is congruent to our findings. And one more interesting aspect to point out as well is that heart rate usually decreases at night, and that is when we sleep. Right. Thank you for listening. This is the end of our presentation. If you want to find out more about our work and our progress, then here's the QR code and our link to Dr. Lim's website. Right. Thank you so much.
Okay, so another round of applause for them. Okay, so is there any Q&A? Cool. Anyone have any questions they want to shout out right now? Just shout it out. I'll repeat. I'm gonna look through like the Slido. Slido is completely empty. Oh yeah, so just shout it out. So I'm repeating the question. So like, what's the aim of the research?
Actually, the thing about our research is just stem from curiosity. We want to learn more how the environment affects our mental and physical health. It's actually started there. So we just continue to build our project as we goes on, and currently we want to bring our project to maybe for school students to use to learn how the environment affects their concentration to better their studies, which is something that impacts us as well. So yeah, we want to develop this project to help our community as well as our friends, and as well as to raise awareness on how the environment may affect our well-being. Yes.
Right. So is there any more questions? Yeah, go. Just ask. Sorry, what do you ask? Cool.
What was the result after doing this project? Like, how did you find it? Whether it was like helpful? Like, what was your experience after the completing of the project?
So repeating the question will be, I guess, how would be the experience of the research after completing the research?
How do you felt it? It was great, awesome.
Yeah, we found it very meaningful for us. We learned about like the factors that we overlook every day. We learned about how important our environment is to our mental and physical health, as well as we learn a lot of technical stuff like machine learning, hardware, software, and it's helped us to galvanize our path in doing science research as well. So it's basically opened the door for us in the world of science research, as well as it's helped us to learn a lot of things about ourselves we all know. And yeah, overall, it's a very meaningful and exciting experience, I would say, yes.
Cool. Are there any more questions? If not, let's give another round of applause to this team. Okay, so, I'll let them pack up. I'll entertain you for a bit. But before that, I have a bit of announcement to make, which one is, so for the next talk, give me a while. For the next talk would be by Kenny Shen, but fortunately he cannot make it, so we'll be actually merging the talk from track 1, which is about cryptography, which is a day in cybersecurity. So to make more space for people from track 1, can I ask for everyone from the back to move forward? Alright, just move forward. So yeah, so like temporarily there will not be track 1. Everyone will be just in track 0. Just move forward. Cool. Okay, guys, I'm banning the back row. There is seats in front. All of you who are sitting on the benches, move in front. I'm staring at you guys. Just move in front. There will be people who are in the room will be coming out later. You need to make space for them. Just move in front. Cool. Okay, fine. You know what? Effort made. I'll applaud that. But you know, there's still a lot of space in front. Cool. So anyways, right, just making a poll, because there's still like a bit of time before the next, like, is it like a thing for software engineers to do bouldering? Because I realize like more and more like software engineers boulder, like rock climb. I guess this is not the audience. Also, there's no audience anymore. Yeah, they're slowly moving out, so. You want to do an announcement? Go ahead.
Testing. Yeah.
So something about
Just jump in. Yeah, we can go and see. I'll just ask you to set up. All right, hi everyone once again. This is now combined track of track 0 and track 1. So please join us, make yourself comfortable. We will start in about 5 minutes as our next speaker is setting up. Okay, as we are all preparing for our next talk, we'd like to call out that we have a lot of seats in front. Please don't make our speakers feel very empty, right? You guys are not shy. There's a lot of space here. We are all one big community together, right? And just a gentle reminder, right? We have some announcements to make in the meantime.
All right, some gentle announcements for everyone. I think for everyone who is going for the Barcamp talks at the Barcamp track, there's a voting round, and I think the voting round has started. So please start voting for the Barcamp talks, and then we'll probably ask Pritam if he's around to make an announcement for the talks before we start the second half. And also some gentle administrative announcements about the pantry area. Please make sure that the empty boxes are stacked up nice, and please make the general area clean lah. Be considerate and clean after yourselves. Thank you.
Hi, I'm enforcing this again. I'm banning the benches. Everyone on the benches, come down. Sit on the chairs. Come down. Okay, yes.
Yeah, hi everyone.
Thank you.
I will feel very empty seeing like there's so much empty spots in front of me. Please join us. There's a lot of spaces here. Don't be shy. No one will eat you up, right? I'm sure the speakers won't, right? Husband won't do that. Just join us here. Thanks, Joseph, for being here.
The last one banned already. No one sitting there. Okay, for those coming from track 1, please feel free to move to the left side of the room. Don't crowd around this area. Don't crowd around the right side.
Yep. Please don't crowd at the door. People need to come in. Please move in. Please come sit around here, please, everyone. We're going to start very shortly. Right. And in case you guys are taking photos during the event, please share them on social media. Tell your friends how amazing you have had today, the experience. And hashtag. Anyone remember the hashtag? I hear only noise. What's the hashtag? It's GeekcampSG, isn't it?
I think it's GeekcampSG.
Yeah, it's hashtag GeekcampSG, right? Make sure you share your experiences. Who's having fun so far? All right, great. I love to see the hands. But come on, is it just all? Who's having fun so far? Awesome. Should we do it again next year? Really, that didn't sound convincing at all. Should we not do this next year then,
Yeah, let's just go back to like Gather Town or something, right?
Would you prefer Gather Town or in-person events?
Thank you.
That's better. So who's excited today? I'm still feeling the lackluster energy and I'm still seeing empty spots. That doesn't really help. So please, as we are all about to begin our next speaker, I'd like to just call for everyone to just come to the front, join us over here, lots of spaces. Right, and please do also share all your pictures, your medias on social media. Hashtag GeekcampSG. That's right, GeekcampSG. Right, and of course, once again, a huge call out to all our sponsors for today. Right, of course, our venue sponsors, SP Digital, we have Cake DeFi, I'm Token, and ProLife. Thank you so much for all your support for making this event possible, and for, of course, all the people who donated to make this event and to make it a successful one. Okay, so are we ready to begin or are we not? Okay, who's ready for the next speaker? No one is? Hazwan, are you ready? Oh, he's still setting up, okay. No worries. Okay, as we are waiting for Hazwan to set up, right, I just want to call that our next speaker, Hazwan. Right, I'm sure many of you may not find him unfamiliar. In fact, it's not his first time speaking at GeekCamp. He has been with us for a long time, and I understand that the reason why he's here with us today is because when he came for the previous GeekCamp, many people was asking him about, hey, what's it like to be in cybersecurity, right? So how many of you here are interested in cybersecurity? Oh, what? Only like 5%? Really? So the rest is what, go home? No, just kidding. Come on, I'm sure there's more, right? Yeah. Okay, who is not interested in cybersecurity? Wait, what? The same people are raising their hands. I'm confused. What's going on? Okay, I'm sure you guys are messing with me, but you know what? I'll let you guys go this time around. Okay, so our next speaker, he's going to tell us a little bit more about cybersecurity, a day in the life inside the blue team. Right, it's pretty cool, right? Like, as we all know, cybersecurity is about this cat and mouse game. The bad guys out there, the good guys out there trying to like overtake one another, right? And then of course that's where it gets exciting. So he will tell us a bit more about this experience in the blue team. Right, there might be certain elements of hands-on, if I'm not mistaken, right, Hazwan?
Yeah, so if you go to the Discord, there's a link for a VM you can download to join along.
Yep.
Or you can play around with the VM after the talk, okay?
Yeah, so as we are waiting, let's give everyone some time. There is a link on Discord. I call it once again, in case you want the hands-on experience, right, you have your laptops with you, that's great. Go to the Discord for this talk, right, and you can definitely download the VM, that's what Hazwan has shared. Also, as we go along the sessions, if you have any questions, I'm sure you have, right, it's an amazing topic. If you have any questions, right, post that in the Slido channel, right, we will take the questions right after the talk. So without further ado, it's 12 on the dot right now. I'm not going to steal the thunder again from Hazwan. So ladies and gentlemen, please put together our hands to welcome Hazwan for next topic. A day in the life of cybersecurity.
Okay, can everyone hear me? Sorry, I'm wearing a mask because I have an itchy throat. So just for everyone's safety, I'm wearing a mask. So my name is Hazwan. Currently, I'm working as a senior cybersecurity researcher with Custodio Technologies. So it's a local company. The purpose of this talk is essentially to remove the mysticism of cybersecurity. Okay? A lot of people think that they need to know a lot of things, right, from A to Z before they can jump over. I'm trying to hopefully today show to you that this is not true. There's so many roles, there's so many domains to be filled, and it's just about finding what interests you, right, and then you jump in. All right? So let's begin. So what is cybersecurity? Oops, sorry. So in cybersecurity, right, it's not just one kind of job. It's not just pen testers. It's not just malware analysts, reverse engineers. It's not only about SOC analysts. There's a whole lot of people working together, all right, doing their best in the different domains. So generally, right, we hear things like red team, blue team, all right, this is from the military. But there's actually a few other colors that's come out today. So you have yellow team, who are actually the coders, the engineers. You have the orange team, your secure coders, people who go through your code, making sure you don't do silly things like leaving your encryption key up in GitHub. All right? There's DevSecOps people, if you're around, DevSecOps. Okay? People doing CI/CD. These are your orange team. There's the green team, basically the backbone of everybody. The people who go out, all right, design, put in things like security measures, like your firewall rules, your detection rules, all of these people. And then you have me, blue team, right? I sit there, right, wait for an alert to come in, and I do investigation, right? Easy job, right? easy peasy. Okay, and then there's red team, right? I'm sure you all heard pen tester, bug bounty, things like that. And then there's purple team. So what is purple team, right? So in my day-to-day job, I basically do blue team and purple team. So what happened is that I have colleagues who are on the red team side. They'll run scenarios, and then my job is to catch them, right? So every day we're doing this. They create scenarios, my job is to catch them. They do scenarios, I run and catch them. So that's what purple team is all about. Okay, so we talk about the primary colors. We've got the blue, the defenders. All right, so we deploy, maintain capabilities, monitor the environments, investigate events, response to incidents, right? All the good stuff, all the, basically you sit down, you wait for ticket lah, all right? You have the red team, the breakers, you test for vulnerability, you find potential security issues, you provide security recommendation. Remember, red teamers, if you're red teamers out there, you don't just tell me you found a vulnerability, you're supposed to give me recommendation, if not I don't know how to patch, okay? And then you have the white team, the administrators, okay, the people right in the middle, the people who pay you to do what you do, okay? They get a lot of bad rap, but they're very, very important because they set the direction. They are the ones who ensure compliance. If you have a very bad white team, your boss don't care, chobola no, don't care, anything goes. That's it, good luck to you, okay? So you need a very good core, which is the white team. So if your CEO says, yeah, we need to be secure, then you've got a good white team, all right? So the security triangles, these are just certain things that you keep hearing over and over again, right? So for example, you have CIA, confidentiality, integrity, availability. We just finished a talk on crypto, right? Talk about how crypto ensures confidentiality and integrity, right? So in security, the whole purpose is that we are trying to ensure this triangle exists. Ensure that data is kept confident, the integrity of the data is kept, and when the data needs to be get at, it's available. But there's another triangle, which a lot of people forget about, right? Which is the security, functionality, and usability. A lot of people like to think purely on CIA. But when you look from a bigger point of view, right, the CIA triangle becomes just this small little point. You know why? Because at the end of the day, your customer needs to do their job, right? You agree with me? So if I ban you or I block you from doing certain things that you need to do your job, you're going to hate me, right? How many of you curse and swear your system administrator every day at work? But they're doing their job, you know, right? So there's a fine balance that needs to be held, right? So most of us think, oh, sysadmin, SOC team, this is what they're doing, right? Basically, no, you're not going to be able to do anything. You need to jump a lot of hoops to do things. But I'm sure this is what's going to happen in the long run. I always use this GIF. You all have seen this GIF in all my previous talks, right? You put in a policy, okay, you put in password policy, gets restriction, more restricted, more restricted. All right, user, okay lah, fine lah, I'll live with it, I'll do it. Okay, you put access control. How many using Intune, MDM, MAM, right? Okay, get smaller and smaller and smaller. Then you put DLP some more. Wow, want to send email, cannot bounce back, cannot send email. Right? And then you put all of these controls. You know what the user going to do? They're just going to find a hole and just bypass. And that's what we don't want as security professionals. Okay? So security must be invisible to the end user. Okay? So as security professionals, or if you're going to join us as in security professionals, remember, we must be invisible, okay, to the end user while still providing adequate protection. All right, so that is our mandate, basically, okay? So let's talk about the roles that I'm going to talk about today. So the VM that I provided, we'll do a bit of hands-on covering the kind of skill sets or the kind of day-to-day job that they're doing. You have security analysts, you have network analysts, you have malware analysts or reverse engineers, right? You got forensic investigator, which is where I fall under, and then you have security researchers, which I also fall under that, all right? So let me jump over into the VM. Actually, I am inside the VM. Wait a minute. Let me exit out from my presentation. Huzzah. So let's talk about the challenges. So if you open, you'll see there's challenges. All right. So challenge 1, let's think about security analysts. All right. So we normally don't go in blind lah. Hopefully you don't go in blind. So usually we'll have certain things like this. We'll have intel or first information report or ticket information, right? You don't go in blind. So there's a threat actor against your organization. And the threat actor makes use of malicious documents to gain access to the system, right? Phishing, malicious doc, right? We call them maldocs, right? So as a security analyst, right, you'll usually get a ticket. And then usually you get logs to work with. So let's open up and take a look at what the logs look like. So I'm going to open up this EVTX file, which is basically the list of logs. So how many events do I have to work with? 46,451. Brilliant, small number, no problem, easy. Okay? So as a security analyst, right, what is the first thing I'm going to do? Based on the information given to me. So I'm going to open this question to the floor. You know it's a malicious document, right? Your first thought would be, someone has to open the document, right? So what would you search for inside of these logs? Any keywords? Any guess? What's the most common thing you use to open document? Wow, winword.exe, brilliant. So what we're going to do is, we're going to find, so I'm going to actually filter first. So what we're going to do is that at the start, right, we can already lower the kind of event ID. So as you join and you learn to events. Okay, so in my case, I'm going to look for 4688, which means process creation, means something started in the computer, right? So if you're using Sysmon, this will be Sysmon 1, right? Sysmon event 1, we call it Sysmon event 1. You click OK. So basically, I just want to filter it, make it lesser, which is not much. It's still 46,000 events. Okay, right? Oh, sorry, it's only 491, brilliant. So I'm going to click Find. I'm going to click WinWord, right? WinWord, I'm going to click Find. Let's see what you can find. Anything brilliant, straight away I find this event, right? So as an analyst, right? All right, Jules, I think this one your bread and butter lah. You see the dash equal, you know what's going on. Yes. Can I zoom in? That's a very good question. Will Microsoft let me zoom in? That is the question. Oh yes, Microsoft allows me to zoom in. Oh yes, brilliant. Okay. So what do you see here? Straight off, you see weird things like bypass. You see exec. Okay, you got encoding. But most interestingly, you have WinWord calling PowerShell. WinWord has no reason to be calling PowerShell. PowerShell is a command line tool. So as an analyst, straight away I see this. Oh, Jose Liao found the issue, right? You can see WinWord, PowerShell. Copy this, go to GCHQ, CyberChef, plug it in, auto decode for you. Brilliant. No need to think so much. Okay? It'll give you the answer. So this is the kind of job as a security analyst will do. And after that, they'll hunt down, okay, what exactly was the document that was open? Right? Things like that. So let's see if I can find what was the document that was open. Okay? No. And here we find the name of the document. Right? So it was a document inside downloads, ipnet.doc. Most importantly, you can see that it is explorer.exe. What does this tell you? It's an explorer process, right? So that means the user knowingly clicked the thing. So you can go and scold the person lah. Why you go and click this? You know malicious, right? Got pop-up, right? Why you still click? Okay? So that's what a security analyst do lah. We figure out all of these events, we try to build back the chain of events, and then write a report. Okay? So if you have downloaded a VM, try to run through. There's a lot of other events inside here. Was there any call out? All those kind of things. It's all captured inside here that you can play with. All right, so that is challenge 1 completed. So that's about security analysts, right? Understanding what is going on in the endpoint, trying to figure out what is the story you can tell. How did the attacker, trying to rebuild the steps of the attacker. Okay, challenge number 2, we're going to talk about network analysts, right? They are completely different breed. Okay, they are able to understand the flows of the packets. They know how, okay, what is the thing is supposed to come, right? So let's take a look at this. So let's take a look at the Intel first. The threat actor, having gained access to your machine, will exfiltrate files using FTP. Simple, simple. So straight away, you're hunting for FTP connections, correct? Make sense, right? Intel say FTP. Okay, cool. Okay, I remember FTP, yeah? Wireshark, okay? So Wireshark is what you use to capture. You can use NC, you can use T-Shark, what have you. Let's open this up. Jing, jing. All right. So it's loading the PCAP that was captured. All right. Ooh, it's quite a big PCAP, so must understand, this one already 4 years old. Yes. Anytime before lunch, come on, you can do it. Please don't die.
So Hazwan, while we're waiting, does everyone here know what Wireshark does? Maybe okay, yeah, he's loaded.
Brilliant. Okay, let's do a very quick thing. Let's go to statistics and take a look at the property. How many events do we have? Or how many flows do we have? We have a total of 493658 packets. Okay lah, easy lah, small amount, no problem. Okay, so what did the Intel say? FTP, correct? So Wireshark has this beautiful thing called filters, right? So you can filter for FTP. Let's search for FTP. Okay. Scanning, 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 checking, still scanning, maybe, anytime soon. And lunch. No, I wish it was lunch. And it says no FTP. Jose Liao, false case, close, finish. No, you don't do that. Okay, if you got a phone with you, right, you go and quickly do a quick Google search. I mean, this is part of the job as a security analyst, you know how to Google very fast. What are the different modes that FTP can send files? They got multiple modes. All right. So if you're looking for protocol FTP, nothing. FTP data, nothing. Okay. It means he's not sending it as a file. He's sending it as a stream. That means it's over TCP. Because it doesn't mean the server, the malicious C2 server is listening as an FTP server. Doesn't mean you have to use FTP to send to it, no. Okay, so let's see whether we can hunt for it. So I'm going to hunt for TCP. Okay, so it's going to scan. Scan, 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 scan. Scan, scan some more. Okay. Great, I got a lot of TCP. I don't want HTTP, I don't want all this because I don't think it's relevant. It's definitely going to be HTTP because it's a FTP server. So what I'm going to do is I'm going to filter it even more. I'm going to say, and not TLS, which will take away for me all the HTTP as well. Filter, filter, filter. So this is what you do, no, as a day-to-day job, no. You will get a huge amount of data, and then you have to figure out which one to find. It's literally every day, every ticket is searching for a needle in a haystack. All right? So now we've gotten it smaller and smaller and smaller. All right? So what can I search for that is common across all FTP connection? Anyone can guess? Okay, let's not talk about FTP. Let's talk about in general, any service. Before I can make use of a service, right, I need to do something first. Connect, right? Login, right? Right? So what is a keyword that FTP servers use so that users can log in? Huh? User lah. I have to give the username using the command user. Right? So let's hunt. Frame contains user. Is it contain or contains? How do I spell this? Correct? Yeah, correct lah. Is that space? No. There is a typo somewhere. Frame. Contain. User. No. It should run. Why are you not running? Frame. Why sharp? Why you are very buggy, huh? Frame contains user. Quotation ma? I don't think so. I've never used quotations. Okay, that's new. The Wireshark update itself while I was sleeping. Ding. Aha, brilliant. Then you will see that there's a lot of noise because some protocol also make use of the word user. So what do? You filter it out. And not frame contains user C or something like that. Was it user set? Yeah, user trace. Ta-da. Go. Run. You know what would be very funny if I open the wrong PCAP? That has happened before. Voila, and we found user anonymous. Okay, I mean this is a very simple attacker lah. They use anonymous account lah. Normally they don't do this lah. They actually have actual keys. Okay, so let's take a look at it. What exactly is being sent, right? We're gonna right click. We're going to follow the TCP stream, and then it's going to load again. Yes, it's a lot of waiting, in cybersecurity. While you wait for the tools to run, right, the attacker already run away already. So it runs. Okay, so we can see exactly what is happening, right? It's sending a file, all right? File called custodio.txt. This is bad. That's the name of my company. I don't know what they stole from us. All right. Then we can find what exactly was sent in the next one. So it's going to run. And what was the content of custodio.txt? You get a content of the file. So what we will normally do, right, what we're going to do is show data not as ASCII. Okay, we'll probably show as raw. Okay, or because we know it's already data that's in text form, right, we'll save this, and then we'll save as the name of that file, custodio.txt, because it's not our evidence, right? So this is what we do. We look at PCAPs, we look at the flow. Sometimes we just look at net flow. We can guess really what's going on, right, whether it's malicious or not, based on how fast, how constant the connection is and how much is being sent through that connection. Okay, so this PCAPs, this is network analyst, right? So this is what a network analyst would do day to day, right? Pretty fun, right? I mean, if you like this, you can always jump in, huh? So number 3, what is number 3? So, based on what you have done, right? You search for your events, you find this malicious exe, right? Then the Intel tells you there's multiple C2s. So what exactly are you going to do with this exe? That's where you take it, then you pass it to your malware analyst team and say, now go and play. Okay? You can give them blind lah, but normally what I would do is, I itchy finger, right? I'm not a malware analyst. I see what I can find, right? Help them out a bit. So most of the things, right, what is the most common tools we use? We use binwalk, we use string, and we use good old grep, right? So what am I going to do? So if I open my terminal, is this the correct terminal? Yeah, this is the correct terminal. So if I open the terminal, hello. Oh, no, please don't do this. Okay. And if I go here, security desktop, challenges, 03, ls. Right? I can run strings on it, right? But if I do that, you'll just get a bunch of gibberish, right? So those who have done malware analysis or do any kind of reverse engineering or any kind of work, right? You will quickly learn that most of the time they are packed, right? So what we can use is try to use things like binwalk or an even advanced version of binwalk called mbar. All right. So what it does is it will try to unpack it into its own constituents. Yeah. So those are intel. So when we say intel, normally we have a special team called threat intelligence. So they'll provide two. C2 stands for command and control. Yeah. So basically, our threat intel team says, oh, potentially is from this group, and this group always like to use multiple IP, so multiple C2s. So we want to confirm whether there's any of the known IPs is embedded inside of this malware. So that's what we're doing, right? Or we want to find what is the features they're doing. Right? Sometimes inside the malware, right, you can figure out what are they trying to hunt. They might be looking for certain documents with certain keywords or certain documents with certain metadata. And that's how we do attribution, right? So we're going to run binwalk. So what binwalk does is then I will export the output of binwalk, all right, into a file. So you'll see that is this file called extractor_strings.txt. So after I run binwalk, I extract all the strings from the binwalk executable, then I put it inside here. So next thing what I'm going to do is I'm going to hunt, okay, for IP address, right? So I can use grep, but I'm on Windows, so I don't have grep. So the closest thing I can do is select string. Select string, and then I can put in the pattern. And then I can put in the IP address pattern, which is 029 123. Then there's a slash dot, and then again 029 pattern 123 slash dot again, right? And then 029 and then 123. So basically this regex, this is your good old regex, right? And then we go and find dot extract. Okay, so we're going to run. You run, you look for anything that looks like an IP address, and hopefully you'll get certain IP addresses, right? Just continue to run, Here we can see all the IP addresses coming already. Actually, I can pause it already. So these are the IP addresses that it found. So probably what I'm going to do, I'm going to take all these IP addresses, give to reverse malware analyst team and say, hey, you hunt for this. See what as a function is calling for this. And then you can call the network team, right? The network analyst say, hey, you hunt for this IP address for me. Was there any connection or any PCAP or not for this IP address? And then you start piecing all the things together. So the thing about cybersecurity, right? You're not supposed to know everything, right? But you need to know who to ask to do the thing, right? That's the thing about cybersecurity, okay? Then you can ask the security analyst doing endpoint, hey, you look for events doing a call out to this IP address, right? So this is what the different roles are doing. And it's all about the sum of everything, right? So this is what the malware analyst team would do, right? So that's challenge number 3. Challenge number 4 is my area, endpoint investigation or endpoint forensics. Okay, so my background is in forensics. All right, so this is what I do. So there is an intel. Again, there's intel. The threat actor immediately deletes the file containing data to be extracted. So it already sent the file. It deletes, so you cannot find, right? So how do I identify that there is these files that have been deleted? Anyone can guess? So you see all those fancy files, right? You see MFT, you see J files and things like that. These are file system files. Sounds weird saying a file system file. Okay? So the J file tells me whatever has ever happened to the file system. Creation of file, modification of file, renaming of file, deletion of file. J file stands for journal. Okay? So these are one of the files that we as investigators will hunt for. All right? So that's what I'm going to do now. So I'm going to open my tools. Okay? I'm going to look for Timeline Explorer. I'm going to open Timeline Explorer. And then I'm going to load into it this CSV file that I've already prepared. Right? Normally we have to prepare the data because normally they are in blobs. So we use other tools to extract the data into a human readable form. Okay? So I'm going to click File, I'm going to click Open, and then I'm going to open Desktop, then go Challenges, number 4, and then I'm going to open. Okay, brilliant. Let's go. Again, the file is a lot. The J file is basically the entire history of your file system. Yes, Mr. Roland, what can I do for you? Oh, the CSV file is the extraction of the J file. There's a tool you can use. So we call it, there's tools by Eric Zimmerman. He's with Kroll, he created a lot of tools. So we have tools like MFT command, that you can feed the J file, you can feed the MFT file, SDS files, and then you can create a CSV files, right? So, again, let's start hunting. So what am I going to hunt for? I'm going to hunt for, here, update reasons, right? Rename, new name, close, file create, file create. This is all the history of anything that has ever happened inside of your computer. In terms of file. It can be very large, right? So, here's the question I'm going to ask you. If I'm the attacker, I create a file, I send the file, I delete the file. What is the pattern I'm hunting for? What is the pattern of user reasons I'm hunting for? Anyone has any idea? Oh, my phone. Why is my phone closed? Anyone has any idea? So what I'm going to do is, I'm going to search for very particular update reasons, right? So I know it's a txt file, correct? So let's do that filter first. Extensions, all right? And then I'm going to put txt inside, okay? .txt. So it's going to run. So now I filtered out all the files. Okay, I'm going to click Find. Dun, dun, dun. Oh wait, I'm supposed to click search option. Yeah, it's filter, mix, yeah, okay, brilliant. All right, so the next thing I'm going to search for is, did I spell extensions wrongly? Oh, it's extension, not extensions. Silly sausage. Okay, so I've now gotten that. Next thing I'm going to do is, I'm going to search for, what is it I'm going to search for? I'm going to look for update reasons. Reasons, right? Create. And then I'm going to find for these events. All right? So you have txt, you have file create. What I'm looking for is create followed by immediate deletion. Right? It makes sense, right? I create, I append data, I delete. So it will be, instead of a normal file structure. So if you open a Word document, right, there will be this entry. Then you work on it, right? Take note, until you press save, everything is in memory. So you will not have an append data event inside of your log. So you can know it's an actual user because it's quite far from each other. All right? So what I'm going to find now is, I'm going to find update reasons. Oh dear, silly. And then I'm going to find delete. And then we go find. Bingo. So we have a file create, we have a data, and then we have immediately deletion. So we can find all these files. So for example, 4.txt, right? System.32, 5, 6, 7, 8, right? Because what the attacker is doing is that he's looking for multiple files, write, send, delete. Find another file of interest, write, send, delete. So this is the kind of patterns us as investigators will find, right? So what's happening here is that there's a scheduled task, all right? So that means every few minutes it'll run, every few minutes it'll run. We'll search for files, send, search for files, send. All right, so this is what a forensics investigator might do. So lastly is researcher. So what does a researcher do? Right? A researcher, like me, if I can open it. Oh, no, wrong. This is what I do. All right? So my day-to-day job, right, is I'm a product researcher. So basically whatever I do research, it has to be productized. So what I do is, I understand how the different types of teams are working. And then we try to search for a way, can I put, oh, this team gives me this data, this team gives me this data, this team gives me data. How do I stitch it? So that when I show it to the bosses, right, let's say a company cannot hack. CEO wants to know, hey, how they get in. I want the whole story. So that's what we do. So we try to find situations like this. So this is basically the scenario that we had. We have a process opening a file, but the process can open multiple files. So which one is the malicious file, right? Then the process spun off another process. This process can spin off other processes legitimately, right? So my job is try to figure out how do I clean all the data to build this chain. And this is what, if we worked on the data, you can find it. So this is actually the attack story of, oops, zoom to fit. Where are you? Where are you? Oh no. Let me reset this thing. So this is actually the entire chain, right? From opening the file, right, to the UAC bypass, to calling down and actually installing the thing. And then this is the part that was actually creating all of those text files and sending it out. So this is basically what I do. But there's different types of research out there, right? You can find vulnerabilities in cars. You can find vulnerabilities in IoT device. You can find vulnerabilities in frameworks, right? In APIs and things like that, right? So that is what you can do, right? There's so many domains, right? So at the end of the day, people will ask, is cybersecurity easy or is it hard? My answer to that is cybersecurity is easy. It's easy. The hard part is finding what you want to do, right? Because each of us have certain things that we like to do, certain things we're good at, right? So do it, because at the end of the day, it's just a collective effort, right? So don't be afraid, right? If you are doing sysadmin, you're doing a coding, you can jump, do a secure coder, right? You're from network, you're from system, you can jump, network analysis, endpoint analysis. I guarantee you, any sysadmin here knows the Windows system better than me. Because you work with it inside out every day. And you have to do it with a lot of quirks and edge cases, right? You already have the skill set. So don't be scared, just jump. All right, so that's actually the end of my presentation. You all have any questions for me?
Wow, that was really, really insightful, right? Diving deep into his day of a life of like being a SOC analyst. So we have about 30 minutes actually to have some Q&A for this session.
Wait, 30 minutes?
Yeah, actually, yeah. We do have
too
some.
Fast,
This ends around, yeah, we have some time. So no worries. We have actually some questions already posted online. I'm just trying to find it.
I foresee this will break down into another rant again.
Nah, no worries. Okay. Anyway, before I go to the questions online, right, I'd like to give everyone that's here an opportunity. Who wants to ask any questions to Hazwan? Anyone? Otherwise, let me get started with the online questions for now. Right. So the first question, Hazwan, right? How do companies usually do log preservation? Since usually we talk about logs being really, really huge in size, are there any tricks that you can share on how we can compress or selectively drop this data storage?
Okay, so what we call, right, we call this SIM optimization problem. Okay? So I had to work with a potential client. So when we were talking to them at the start, right, they say, so yes, what data can you give me to work with? Say no data. Then I say, okay, can I tap into your network to capture data? Cannot tap into my network. Data diet also cannot. So what you want me to do? I don't know. That's the challenge for you. Find out how to create data. I cannot do investigation. I cannot magic data from the ether and then suddenly I got data. So about data retention, it really is about fine-tuning. You need to know about your threat landscape. You need to know what is the kind of security issues that you will face as an organization. And then you be selective, right? I can say to you, oh, I need 5156, right? Your SIM engineer will tell you, crazy 5156. For those who don't know what 5156 is, anytime your computer does a connection, a 5156 event turns on. The mere act of turning on Windows machine, you know how many 5156 events there are? Just turning it on, no. And then you browse the web. Habis. You turn on VS Code, so many telemetry go out. Right? So data retention, there's two ways. Generally, what SIM engineers will do is we'll have hot storage, warm storage, and cold storage. Right? Then it depends on your retention. You can have up to, let's say if you work with Chronicle, Google. Their hot storage is 1 year. Google, you got a lot of storage, right? 1 year. Then you move it to warm storage. And then they move it to cold storage. But then again, in my previous line, when I was in SOC, our field engineers had to go down to client almost every month to put in new hard disks. Because there's so much data being generated. And then you get new novel attacks coming out, right? Or then you need to track this new event, habis. So it's really a fine balance. Do you need this data? What is the chances of you getting hit? 1%, 0.001, what is your risk appetite? If you say, never mind, I can use other data to try and patch the hole. Okay, fine, then you don't need to take. That's the kind of, you have to walk it through your threat landscape.
Cool. Wow. Okay. That's awesome. The second question we have from Anonymous Online. Okay, it's going to be this. So, Hazwan, what do you recommend for log searching? Right, as you shared earlier, right, as part of your day-to-day as well, right? Apart from log searching and the tools, you also spend a lot of time waiting for the results to come out.
Correct.
So, what do you do in the meantime? Like, do you think about what to do for lunch? Will you share a bit of insights on that?
Always think about lunch. No, it really depends. What do you mean by log searching? Are you trying to do threat hunting? Right? There's a lot of things you can do. Your SIM, your LMS, right, has to do a lot of heavy lifting for you. So it really is up to your SIM engineer. If your SIM engineer doesn't do things properly, he doesn't tune it properly, right? Okay, let's say it very simply. There is this company out there that creates security events for their products. Okay? But there's an issue. Their product stacks have multiple products. Each of them have their own events. Okay? Each of them have their own naming scheme. So the field name for one event doesn't match with another event. Right? So this is where you need to make friends with your SIM engineer, because they can help you with this normalization problem. For me, I love ELK because they have ECS, Elastic Common Schema. And you can write a lot of rules. You can put in Sigma rules into it to hunt. So that's what you can do. Right?
All right. Any further questions for Hazwan? Oh, yes. Sorry.
So basically, like you love to be called as a hacker.
Are we allowed to be called as hackers?
Okay. Okay.
Okay, so let's. Oh, Roland ran away.
I didn't ask.
Yeah,
Okay.
okay.
Have you tried to hack college or company servers, or have you tried any weird things in your life?
Have I?
Ah.
Oh, are you trying to get me fired, is it? Right.
No,
Okay,
like, hackers do right.
So here's the thing, right? There's this concept of bug bounty. Okay, let's put it that way lah. I'm not a red teamer. I cannot find an XSS vulnerability even if my life depended on it. Okay? If this was a Saw movie, all I had to do was find a cross-site script vulnerability. I would die. Confirm password. Okay, don't bother. I've been a blue teamer from the start. Okay? So if you want to do this, please do it properly. Go through a bug bounty program, all right?
Yeah, hi, thank you. For day one attacks, what is the best security policy?
Day one or day zero?
Zero, okay, zero then.
Day zero, no security. It's called a day zero.
So
what you want me to do?
But definitely there's some way to stop it, right? Like
day zero is called a day zero because there's no way to stop it.
Okay. What's the role of machine learning in this industry now?
So there's a lot of usage of machine learning, AI, and a lot of things. The idea around using AI to catch day zero is, honestly, it's purely heuristic. Right now, it's purely heuristic. So you need to do a proper baseline. But if you try to do heuristics on the company I work for, habis. Correct, habis, You know, my own computer, right, deletes half of my files that I ever created there because of my work. But it's purely heuristics. But then again, any data scientist here, data engineer here, I think you can jump into this conversation. It's only as good as the data and how big of the data set you can do, right? How long you want to train your heuristics? 1 year, 2 years, 3 years? No, not that long, what? If you are working in a company, you're running on project basis. Every project flow different already. Then how? Everything trigger lah. So day zero, right? The thing about day zero is you need people who are proactive. Here's the thing. A lot of the day zeros out there, right, there's already telltale signs. So if you have someone who is very curious, right, they go to forums and then they read out, hey, I always get this bug error on my computer. Then you look, funny leh. Then you hunt for it. Kena not my computer? Because it's these small little signs that tells you that something is going on. So a lot of the day zeros were caught because of this kind of things.
Do we have any other questions for Hazwan? Oh, yes.
Hi. So most of the demos are from the logs and the events created locally or on-prem, I can say, but everything has moved to cloud. So where does the network analyst, malware analyst can come in? Because
you still use the cloud. Okay, for example, if you go through the cloud, let's say AWS. AWS, you can set up the exact same infrastructure of on-prem in the cloud, right? You can set up things, right? You have CloudTrail. You can see all the auditing, what's going on. You can still have endpoint protection inside of your cloud-based VMs. It's still going to push to the SIM. The thing is, right, you cannot think of cloud as a separate entity. Once you do that, habis, right? Whatever you do on-prem, you apply on cloud as best as you can. You can have firewalls on the cloud also. No one is telling you cannot put a firewall. No one's not telling you cannot put a WAF, right? Nobody is saying you cannot put an application firewall there. All this is still generating things, right? So the only difference is where am I pulling this data from? From prem? Oh, it's a VM. Okay lah, I have a secure channel, go in, I put a VM. It's the same thing. The moment you think it's different, right, habis, that's it. Game over. Anything else?
I do have a question for you actually, Hazwan. That's from me, right? So, you know, I think about 0 days is something that is very hard to mitigate against, right? So I'd like to hear from your experience. You know, tell us about a time where your team was not able to maybe detect and mitigate against a 0 day, and how do you guys manage that?
So far, luckily enough, none of our clients found 0 day. But internally, we did find a few lah. Those of you doing security, you can test this out. There is a scenario where if you change certain processes together, after the second or third chain, it becomes invisible. It becomes completely invisible to the logging mechanism. That means the logging mechanism will see this process calling this process calling this process, afterwards, nothing. We thought it was a fluke, we thought it was something weird on our range. So we ran it multiple times, we realized, oh shit, there's some problem. So we wrote up, we sent a ticket up to Microsoft to figure out what's going on. One of the other issues is that it's all about finding quirks. So one of the common rules, right, that you should always have inside of your SIM is to look for outlier. An event that happens one time only. Or events that only happen 2 times, 3 times. So that's how you catch them. Right? I mean, this is a very blunt rule, but it's essentially doing heuristics, right? You're looking for outlier. Right? If this thing happened one time, you flag it, look, hey, it's weird, maybe do a full investigation. It might be nothing, it might be a nothing bugger, might be a misconfiguration, or it might actually be a symptom of a 0 day.
Wow, that's awesome, thank you. All right, so any final questions for Hazwan? Okay, there's a question online I was just told. Let me just take a look at that. All right, so the next question from Anonymous. A lot of anonymous questions today online, but no worries. How do you, sorry, excuse me on that. How do these principles apply to a serverless environment? For example, using ECS, using Lambda, using Cloud Run?
Wow, serverless. Well, luckily so far my client haven't used serverless. But serverless, where is Roland? Roland should be able to answer this. Where is he? He's not here.
Roland calling you, paging you in the house?
For those of you running like serverless and things like that, right? There's still logging available, right? Okay, example, if you're using ECS, you're using Lambda events, right? Your CloudTrail will tell you everything already. Make sure you turn on CloudTrail first, You don't turn on CloudTrail, I cannot help you already, again, right? Your CloudTrail will tell you what process called this ECS to be started, what were the parameters that was sent to this Lambda to run, and what time it ends. Right? And the CloudTrail, right, can even tell you, if you know how to read it, it can even tell you whether an account has been compromised. For example, you have an account that is higher privilege than another account, right? So what they like to do is, they'll take over this account, then they will, in ECS, you can do this thing called, you can delegate your rights, to a lower grade account. So if they're trying to do this to try and hide, right, if you look at the CloudTrail properly, you actually read through the logs properly, right? You can hunt for this. So even if it's serverless doesn't mean no logs. There's still logs. It's whether you want to turn it on and you're willing to pay the storage of the logs. And then whether you have the manpower who knows how to pass these logs.
Thank you. I hope that answers the question, whoever will ask that. All right, so if there are no further questions, which I believe that's almost the case, right? No other further questions. We'd like to please give a round of applause to Hazwan once again for the really insightful demos and hands-on, really in a day in the life of like a security analyst, right? All right, so we also just had 2 very good talks on security. Just wanted to call out that on the Discord, there's actually a CyberSec channel. If you all like to continue the conversations there, please feel free to. And of course, Juice from our previous session, as well as with Hazwan, is going to be around for the rest of the day. So feel free to engage them as well. And because we have much more exciting talks lined up for all of us. Okay, so I believe we are just about to head for lunch. I will hand the time over back to our 2 MCs over there.
Hello, Terrence, we need a mic.
Oh yeah, sorry, I'm holding on to the mic. You have 1 mic, come on.
No, it's just one. We're 2 of us. Okay.
Thanks, Terrence. All right, yeah. So couple of admin announcements again just for lunch. I think first we have a shout out, right, to our very favorite lunch sponsor.
The sponsor for the lunch will be sponsored by I'm Token. They are also hiring, like, so there are posters and banners around. So on the food, it's Understand. It's about 5 minutes to 2, so we're about to start. So if you guys are curious about parsing differential problems, right, because microservices have become more popular in the software landscape, you guys can sit in track 0. But if you guys are more interested into like how databases work and like about like, wow, that's complex, about like append-only hash trees, LSM trees, B+ trees, you guys can go over to track 1, which is over at the Franklin room.
Yeah, that's usually how it works, right?
Just like, what? Kind of want to know the database more than this, eh?
You go for this after you're done. Don't like me, just say.
No, it's not. I don't really.
Also, paging for 3, timekeeper for track 0.
Same deal as this morning, I'm banning the back row. The back row is now banned. Can you guys come forward? There's still a lot of seats. Yeah.
Can sit in front while still safe distancing, don't worry.
Yes. They're all safe distancing from like the speaker.
And on the note of safe distancing, do also remember to put on your masks.
Oh yeah, so yeah, we're trying to like not create
spreading event?
Super spreading event. The 小宝贝 variant is very scary.
Dictionary letters. Also, any more last stragglers that haven't used the toilets, it's on the exit. Just turn left, and there's multiple toilets for you to use.
Cool.
Remember to wash your hands with soap, friends. I have to say, some things need to say.
Some things need to say, right? Like, cause some people will choose not to wash hand with soap, or not to wash hand at all.
No comment.
Understand. So, guys, move forward. Move forward. I'm looking at you guys. Just move forward. Move in front. No need to save distance from the speaker one.
You want to do some crowd work? Let's go and interview the people at the back.
Yeah, just.
Will that, like,
you know what? I'm
make them
gonna go in front and interview you guys.
We have 2 minutes, right? We have 2 minutes.
Come. I have 2 minutes to entertain you guys. Come, lai. So, what do you guys do? Cause you guys choose to stay behind, right? Like, what do you guys do? Or do you guys want to move in front instead? Okay, cool. We'll see you in front then.
Hello. Everyone enjoying the talk so far? I promise you will enjoy it even further if you sit in front. It's more comfortable, so it's more plush seats. Come, friends. One group. There's a row there. It's more comfortable as well. Right. Don't worry, the speaker won't take it personally if you just like move away from the front row to the next track. Geeks. Come, let's move in front. Yep. Remember, keep your mask on, friends.
Hi, people at the pantry. So, guys can try to join back to either track 0 or track 1. Cool.
Are we reaching 2 o'clock already, Jody?
No, it's 1:58. So.
Okay, come, let's count down.
The one lah.
120.
So I think, oh, it's too close. Hi guys, I'll be talking about passing differential problem. If you guys are software developers or students or just want to explore security in a sense, I think this is perfect for you. It's pretty beginner friendly, and we explore how we look at software development in the security perspective. So my name is Cherbun. I'm a security engineer, a part-time faculty at SMU, and I play CTF under that banner. So yeah, what we'll learn today is what is passing differential problem, how this affects us, and how can we address this issue. So I think some of us here are startup owners or wanting to be startup unicorns, and we all start with a single system, right? And or maybe some of us are working in a startup or a company of some sort. And the software we're working with could be as small as a single system, and over time it evolves into a very large system. And when you make it big, it involves different technologies, languages, because you just have different tech families spawning here, left, right, center, right? So as you proceed to have growth, you start to introduce probably a gateway, right, to integrate everything together, and everything is interconnected like microservices. So you could have a .NET at the very back end with Java or Django and Go. So all these services, they're all talking through either HTTP or gRPC or whatever. Like they are all exchanging data through a common interface. So all this is due to the path of least resistance to growth system, right? You are, let's say you are in a team, you're using Go, and then somehow the CEO or the product manager says, let's build this product, and they assemble a new team, and that new team happen to be coding in Python, for example. You can't expect them to do it in Go, right? It's a reality, right? You just want to make the system work and serve it as fast as you can to get shorter time to market. But what could go wrong here, right? So if let's say we have system 1 and system 2, given the request, right, of these two, right? First you have John, the second you have Mayer. Assuming that system 1 is Go and system 2 is Django, what could go wrong here? So let's look at the fundamental simplistic code that you will have in the Go and the Django, I would say HTTP microservice. Right, so on the top you can see there's this .get, and the bottom you see there's a .get as well. Both are similar, and both can be found in the official documentation. So what would happen is, the Go system, right, after going through the gateway, will evaluate foo as John. Say, okay, no problem, let's pass it on to the next system. And system 2 will evaluate as Mayer. Now imagine I'm an adversary, right, and I want to cause harm to your system. I will take advantage of this inconsistency and inject probably SQL injection as shown here. So let's take a look what's under the hood, right? And the Go documentation, Go gets the first value that's associated with the key, while in Django, it gets the last value associated with the key. So that means this is how it looks like to the system when the whole entire request is being made from the user, right? Now this is called the passing differential problem. It originates way back from this Langsack theoretic approach where systems have difference in mutual interpretations of the components. So this is not something that's new. It's been mentioned in many articles and many CVEs as well. Right? You can have how to exploit parser differentials in GitLab by Yuan, I can't write the last name. And there's a Pun function which he makes a tremendous video about it. And then on my favorite hacker researcher, Orange, who talked about it in his Black Hat talk in 2018. And one of the books that I read like a Bible, Tango Wet by, there's Mikhail Zlotowski. And if I could quote another guy, a local guy, his name is Eugene, also go by the name Space Raccoon. His recent DevCon talk on iCalendar exploit also includes issues with parsers and how they're being exploited due to the difference in how RFC was implemented, interpreted in those applications. So this is a list from this payload of all things, GitHub, which I contributed to it some time back. And I kind of collated all the different ways how systems or subsystems would, systems and libraries would interpret the variables, right? Which one would they choose, the first or last, or they see everything as an array or a list, right? So this, at least you can see. So why this occurs, right? So we have this, unlike this URL or URI RFC 3986, right, where it defines how you should read a domain name, how you should pass a domain name. There isn't an RFC for variables in the URL, or even the request body, or even HTTP body per se. Like right now, there isn't, as of today's talk. So this creates a space, or rather the opportunity for problems to arise from such root causes. So, like I mentioned, apart from the URL variables, it can happen in your request body, it can even happen in your HTTP headers. And I would like to point out that HTTP headers is also a whole world of crap over there, because you can have canonicalized, uncanonicalized headers as well, which, you know, the headers can jump up. Some systems, they would uppercase the whole entire header. Some systems, they will lowercase the entire header. Some systems just read it as it is, right? So I've read vulnerability reports about systems not reading the headers because, or rather passing the headers correctly, which allows some sort of a bypass leading to a remote code execution. And one example is one of the GitLab ones, right? So because of the headers as well. So what can we do about it, right, is be aware of what we are using, right? Know what is our system. Include test coverage for such repeating variables to assert that this weird behavior doesn't happen. Or normalize the data using an API gateway so that your API gateway will strip such things. Now there have been, one thing that I left out here is that we can just use JSON or XML or anything, right? That could also help you normalize your data because how the library works. So before I end my talk, let's say, it's a bit fast, but if there are any questions, you can just ask also, right? But before I end my talk, we talked about web systems and all, right? The next step I'm taking forward to is actually the cloud. Today we have so much cloud services and from different providers. What kind of passing issues could this cloud provider give us, right? So that's one thought I would like to share with you to think about next time. Thanks.
So repeating his question, is there a typical exploit that, that in passing, sorry, just repeating for people who are streaming?
Okay, so usually such exploits, right, will be used to bypass restrictions. So you have a blacklist or whitelist, or you might even want to bypass firewalls, right? So one example is you want to bypass a web application firewall, custom built, right, built by your in-house team, you're not using cloud providers one. You want to bypass filters that has been implemented in libraries, right? Using such methods, you can bypass those firewalls or even blacklists.
Are there any more questions from the crowd? Yeah. Else, there's one question. Oh, sorry.
There's one there.
Cool. You want to shout it out first? I'll repeat it for the.
Yeah, so that was one of the mitigations at the recommendations, like which is to use normalizing the data maybe through a gateway, through GraphQL, through gRPC, anything to determine the final form of the data before passing it downstream to the atomic services.
Any more questions? Cool. So there's one question from online, anonymous, but are there strategies that can be adopted by SDLC teams to avoid the parser differential issues?
So I think first you have to, from a macro level, you have to understand what you're using in your systems, right? If you are a very large team in a very large tech company, then it's really hard to track those. But if you're in a small team, you can really start by understanding what your systems are working with, and along the way, implement subsystems that will normalize those values. Because even you have new system popping up, right? If you normalize the value at a certain point, you would eliminate that problem, or you probably just use JSON or anything that would just stop this from happening. Yeah.
Any more questions? All good? Can we give another round of applause? Cool.
All right, next speaker will be talking about polycube construction sets. Yeah, you can see that, right? Got a very interesting black cat here, so this is what they're going to be speaking about. Yeah, and as a reminder, there's the Slido for you all to ask questions. If you are too shy to ask, we can repeat it for you. But yeah, so the issue, right? 3D printing, but then cannot print like thick models because it takes too much plastic and so much time. So today, Chunwei is going to be telling us, walking through how you accomplish polycube construction sets in voxels.
If I'm not wrong, some of you are given like little boxes at a registration as well, right? Yeah, so cool.
Y'all can try it out. If y'all don't know, maybe you still can try a registration if they still have. Do you know if they still have Chunwei?
I think it's out of stock.
Oh dear, alright.
Yeah, unfortunately, I only could make about 100 sets with all
That is a
figured out.
lot of sets.
But is this something we can print? Is this in the slides?
Yeah. It's open source, so
right.
Yeah, you can just hold on. I'll come like that. Okay. Okay, I'm not sure how this works. Yeah. Okay. Okay. For me, today's talk will be on this construction set. Okay, I've developed this set by myself, so it's an invention of mine. But just like, I don't intend to sell it. I just want to just give it away. Okay. So what's the long story short is that what I want to do is to get representation of or just design something that's based on voxels, and I want to have the thing is that when you design on a program like this, you can see it, we can't really touch it and get a feel of it. I don't really believe in the metaverse. I really believe in touching real stuff. So what I've developed is a construction set that can easily translate what you have done here to a physical item like this. So this is an example. Okay, so it's touchable, it's physical. So maybe I pass it around, I can have a feel of it. Yeah. Okay, yeah, it's very light. It's a very efficient use of a material. Yeah. Okay, physical touchable object. Okay. Basic dimensions. So it's 125 by 255 millimeters by 200, and it weighs about 88.74 grams. So what that means is that on a standard wheel of a PLA material, if you know about 3D printers, you can make about 10 of these. Okay, so this obviously is not based on Lego blocks, but why don't I just use Lego blocks as a starting point? Okay, so now I just describe what Lego blocks are. I'm sure you know, but I just have to say it for completeness sake. Okay, so Lego blocks is a building block system of something on starts on top and empty starts on bottom. right? Connection is achieved through interference feed. Okay, so the thing about Lego is that, you know, when you play Lego, you use up certain pieces and then you can't find the piece you want. And then you have so many other pieces that you just can't use, okay? So that's a real problem, okay? That's a problem I want to solve for this construction set. Okay, another problem is that these blocks are not orthogonal. That means their height and their width is not the same. Okay, it's very hard to get square builds out of Lego. Okay, and also building sideways is very different from building it vertically. And for example, you can see here, right? If you want to extend the red block with the blue block, right? You basically have to replace everything and build it out of plates instead. Right? And if you are that's the thing about it. So that's the thing about Lego also, you know. When they sell you a Lego block set, they also give you an example of what you can build. But most people, what they do is that they build the example on the box set, and after that, they find that they can't build much of anything else. So that to me is it's not really a good toy for free play. That means you just want to imagine something and you just want to build something out of it. This creates a lot of unnecessary complications. Okay, so this is an example of a perfect square. Sorry, a perfect cube in Lego. It's 48 by 48 by 48 millimeters. Okay, but it's very big. It's 6 by 6 by 5, so it's about this big. Well, not a good way to use it to design voxel-like sculptures. So why do we want to do a clean sheet design now? I mean, why don't you just square the Lego block and then just 3D print it? Isn't it so much easier? Okay, so the main difference now is that 3D printing now can be done in a home environment, okay, and they can do, how would I say, the kind of design rules, right, which means that the things you can do and you can't do is very different from the technology used to produce Lego bricks. Okay, so there's a difference. So just by transferring a design from Lego to 3D printing isn't really the ideal way to use 3D printing to its fullest. Okay, so also there's a trend for hardware to become more open source, like wrap. Okay, 3D printing used to be very expensive, right? Right now you can get 3D printers from AliExpress for like less than $200. It used to cost $200 to just make one model, maybe about 10 or 20 years ago, right? So it's not only about the hardware, the software to drive, the design, and the fabrication has also matured a lot. Okay, I would say, especially for computer-aided design, right? So it comes to a point where you can do relatively complex designs using open source and free software. Okay, and last thing is that Lego is also not the good company that you think is this. All corporations are evil. Okay, if they feel that they're threatened, they will send you a very nasty legal letter, and yeah, you just try to shut you down. It's not that. It's more of you don't have the money to fight these legal issues that cause all these companies to just ban all this or just take all these designs down. Okay, so now what I've done is that instead of there's so many parts in Lego, so all you need to do to build the cat, right? I'll just put it down there, it's okay. Yeah, it's only 4 pieces, right? So there's only 4 different kinds of pieces that you need to build this model here. Okay, so it reduces a lot of these logistical issues. Okay, there's a 5th part, it's optional. It's only when you need to get sharp corners. Okay, but so the plus and minus may be very dangerous, so you may not want to use this part here. So how they work is that they have bumps and dents on the side, on the edges, to help the pieces lock together. Okay, and yeah, they are also keyed, right? This is through testing. They realize that sometimes you may connect wrongly, so this is to help you connect the pieces correctly. So these are the kinds of connections possible. So there's a straight connection and a 90-degree angle connection. Okay. So when you build the object, right, it finds the edges function like zippers, right? So the thing is that when the thing is not closed up, it's actually rather quite flexible. So it's easy for you to put the pieces together. But once you close this thing up, like this cube here, we close it up, it becomes very rigid, okay? And it can hold quite a bit of weight. So the real problem is that you have these 4 pieces, but how do you know which of the 4 pieces to use to build the model that you want, okay? So there are 2 kinds of methods. One is more of the intuitive edge following method, right? Where you follow the edge of the model you want, and then you choose one of these 12 fragments to fit there, okay? This is good for free play. That means I don't have any computers to help me design the model I want, right? I just want to say, oh, I want to have this protrusion here, okay? And then from either my memory or I have this as these 12 fragments as a guide, I can create a protrusion from an existing model, right? So the other method is to enumerate all the possible fragments for each face. So this is more suitable for computer-based planning, to plan which tiles go where. But I haven't automated it yet. I just enumerated all the possible pieces, that's all. Yeah, because I still go back to this intuitive edge method because I do mostly free play with this. Okay. Yeah. So the thing about it is that how much effort does it take to actually build this this thing? So if I were to spend 5 minutes to print one panel and then I have to stop and then I have to fill it out, I mean, you're going to run out of patience very soon. But the good thing about today's 3D printing tool chain is that you can print them in an array like this, right? And you can just plug them out without getting rid of any supports, okay? So what you do is that you set the system up, okay? You set the print, then you wait for about 4 hours, then you get 90 pieces of each part. Okay, so for this model, the cat probably took about like 2 to 3 days of printing. Okay, the assembly itself would take about 2 to 3 hours. Yeah, so it's a good time, it's a good activity to pass time. Okay, so as I said, this is released as open source. Okay, you can copy the design, you can share the design. Okay, you can adapt it, you can make it bigger or smaller if you want. Okay, but you just remember that, just give me some credit, okay? That's all I ask for. Okay, so everything is available on GitHub, it's on this link here. Okay, you can grab the FreeCAD design files, STLs, and have a try at printing it yourself. Okay, so if you, how many of you have the sample kit? No. All those. Only
I think
a few.
some of the morning folks might be in the other track.
Oh, okay. Maybe I should.
They're in the wrong room.
Yeah, maybe. Okay, so doesn't matter. Well, if you can print out the parts and then you can try out using the sample kit. Okay. So the instructions are over there. Okay, that's it. So yeah, this model of the cat, the one multicolor one. So it has been color labeled, the blue, yellow, white, and orange. These are the 4 different parts that are needed. So it looks very weird. Yeah, but the thing is that you can choose any color you want, right? Yeah, and give it a more decent look. Okay. Yeah, so that's all.
Thank you so much for your talk.
Let's go through Q&A now.
Sorry?
Let's go through Q&A.
Yeah, let's go through Q&A. Is there any questions from the crowd? You want to scroll? Oh yeah, go ahead.
Palm Street, yes.
So, how did you got about this idea? Like, what inspired you?
Oh, this one. Okay. How would I say this? It's more of it's more of a need to find build a structure that is truly modular, right? Okay, the thing is about modularity. So there's some research being done into structures, right? Robotic structures, structures which can be assembled robotically. Okay, so the thing I've seen is that most of them try to construct trusses. You know, trusses is like sticks, then you assemble them in like a hexagonal pattern or honeycomb pattern. Yeah, so I feel that well, that's a way to build a space structure, yes, but a lot of structures that we see nowadays, they need to have a barrier. Like these trusses, they can't hold water, and you pour water on the water will just fall through. So you need to have a system where you not only provide a structure, you also need to provide a barrier, right? So it can, let's say, contain a tank of fluid, for example. So it makes it more useful for modular applications. Yeah. So, well, I see it now as at this point, it's developed more as a toy. So it's to, like, I'll say just, okay, the thing about this is that it's be designed such that if you take any piece of the parts there, right, you can pass through the entire internal of the body. What I mean is that, okay, let's say if I take any piece, right, I open up, okay, I take any piece out here, okay, I drop it in, right, and you can come out the nose. Oh, okay. You understand? So the point of this is that there is a possibility of designing a robotic system to move this from any part of this through inside interior. So you're not restricted by, you know, from one side to the other. So it's more of like a transport system. So yeah, because if you've seen all these robotic systems, they tend to make each panel smart, but that's not really cost-effective or sustainable. You rather have something that's modular, that's easy and cheap to make, but you have a smart robot to move it around, and you have a structure here that helps the smart robot to navigate the internal structure here. Yeah, but that's very, very far ahead, right? But right now, as it is, it's just a toy. Hopefully, you can play around with it, and if you want, you also can develop a robot that can assemble this from the interior or something like that.
More questions? I see one on the crowd. Give me a while. Come.
Thank you for this creation for modularity. I see all your creation is orthogonal.
Yeah.
Any chance that there will be slant edges or other angles, like a prism or pyramid?
Okay. The thing is that if you can make a donut out of it. Okay, because because this thing, right, this is not rigid, it's flexible to a certain degree. So you can make a circular ring, then you can make it like this. But if you're talking about, let's say, prism or slanted edges, my thinking was that okay, that will make that will contradict that what I want to do is that you will just increase the number of parts in the system. Okay, one other thing you can try is that instead of making it like 25 millimeters cube like this, you can make it smaller, right? And smaller and smaller and smaller until you don't notice that it's stepped, but it's just a slope edge itself, right? So this is rather large. So imagine if this thing can be shrunk to, let's say, like 0.1 millimeters, then you build something out of it. Yeah, you may not even notice that there's a jagged edge. You understand what I'm trying to say? If you have really angled edges, you can do it, yes, but you just increase the number of parts, it goes against the principle of doing this.
Cool, thank you for the questions. I am very interested to do like 3D pixel art now. It's like not just in the metaverse, but 3D pixel art IRL, right?
It's in real life. You can give it to your girlfriend or what? I'm
Cool.
sure they like it.
What? Cool.
Right.
So, thank you so much. Is there more questions? If not,
okay,
let's have a round of applause.
Okay, thank you. Thank you.
Right, so we are back to track 1, track 2, track 0, track 1, because we are programmers here, right? So, so the first, for the main track over here, sorry, I'm going to move away from the mic, Right, so for the main track over here, we'll be doing monorepos, right? How do you set up efficient PNPM with NX, which is like a monorepo system, or you can go over to track 1 to do hardware stuff, which I have no idea what to do. Cool.
Yeah, Jody's a software person, so let me take over for this one. Yeah, so if you are familiar with FPGAs, right, processors, you can't trust them. So here, Joyce from High-End Technologies will be mentioning about how we can truly trust and present a computer design with an FPGA RISC-V processor, so all open source, allowing for the underlying hardware to be inspected, so you can trust it.
No idea what you just said, but cool.
Yeah, so toilet break now. Feel free to get some extra drinks or maybe scarf down some extra desserts and a little bit more food. We still got extra servings.
By the way, so there are still extra food courtesy of IamToken. So if you guys want a second go at food, can be fast and over there. Right, so bentos are on my left, if I can see me, on my left, and the desserts and drinks are at the pantry. Cool.
Once again, thank you IamToken for the awesome food. I love the spaghetti. Do you get the spaghetti?
Oh no, I got the rice. So
now you can get the spaghetti.
No, it's okay. IamToken, gold platinum sponsor. Platinum sponsor. Gold sponsor is GeekcampSG, I think. Silver sponsor is Pro Life. No, I'm actually just off the hip. I think I memorized it. I will die. Sorry, if it wasn't clear, main stage over here, track 0. Track 1 is in Franklin Room. Cool?
Yeah, so Joyce's talk as well as Barcamp talks are further in.
Cool, so this is track 0. Right, so if you are interested in monorepos and how you organize and manage them using NX and PNPM, which is apparently faster than Yarn, but sure. Okay, this is just a request because like there's more seats cleared up so can you guys move forward? Thank you. I will treat it as a personal request for you to move forward.
I promise the front row seats are more plush.
Yes,
Can the-
it's
come.
soft, and I just disinfected it just now.
Crowd
so
work, crowd work. Come,
move
come,
forward, or else we'll come and ask you questions.
So the folks here, they were sitting at the back just now. Is it softer now? Is it more comfortable?
Yes. Yeah.
Definitely.
So we never lie, right? So seat in front.
It's
Thank you.
3 5-star reviews. Come on.
Test. Maybe it's too loud.
Cool. So I'll do a quick introduction while he sets up. Hang on. Let me try to find. Bloop, 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 bloop. So, as people shift from monoliths to microservices to micro front ends, more teams are shifting towards a monorepo model. With more collaborators, monorepos will grow in size and needs to run efficiently. So, Thomas over here will be sharing how do you do a good monorepo setup. So, take it away.
Hi everyone, so I hope you're enjoying the event so far. Maybe we can get a quick round of applause to all the organizers for the excellent job they have done. Thank you. So today we're going to talk about monorepos and especially how to set up an efficient setup for it. So I'm Thomas, I'm a front-end consultant at Zenica, which is a IT services company. It's originally created in France. That's why I have this lovely accent. And I'm specialized in front-end development. I really love performance and accessibility. And I really enjoy learning new things. So currently I'm trying to learn Rust or mostly fighting the compiler. So first, let's start with the big question. What is a monorepo? Maybe you've known monorepos, maybe you are already using one, and maybe you don't know even what it is. So we'll try to answer that question. But first, we will talking about something else. What is a repo? Like, a repo means repository. So it's a place where you are storing your code. And initially, before microservices and stuff, we used to work with monolithic apps. So you had one server to handle everything. So it needs to serve your front-end assets. It needs to run the business logic. That would be the back-end code. And then you probably need to fetch some data as well. So you're accessing the databases. And you maybe also have some scripts, like to handle the deployments or every automation task that you may need. And everything is stuffed into one repository, but you only have one application. And to do this, you will be using two important parts. The first one would be Git, or maybe SVN if you're not lucky. It's basically a version control system to help you store all the history of your project. And the second important part of like having a repository is probably using some bash script to run like deployments and stuff like this. But then there is a complexity, like an evil complexity growing, and it will try to hurt you. So we are trying to like fight the complexity, and to do so, we'll need some monorepo. But let's have a look at what is this complexity first. So today we have not one app to handle everything, but multiple apps because we have more and more stuff that we want to do with like our website or our applications. So we need to have multiple applications, and sometimes they need to communicate with each other. So you may have some multiple service, then a gateway to like normalize stuff, backend for front end. Maybe you have multiple front ends that may be working together inside one micro front end. So it may be complex. And then for your front end to be consistent, you need to have like a good user experience. You want to have a pretty nice UI, sorry. So your brand is the same throughout all of your apps. Then you have a complex business domain to address. So you may extract some of the core logic into libraries. You may share some class between your front end and your back end if you can write everything in the same language. You may have some library to handle things like the formatting of the front end code, or how to display dates, or maybe internationalization as well. You may have a lot of dependency to handle. Maybe you want to publish some package for like open source stuff. You have to deal with security, like imposing some rule set over your repo. And if you're really into automation testing, you can set up some end-to-end testing with tools like Cypress or Selenium. And then you have your deployments. Maybe it's a simple server to deploy. Maybe it's container within a Kubernetes system. And then there is like the infrastructure as well that may be stored somewhere. So all of this could be a lot of repository to manage, and that can be a real pain to deal with. There's three things that we won't talk about today. It's how to handle versioning, deployments, and building your application, because this is highly dependent on your existing software, the type of language you're using. So let's imagine that we have that part covered already, and we won't talk about it anymore. So the first way of dealing with all this multiple repository and the complexity of managing the version, the deployment, the code sharing, reusability, it's simply to ignore the problem. Like, okay, I have multiple repository, I can manage. So let's say you have some UI library, you have your front end, you have a backend code, and you have a models folder with some shared class, because everything for this example would be written in TypeScript, so we can share the models on the front end and the back end. Not that it's a good idea, but it's just for the sake of this example. So if we want to update like a button in the design system or the UI library, we need to update the code, and then we need to push the new version. So we need to publish the package into our registry. Then we need to check out the front-end code. We need to pull in the library. And then we can finally release the new version of our project with the updated button. And that's a pretty long workflow only to update a button. So that's a bit annoying. And then if you have something like this, so the front end is using the UI library, and the backend and front end are sharing the same classes from the model package. And if you want to deploy your backend, you need to be sure that you can do so without breaking the front end, because if your backend systems doesn't have the same model as the front end when you deploy, you may break some things. So that's something you want to avoid. So to avoid all of this multiple repository, we can decide to actually handle everything inside one repository. So here it would be called your monorepo. And then inside this monorepo, we can have multiple packages. So you can have your front-end code, your front-end end-to-end test suite. You can have multiple backends, or maybe your backend for front-end, the design system, your models, the internationalization library, some utils folder where you can stuff everything you don't want to know about. Or you can have maybe a more, I would say, clean way to sort everything. So you can create a libs folder who would be responsible of all the libraries that can be published. So design systems, model, utils. And the apps folder with all of the real apps, let's say, and end-to-end test suite, sorry. So to set up all of this, we need some tool. So let's have a look at the different tool we are going to use today. So definitely Git is a good tool. We are taking him in our team. That's a really good tool. I don't think anybody has something to say to be mean with Git, so let's take it. Then we're all using computers, right? I think. So we might need some file system, and having some cache is always a good thing. So let's add some cache to our setup. You may need some build tool as well. So we are probably dependent on your language or framework to build your project. So this would be probably imposed on you. And then since we need to have some configuration, we are probably gonna need to write this configuration somewhere. So since I'm writing TypeScript, I will be using a package.json. And then we have to sort the multiple dependency that we have. And for this, we will need a package manager. So every messy dependency would be cleanly put. So now we come at a point where we need to set up all of these tools to help us with our monorepo. So we'll start with PNPM, which is exactly the same thing as NPM or Yarn, but faster. That's why it stands for Performant NPM. And the nice thing about PNPM is it is mostly a drop-in replacement. You can use PNPM in basically every repo that you have that uses NPM. So you can handle workspace, you can handle your log file to set exact version of your dependencies. You can override some package. You can read the default config file from the npmrc as well. And if you want to execute some package without installing, you can do so with pnpx, which is basically the same thing as npx. The best part about PNPM is all the additional features. So you can manage the node version. You don't need to use NVM to do so. You have some migration script as well. So if you have your existing package with the package log file already in place, you can just migrate. And the best part is the content addressable storage. So it's difficult to pronounce. So the content addressable storage is a global store. So think of it as the global node module that you have on your laptop. And it uses hard linking and symbolic linking to point to a file somewhere in the system. So instead of copy-pasting everything like NPM does, you can just create symbolic link between your files. And small difference from NPM, it does not use a flat node module structure. So let's have a look at what it means. This is NPM, so every time you want to install something, it will look for the global NPM cache and copy-paste everything into your node module. And then you will have all your dependency into the node module. So here I'm using React, TypeScript, and Express. But then Express also has some dependency, so we need to install it as well. And in that case, what NPM will do is actually copy-pasting the dependency of your dependency. So here Express has a dependency with body parser, and it will need to pull it as well. What PNPM does is a bit more clever. So it creates a .pnpm folder, and it will create some hard links. So React, TypeScript, and Express will actually not be copy-pasted. It will only be a pointer to use the real file in the global PNPM store. And then the node module will only have symlinks to reference those files. So the node module will only contain React, TypeScript, and Express, and not the body parser dependencies. Now comes NX. So NX is built by Narwhals, which is a company that maintains some tool. So initially, it's based on the Angular CLI. It even used to have angular.json as a config file, but not anymore. We used to have we have a migration script if you want to add it into your repo as well. We have some plugins maintained by the Narwhal team, but also from the community. And most of them used to have code generator to help you generate some boilerplate as well. So this is the list of features of NX. We are gonna try to have a quick look at all of them. I'm not sure about the time. So this is the file structure we're gonna use. We have a design system that is used in a Remix application, and we have a utils folder that is not used anywhere, just for the sake of the example. So if I want to run the nx build command, it will actually look for all the dependency of my project. So on the top, it's about the contrast, sorry, but nx actually says one dependent project task succeeded. So I actually launched the build command on my Remix project, and it actually automatically knew that it needed to build the design system first, and then it could finally build the Remix project after that. If I want to build something, well, I can run the nx run many command to launch the build command on all my packages. So every task is taking 2 seconds here because it's an empty project. And if I want to run it again, that would be a loss of computation resource if I need to build it again. So we can probably cache it. And by default, NX does not cache anything in case it doesn't suit your project. But if you apply the cache and you relaunch the same command, it will actually pull every output from the cache. So here the final run of this task took only less than 40 milliseconds. So let's design a feature where you want to update your Remix application. Since all of your packages are within the same repo, you don't want to rebuild everything, and you only want to maybe update only the Remix application, so you don't want to run the test for every other folder. And you can do so easily with the affected command, which will only launch the command on the affected project. So you create a branch, NX will look for your master branch or main branch, look at the differences, and only run the command on the affected packages. And here it pulled the design system for the local cache because there is no changes on the design system, and then he built the remix application. A nice feature of NX is the ability to use the graph. So the graph command will actually open up a small web page to visualize the dependency within your system. So here you can see that the design system is imported by Remix, but the util folder is not imported anywhere. And if you combine the affected command and the graph command, you can see the changes that you just made. So here, I only have a change in the Remix application. I can visualize that it's the only thing that changed. And here I can have a change in the design system, which, since it's imported in the Remix application, it will affect it as well. With NX, we have, the normal team has a commercial product as well called NX Cloud. It allows you to have a distributed cache between all of your machines. So if you're working on something and then one of your colleagues needs to build the same command, it can actually use the cache from the distributed system of NX. And then so does your CI. So everything can be cached and improved. And then there is the distributed task execution, which is basically like running multiple agents in the cloud to distribute efficiently the computation resources. You have this site called monorepo.tools. It's made by the Narwhal team, so maybe it's a bit biased, but it's a really nice way of comparing all the monorepo tooling that exists today. Is it good from time? I still have a few slides. Yeah, okay. So now it's the return of your happiness, because this is only a tool, but it will bring you some joy. So this is the repo structure that you may or may not have from your existing monorepo. And if not, you can totally configure everything in PNPM. So if you have to have your components into a components folder and your other packages into packages, you can do so, but it's just configuration. You can change it as you want. If you already have a monorepo, you can run the PNPM import command to actually migrate from NPM or Yarn to PNPM. So it's just a one-liner and you're done. And for NX, depending on your repo structure, you may follow the different guides they have. So they are a pretty good documentation to get you started. If you want to do a fresh install, like starting from scratch, you can run the create NX workspace command. Basically, it will ask you some nice question about what do you want to like scaffold and things like that. And it will create everything configured for you. Then, if you have an existing monorepo, you can do the installation by using the add NX to monorepo command, and it will try to read your project and set up NX for you as well. You have a lot of plugins depending on what you want to use. So if you're using Angular, React, Vue, there's probably a plugin for it. So all of these are the official plugins, and there is also a ton of community plugin as well. Performance-wise, just a small comparison. On the top, you can see Yarn. So it's a fresh install on a real project. The fresh install from Yarn took 40 seconds, and the PNPM install took only 30. And the space used on your machine is like half, so pretty efficient at managing resource and disk usage as well. For NX, this is a comparison from the creator of NX. So just a large monorepo with a lot of resource to compute, and NX is done like in less than a second, and Turbo repo is done for a bit more than 4 seconds, so 10 times faster here for NX. The documentation of PNPM is quite simple, but it's good. I've never been annoyed by it. And you're in luck because NX just released a new version last week. So they revamped their doc and it's even better now. And do we have some time for the demo? Is it okay? No? Okay.
Hello, hello. Okay, we have around 30 minutes. Just take your time.
Okay.
Yeah.
So here we can try to use the scaffolds command from our tooling. So the first thing I want to do is maybe increase the size of this so you can have a look. Okay, is it good enough? Okay. So the first thing I want to do is actually create a new monorepo. So I can do this by using the create NX workspace. And since I'm using pnpx to install the NX workspace, oh, I forgot to turn on the Wi-Fi. Okay, let me try again. Okay, so since I'm using pnpx to launch the command, NX will actually know that I want to use pnpm, and it will do so without asking me for it. And still no Wi-Fi. Okay, sorry, need to turn this on.
I would ask you to use the milk bottle, but the guy who has the milk bottle like is walking away.
Okay, here it is. So I'm running the create NX workspace, and what NX will actually try to do is to ask me some question about what I want to do. So here I want to use an integrated package. So it's a pre-configured setup from the NX team, and everything would be scaffold for me. Then I can ask him to generate a React application with an Express backend. Then I can try to create some package. So let's call it GeekCamp. The application would be maybe the front end. And we're using CSS. I don't want to connect to NX Cloud yet because I don't want to set it up. But if you want to do so, you can set it up right now. And then it's going to install some dependencies. So it may take some time. It should be faster than NPM. Should be. Yeah, let's blame the network, okay? Okay, so it's creating the workspace. It has installed the dependencies, and it may run the pnpm install command several times. So we'll just have to wait, and then we'll have a nice project entirely set up with everything. It is slower than usual, sorry for that. Okay, so NX has successfully installed everything, so we can maybe have a look at what it scaffolds. Okay, so I'm just gonna try to zoom in a bit and see if that's better. Okay, so I'm not sure I can zoom in, so you're just gonna have to believe me. So this is like the setup that was generated. So we have a main GeekCamp folder, then we have the apps with an API, the front end, even some end-to-end tests have been generated, and then we have some libraries with some model defined inside. So let's come back to this. We'll go into the GeekCamp folder. Okay, so here is my project with everything inside. And now what I want to do is actually run like everything. So I'm going to use the run many command. And sorry, run. Okay, so this one, I'm going to run the run many command to serve both the front end and the back end applications. So NX is going to start everything. Okay, so the serve command has been run for 2 projects, API and front end. So if I go here, should be able to go to localhost. Okay, so here I have my little front end and this welcome to API. So if I go here in the network and I refresh, I can see that this message, welcome to API, come from the actual API on localhost 4200/API. And this is basically a proxy from localhost 3333, okay, and it's on /API. So this is my API, and this is my front end, and everything has been set up for me. So now if I go back here, I stop everything, and we are just trying, please, okay. Now we can try to scaffold some library. So we are gonna need to install some packages. Which is it? pnpm. Okay, so we are gonna install 2 packages, one for React and one for Storybook. Should be quick as well. Okay, so I've installed some dependency. Now I can generate some code. So if I run this, okay, so I'm gonna run the NX generate command with the React package to generate a new library. I will call it my new library. And what NX will actually do is it's using the React package to generate some code for me. So it will set up a new library with all the configuration, and it will put it inside our monorepo so we can use it immediately. Okay. So if we go inside our library, which one is it? Okay, so I'm gonna go inside my front-end code, open the application folder, and then this is like a basic React component. But if I want to use something new, I can just use my new component. So it's called my new, so I have to look at it, my new library. Okay, so this is the new component that got generated. I'm just gonna import it inside my application here, and then here I can probably use like this nice little syntax, so I don't have all these nasty imports. Okay, let's go back here. Let's run the serve command again, and hopefully I did not forget anything. So here I imported the new component, and it's already working. I basically did not do any configuration for it, and I can import the component from another library. So it's easy to set up. And what's even best is that we can now create the same configuration for Storybook as well. So if I want to run a Storybook command, I can actually generate the configuration for Storybook for my new library. So I'm just going to do that. And here again, it's one of the plugins from the NX team that will generate everything for me. I'm just going to select the React application. Everything is automatically generated for me, installed, so I don't have to even think about installing the dependencies. It's storybook, so it's a bit longer than usual. Okay, and now I can just import like already written test page from, oh, sorry, what happened? Not timeout? No, I think it's good. And now I can run the start storybook command, which is this one. It should compile the storybook and open it so we can have a nice documentation page for the component. So here again, nice thing, I don't have to set up anything. I'm just typing commands and everything is configured for me. This is painful because this is the first time, but then if you need to relaunch the task, it would be, you can cache it, so it would be faster next time. But the first time would be probably a bit slow. Okay, let's just wait for maybe a few more seconds and then I will just cancel it if it's not working. But you have to trust me, it works. Just not today. Yeah. Okay, so I think Storybook is asleep and doesn't want to come out, so you'll have to try it on your own laptop, I think. Okay, so I think I don't have anything else to show you on the storybook part. So if we go back here, mostly I've told you anything I knew about PNPM and NX. I hope it can help you in your future monorepo adventures. Here are some sources. I will share the links to the slide later on the Discord. And thank you.
Okay, so I will be inviting Thomas to stay on a bit more. Is there any more questions from like the stage? Yeah, Shri.
I have been using NPN. I haven't used about PNP. After seeing your slides only, I got like if I have some projects in NPN, could I transfer it to PNP and work it out?
I'm repeating so that the stream can hear as well. So, question is, been using NPM for a while. How do you transfer and migrate over to PNPM?
Okay, so the nice thing about PNPM, it's only a tool to like pull the dependency. So if you have some library published on NPM on the or any kind of registry, if it's a private, corporate, and a registry. PNPM will be able to fetch your dependency from any kind of repository. So you don't have to think about, oh, I have some stuff hosted on NPM. It's not a problem because PNPM will actually be able to fetch your dependency from anywhere. Yeah, it's just the CLI to install stuff, and you don't have to think about migrating everything from NPM. So you can use your dependency as you are already using them.
Any questions from like the crowd? Is there any raised hands? Or if you have any questions, just shout out lah. Okay, cool. Give me a while. Let me run over. Yes.
How does Yarn workspaces compared to monorepos in PNPM?
So it's basically the same setup. In Yarn, you can define workspaces, and it's basically a config in the package.json where you say, oh, you can look at all my sub-projects at this page. And what PNPM does, it's basically the same thing, except the config file is written elsewhere. But if you want to use Yarn to handle your monorepo, you can totally do so. And
any more questions? Any more? Okay, I'll move on to the online questions. So, by Anonymous, any tool suggestions for back-end and front-end if using totally different languages? For example, if a .NET back-end, but Nux for front-end.
yeah, so if you head over to monorepo.tool, the little website I shared.
Hi guys, can I just like a bit of quiet? It's because like people are listening as well.
Sorry?
No, I'm just like, guys, can you like just a bit silence for like, thank you. Okay, cool.
Yeah,
you can continue.
Yeah, so if you head over to monorepo.tool, the little website I showed you earlier, there's plenty of comparison for like the whole monorepo ecosystem. Maybe I can show you quickly. So if we go to monorepo.tools, okay, so this is the website, and you have like an explanation about what is monorepo, why you should use one, and every other question that you may have. And there is some, if I scroll down here, there's like a comparison of every different tool that you may have for monorepo. So here, just gonna zoom in a bit. If you want to use Bazel, it can do local computation caching. If you want to use Gradle, it can do so. So does Lage. Lerna does not does it. NX does it, and so on and so on. So here you have a lot of like comparison of what kind of tool you may use. So if you want to use NX for something else than Node, you can totally do so, because NX is just calling your build tool. So you will have some package.json for the configuration of NX itself, but that's it. If you want to build some, I would say, .NET or even C++, you can do it with NX as well.
Okay, so another question's from Slido by YYK. So YYK says, love monorepos too, but I think monorepo has problems scaling to more teams, different timelines. Have you faced any suggestions to mitigate them?
Have I faced any? I said depends on your organization structure more than the tooling itself. So maybe the issue you encountered with monorepos and maybe team overlapping each other boils down to the way your organization is structured and how you work together, more than the tooling itself. So, but maybe I haven't encountered the particular problem that you have, so I wouldn't know.
So is there no more questions? No more questions. Let's give another round of applause. Okay. Cool. So I have nothing until Hi, so track 0 ended a bit earlier, so you guys can take a bit of a toilet break. Just know that like our next talk will start at, hang on, where is it? Next talk will start at 3:45. Well, that's actually quite a long while. Right, the next talk will start at 3:45. Track 0 having unreasonable effectiveness of dumb values, and for track 1 over there in Franklin Room will be Bitcoin, blockchain, and cryptography, part 2, simply because Yuzin Chua has actually given a talk in 2012 about Bitcoin, back when Bitcoin was quite small, right? So you get to see his like 10-year journey of blockchain and Bitcoin. For track 0, we'll be having like a talk on like how we can use like dumb values, right? Dumb approach to solve simple problems. Cool. So about 15 minutes break. See you guys back here.
So take note though, take note that the like use params or this funky colon slug thing at the bottom. So these are the provisions that the libraries give you. These are code from the library that you'll be sprinkling all over your code base, all right? So let's look at what a router is. It's a pattern that you write and then you have a function that you call, comes together. During runtime, you will put the URL and your match and call your function, simple. Right, this is the parse URL portion, which is very important. So the next thing that you need will be like, okay, how do I link to my home page? How do I link to my book, right? So without any other support, you know, you can always, this is the worst case scenario, you can always concatenate string, no problem. But then you'll be sprinkling strings concatenation all over your code base, and like, good luck when you want to change URL or path or anything. So usually, what we need is that, hey library, do you have a path helper? Right? I could say path 45, and then you'll give me something back. So you use a router, you need to use the path function from it. Now the library needs to support and give it to you. So now the library is twice as big. Right? I own you, because now all the path APIs are in your code base in every page already. And then when you choose your router library, you'll be like, does the router support tests? How does it do this, right? So this is from React router page, and it has picking a router. Within the router library, I still have to read the FAQ to pick a router. This is like getting very, very complicated, right? It's very high risk. And the middleware, this is a flowchart for picking a Golang router. What APIs do you need? If you need this function, you better pick this router, otherwise you'll regret it. If you need that function, you better pick this one. So this becomes very high stakes. What library do I use? Because if I choose it, the APIs are sprinkled all over my code base. And then, so then the router libraries now compete with features, right? So this is very tiring. So I used to think that my application is at the center. I used to think that my application is at the center, and the dependencies go round and round me. And then after a few years of you doing web development, you realize that actually the thing flying across in the center, right, it's not you, that's your library. And then you're just this little app are trying to catch up with the dependencies and the version. It's like, whoa, it's like, is this, does it have to be this way? Is life like that? This is hard, right? So, hear me out. Values. If we go back to the gist of it for the routing parser, this is what it does, right? Pattern, you give it pattern, you give it function, and it matches for you at the runtime, calls your component, calls your function. Small change, right? Instead of calling my function, just return me a page value that I own. I define my page. So like, I have a home page, I have a book page, right? Instead of, I still define my pattern, but don't call my functions. Give me the value back. So, okay, fine. Because once I have the value, it's very trivial for me to write a function to just, okay, given this page, this is how I'm going to call my component. Everybody can do that. Anybody can do that. If you cannot do that, yeah, so everybody can do that, yeah? This is easy to write, right? So with a page, if this library, which is just this portion, I just need this portion from some router library. If you can give me that, right, nice. So to call the function is very simple. In the same way that this is very simple, it's also simple that I can make it return string. So now I can route to any page. I can say, let me route to page book 42, and it's the same switch statement. Anybody can write this function that generates user. You do not need a library to help you with it. So then there's this earlier question, how does my router library support tests? What configuration should I do so that I can test with the router, right? But now in this new other world, the dumb values world, this question becomes very stupid, because like, how do I use your value in a test? Because you just use values in test, you just test with it, right? There's no question. So same thing, I don't need a test helper from you, just give me the value. Middleware, even easier. If I have a page that is like that, and then if you know what, now my application, big business, I have authenticated pages already. So just create sub-pages, right? So I have auth page consists of edit, and change password, in the original switch statement, just pass off all the subpages of your authenticated pages to another function to do. You can do it however you want. You do not need any middleware, any library support. This is your own code. There's no library code right here. So you don't need a middleware support from a router library as well. Right. So this is one example for a very common example for SPA. Right. You have a dumb server, people reach a page and you just render it. And the front end has to sort out what page to render. But the problem is any route will be 200 okay. I mean, some people will be like, this is a small problem too. But you know, we all agree that this will be better, right? If you have a route, it's 200. If it's not, then it's 400, 404, right? So it's very simple. On the server side, because the route gives you a page, it's the same code. Actually, you just sneak this in, and you ask the router, not router anyway, it's a parser, do you have a page? No, I don't. 404, simple. You don't need any router library support. Once you have a value, you can do a lot of things by yourself, right? So you want to choose that, or just give me a value. So this is the simple version. So other problems, right? So sprint, then, okay, there's a story comes. This is the thing that you have to implement. It's kind of a big feature. User send to client, client send to server, and maybe like this is what 5 points, right? So, and then you do the story. And let's say you just imagine what kind of code has to go inside. Your client has to batch up some work, send to the server. It's not hard, but it's also not trivial. If you have a teammate who sends this pull request in, and then you look at it, it's like, how do I know it's correct? What do I have to go through to check through this code? Right? It's not that bad. Then okay, maybe I should have tests. Does your teammate do tests? Right? But now you have many components, and you have to do mocks, right? Mocks, and you'll be like, mock, but they say that if you own the component, you shouldn't mock it. You should only mock the external stuff. But should I be mocking or should I be stubbing? Right? Or which library should I use? And which version does it go? Oh, then it becomes the same problem again, right? Then, oh, my mocking library is round at the center. Okay, so no. So what? What's the solution, right? Values, right? So what's the values? Let's just take this one part first. Very easy. Everything that point inside, you just take as an input value, okay? User submit a list of items, great. Okay, and another input is that server reply, give me a successful item, fine. We do the same for all the outgoing values. So client output is send batch items, So whatever these arguments are, no problem, because ultimately the API that you need to do, you just copy the values, right? If this one has one argument, then the type has one argument. If this has two, this has two. So this is the brain dead. So this is a summarized version of the same code. Right? So to create this brain, so what you do is, okay, you can take in an input, and then you're going to return you some output. Fine. And then input, there's only two kinds. Right now, we define two kinds. If the requirements change and there's more kinds, just add to the case statement, right? No problem. So say this, and then when user submit, I'm going to send a batch over. And when the server reply, I'm going to report progress. I'm going to send batch. But notice I use TypeScript just to show that this is actually value. This is dumb values, JavaScript object. So you return a value. You're not doing anything yet. I'm saying that when the server reply, send a progress and send a batch, right? And okay, I'm trying to do something. Why ask me to return a bunch of values for what? Well, to get these values to do the work is trivial. Like just now, it's the same way. You do a case statement, and then the arguments just pass it in. It's just blind. These are mechanical functions, right? You don't even have to think much about it. Because the arguments, like I said, matches what you are eventually going to call already. If the API changes, then just change your type. So what's so good? So I now, instead of calling the function, I need to return a value. So the good thing is that, hey, this brain function is super testable. So when it comes in, I'm going to do, hey, so you test it and say that it does return me some values. And then if the server reply, it does return me those expected values. And I'm done, right? So this thing seems not so intimidating anymore, okay? And if you have to go for mocks earlier, and this is the code that's usually the mock, wow, I really cannot grok how to interpret mock tests. It's going to be very hard to see. But values, right? Because if you just change it to return values, you can actually just compare the return values. You don't need any libraries to do that anymore. Right? So in essence, anything that you need to call that has an effect, you call an API, read a file, go to the database, just change it to a value, same arguments, and then, because later on, you can always do a switch statement and call it. So but with these values in hand, you can have all these blah, blah, blah benefit in the previous few slides. Right? So you'll be like, hey, you are asking me to trade one line for like 5 lines. No, I'm asking you to trade 5 lines for the whole universe spinning around, right? I don't have this dependency problem. Just give me values and I can do a lot of things by myself, right? So same thing, right? So if you have to mock and stand up a lot of services, maybe just do your input output and that'll be fine. So this is set for client and you can have another set for server as well. In practice, so what I do is I have these things and I also have one end-to-end test that goes all around. But the end-to-end test does not need to permutate anymore. There's no logic if this person do, because all the permutations are all inside this return value test, which I can go very fast. My test runs like, each one runs 3 seconds. 3 milliseconds. And then my end-to-end test just go once. So the permutation goes there. So this talk is actually about decision tables, state machines. Or is it about tag unions? Or is it about pure functions? Or is it about defunctionalization? It's a very cool thing, by the way. Go and Google it. Actually, it's all about the above. What I'm talking here is that I find that when I'm in some corners, and then eventually the solution that comes to me has to revolve some dumb values. Either it's a value that I do a decision table on, that I can put input, output on, and it just becomes a simpler thing that doesn't need that whole dependency library decision to do. So I work at Hobnob. We use pure type functional language on the front end and back end, break down silos, build answer network for a company. Anything about this talk or about a company, talk to me at Twitter at chunkit.com. Twitter.com at chunkit, but chunkit.com works also. Okay, thank you.
Thank you, Chunkyat, for that rapid fire session. I'm sure 15 minutes was quite a time lapse for you.
Thank you.
I learned a lot about React. So, for some context, I'm not from a software engineering background, I'm from a cybersecurity background, right? And I don't know if you all have seen the code for GeekCamp, which is public on GitHub. Go search it up, very fun stuff. It's like an amalgamation of React and lovely modules and functions.
It's okay, I didn't even touch it, so.
All right, let's present the next speaker.
Let's prep for the next speaker, but before that, is there any questions? Quick one. Any questions?
Like a bit, no time.
No need.
Okay. The birds are flying around, like very mesmerized. Okay, cool. Let's prep for the next speaker, Sam Prodder.
Next speaker needs no introduction.
Right.
Both the organizer and a speaker and a volunteer and an organizer for another conference.
Right, so, databases are very beautiful and fascinating. So for me, right, what I will see is always in if you do a database dump, it will look like just a very tabular form. So Sam over here is trying to make it beautiful and make art out of databases. So give it away for Sam.
Hello. In theory, this is working. I can't actually tell, but hi, my name's Sam. It's nice to meet you all. Hello. Oh God, this thing it's like the Star Wars headset. Okay, so I'm gonna mirror because use a separate display. Cool. Slideshow. All right. It's coming, I promise. And open speaker notes. And then, theory, if I can just drag this over here. Alrighty, hello. Oh, and that's... Okay. USB-C, everyone's favorite. Here we go. Here it comes.
And just never touch this again.
Okay, I'll never touch it again.
Cool. Let's give another round of applause.
Woo! Hey! Okay. Hello. As I said, my name's Sam. I'm a student as well as a software engineer at Hack Club, where we build the best place to be a technical teenager. And today I want to tell you a story about curiosity, experimentation, and making things. Alrighty, so it began with a question I had. Images are made up of pixels, music can be broken down into notes, right? So what's stopping us from turning a database into a piece of art? So that's what I'm going to explore today. Not the world's most pressing question, but something fun. So exploring it, I started by creating a quick Prisma schema. If you haven't seen it, Prisma is an ORM, which allows you to connect with databases in JavaScript. And it's a simple database. We'll be using it. It's a database of jokes. So that's what I've set up here, and that's what we'll be turning into art. Alrighty. So here's a joke. It's not exactly a good joke, but we'll work with it. When my son told me to stop impersonating a flamingo, I had to put my foot down. So thanks for the sympathy laughs, I guess. So how in the world are we going to turn this attempt at a joke into a piece of art? So I got thinking here. Art, you've got colors, hex codes, and hex codes are just hexadecimal representations of RGB values, right? So we could just as easily create hexadecimal representations of our jokes. So that's what we've got here. Here's our flamingo joke in hexadecimal. It's just as funny as it was before. So there we go. Now, we could break that hexadecimal value up into strings of 6 characters to make colors such as these. And so that's what I decided to do. And at this point, I got bored of thinking and wanted to write some code. So I took my idea and I put it into code to create something like this. This is a React function. Basically what it does is I've created a CSS grid with a bunch of squares, each with a different color from a different chunk of our hexadecimal value. And then the amount of columns is dynamic depending on the hexadecimal string length. And the result was this. Slightly disappointing, to be honest. The colors, except for this one lovely green square here, the colors are very boring. So I wasn't too happy with that. So let's change that. Here is my color popper function, the 2 RGB function down there. It's a little bit of witchcraft of mine to boost the colors. What it does is it multiplies the largest value out of red, green, and blue by 1.5. And then it multiplies the other 2 by 0.7 to decrease it. So that would then just make the color nicer, or pop more. And with that function, we'll replace it, so we'll use it in there in our CSS. And the result was this. Yay! It's a lot better looking if you ask me. Now you just have all these random squares of random colors. And we can make more jokes into this. So we've got more dad jokes here. How do you find Will Smith in the snow? You look for fresh prints. Why can't you play poker on the African savannah? There's too many cheetahs. And then what did the grape say when it was stepped on? Nothing, it just let out a little whine. So there are some random jokes, and that's them in colors. But colors can get boring, so to make it even more interesting, let's have music. So whenever I think about making music in code, I use something called Tone.js, which is a trusty JavaScript module that lets you make music within your projects. And then I got thinking, so I thought about music notes. And they've got a fairly basic structure here. A letter, A, B, C, D, E, F, G, or then a number. So that sounds like something we could work with. And when we think back to our hexadecimal string also had letters and numbers. So here's some code I wrote up that basically it plays a note with the first letter in our hexadecimal string, and then the first number of our hexadecimal string, and then of the most recent joke added, and then it runs whenever a new joke is added using use effect. So let's try that out. I'm going to pull up a demo of the project, and hopefully everyone can add in some jokes. Now let's see if I'm able to do this. All right, here we go. Okay. Oh no, it's centered over that way. Okay. All right, there you go. We'll work with that. Okay. So if anyone wants to scan that QR code, I've also got a little script that will start making some noise. You can add in any joke. They can be just as bad as mine, or potentially better. You never know. So I will also run my script, which should start making some, and then I'll press over here. Okay. So now it should start. So we can see some jokes are starting to be added. And you can hear all sorts of random noises. Okay, we're back. Now we've got some more jokes. And what on this little demo website of mine, what you can do actually do is you can click them and you can see the joke. So, Lorem's up on child Erica Hart 75, whatever that means. Well done to that person. So you can click on these jokes to see them. Oh, what's that one? I'm actually quite curious how someone's generated that. Wonderful, wonderful work. Alrighty. Oh. So we can hear all sorts of music coming in. And actually, all the code that runs this is all on GitHub. If you scan the QR code, there's a link on there to see it on GitHub. Whoa, nice one. Okay. Thank you to that person. So yeah, it's a little Next.js thing that's using, if you haven't seen it, SWR, to just pull the data off an API route and then quickly update it. And then it's all running serverless on Vercel. So it's a small little thing that I experimented with. And yeah, if people want to keep adding jokes, that's all I've kind of got to say. You want to pull this up? Thank you for listening. And if you're curious, you can explore this talk's source code on GitHub. It's fully open source, and you can drop it a star if you'd like, or follow my GitHub. Yeah, thank you so much.
Cool, thank you. So we have 5 minutes for questions. Anyone have any questions? So you want to shout it out? Yeah, go ahead, shout out.
Thank you.
Cool, that's not a question, but sure.
It's a statement, but thank you.
Anyone have a question?
Have you looked at like more filters for your colors?
I played around with a couple. I played around with the CSS filters on them. I couldn't get one that looked exactly nice, but it'd be interesting to do.
Right.
Especially if I could pull in a way to get like the filters to be affected by something else. So actually some of them I had the ID also changing it as well. So I could try that as well.
You could go for the HSN code, like different colors of themes, right? Why you choose RGB instead of like there are 4 color patterns, right?
I don't know, RGB is just kind of being what I kind of always defaulted to. That's a nice idea though. But
Most of the coders use HSN, I think, so the few
yeah, I'm just boring and use RGB.
Any more questions? If not, thank you so much for Sam's.
No worries. Thank you for
having me. So one round of
applause.
Cool. So for our next speaker, his name is, sorry, how do I pronounce your name? Chinmay. He'll be talking about the software best practices in hardware world. So. So Chinmay has been working in like, what are you working in? Just quick interview.
Oh, thank you.
Cool. I work with underwater communication, so you can think of it as Wi-Fi routers, but that work under the water.
That's fascinating. So he'll be talking about how to build automation CI/CD tools that is widely adopted in the software industry, right? So cool. Right, so software processes and best practices like version control, build automation, and CI/CD tools are widely adopted in software engineering, but Chinmay wonders if that is used for hardware engineering, right? Like Git on schematics. Oh, that's fascinating. Right, and hardware test automations.
Yeah, so just plug it.
Right, so whenever you're ready.
Mic check, can you hear me?
Cool. So once again, give it up to Chinmay, CTO of Subneuro.
Hi folks, welcome to my talk at GeekCamp on the software best practices in the hardware world. A quick introduction about myself. I'm an engineer. I work at Subneuro, where we make underwater Wi-Fi effectively. I also run a monthly meetup, a hardware meetup called Hackware. It's kind of on a hiatus-ish now, but hopefully we'll be back soon. And I've been working at this intersection of hardware and software for about 15 odd years. And one of the things that I've noticed over all the time I've worked here is stuff that we consider normal and best practices in software world are not at all used in the hardware world. We'll go into some of these things and what they are, but before that I want to do a quick definition because this gets confused quite a bit and people don't know what they're talking about. Hardware is a very generic term. I'm using this a lot in this talk, but what I mean is sort of mechanical engineering, mechanical development, and electronics engineering and development for making standard products. So this could be watches kind of stuff, or mobile phones, whatever, things that you use on a daily basis. Since I've did definitions, I would quickly like to get a poll. How many people here only do software stuff? Quick raise of hands. No, that's not true. I love all of them. Software and hardware? All right, we got a bunch of them. Cool. Hardware only, anyone? Anyone? No, I don't think those people exist anymore. But yeah, I guess everybody does some sort of software here and there. And that means most of us would be very comfortable with some of the best practices I'm going to be talking about. So when I was working at Subneuro, one of the things I sort of tried to think about and do was to see if some of these best practices we use commonly in the software world can be applied, and not anyhowly applied, but can be effectively and practically applied so that people want to use them and we get the benefits out of them. So just to give a concrete example of what we're talking about, I'm going to be taking an example of one of the devices that we make at Subneuro. So this is one of our underwater Wi-Fi devices. And to make something like this, you would need a bunch of mechanical drawings and assembly drawings. You would need electronic schematics. You need layouts of them. You need the bill of materials of the electronics. And you need code. And a bunch of these are documents. And the documents would need versioning and version control. And then once you have and build all the components, you got to put them together, you got to test them, and then you got to integrate them and sort of put everything together and test it again. And coming from a software world, these words look very familiar, right? I mean, version control, versioning, integration, testing, this is stuff that we do on a regular basis. So can stuff that we have learned in a software world be applied to hardware development and engineering? So let's take them one by one. Let's start with versioning. Unfortunately, there's no standard versioning scheme in the hardware world. I have some examples of the kind of documents I have seen in the repository I have. Stuff that you've seen as horrors of underscore latest, underscore underscore latest is very common. People just make up their own versioning schemes, and then you get this really awkward problem with saying, oh, the mechanical assembly version 4 Mark II, is it compatible with revision 101A of the PCB? And there is no way you can figure this out. Of course, the software world, we have figured out this with semantic versioning. It is kind of a standard. It is widely adopted, though. And it's got this idea of having a major version, a minor version, and patch version, and a set of rules that explain to you when you should use this. What we did at Subneuro, we sort of created our own variant of this, in a way. This is sort of how we define major, minor, and patch. And what we wanted to do was to basically be able to understand what changed between two versions at a glance without needing to go through all the change logs and figure out exactly what it is. So this mechanism helped us use SemVer, and it's been working quite all right. The next one I'm going to talk about is version control. This is a hairy one. All documents need version control, and of course Git is the most favoritist of all of things available these days. Unfortunately, a lot of electronics and mechanical CAD tools tend to have proprietary binary file formats, and that just breaks down with Git. You get stuff like this. Somebody changed a file, added 512 bytes, don't know what happened. Even some CAD programs that use text files, you get a diff like this, which is great. It's kind of hard to see, but it's a bunch of numbers that changed, and nobody has any clue what happened. And the reason for this is, well, Git itself can deal with this, with binary files, no problems, or even text files like this. none of the user interfaces built on top are designed to be able to make sense of what happened between these two. But still, using Git gives us a bunch of good things. It gives us tags and commits, which work regardless, so you can still go back to a release and figure out what happened. It gives us branches and pull requests, which are still useful. But the most interesting thing, and this is something I think going forward we might get useful, is to have, in Git parlance, it's called porcelain. It's basically a user interface or a user-facing side of Git that could deal with some of these things. So there's a company called Allspice that's using some of these things to basically show a nice view. So this is how electronic schematics look like. So it would be able to do diffs on these things to say, you know, this change or that change. And this is nothing fancy except a plugin for Git, right? So once we have a good ecosystem of these things, and hopefully they're open source and you know, non-proprietary. Currently, this is completely proprietary. I think this is something that would totally be usable in a electronics design kind of a workflow. So currently we're still using with the commits and tags and the PRs and the branches, but I think with custom porcelain and GUIs built on this, I think some of this stuff could be easily translatable to the hardware development world. The last one is continuous integration and continuous deployment. This is you know, the ultimate goal in software development best practices, right? People want to be able to deploy things. It's impossible to continuously deploy things in hardware, right? You can't be shipping people new you know, Apple Watches every time there's a new release. So that's not happening. But even continuous integration is hard. And one of the main reasons is the time between designing a piece of hardware, so making a schematic, and then getting a working, you know, circuit board in your hand usually tends to be between days to weeks. So you're not going to be able to say, I change something, I ship it out, I get something back and I test it. So that repetition cycle is very, very slow. The other problem is that testing hardware requires custom hardware and custom equipment. A lot of times these equipments are expensive, so usually you might only have one. A lot of times you might even need to make custom equipment just to test your hardware. And most of the time, these equipments don't have nice APIs. So they're usually using some ancient interfaces, or even if they have some. So there's no way for you to be able to control them and say, you know, do this, do that, and then, you know, get stuff out. This is even harder on the mechanical side of things because, you know, for example, you know, things like multimeters to check, micrometers to check how long or wide something is. That's very, very hard to automate those things. So this stuff gets very hard. What we did find out is if you restrict your usage to just testing the software on the hardware, you can get quite a bit of the benefits of CI, but and you know, it actually can work. The awkward bit is you need to test the software on the hardware you're making. So in our use case, we have to test the software to work on the piece of hardware that I was showing you earlier, or some subsystem of it. What we figured out that we could do, and this is something that we have been doing quite a bit, is to have the hardware that we're testing on here, to have some kind of a host machine, and a test input generator and test output generator. And this would basically allow us to test the hardware through a host machine. So the host machine runs your GitHub CI runner or whatever your continuous integration host client is, compiles the software, programs the device under test, and then gives it the right input, and then records the output, and then checks whether that conforms with the test spec that we have. This has kind of worked well for us. It is a custom part of, or a subsection of CI that we can do, but it at least allows us to test a significant part of our software chain on the actual devices they're going to be running. The nice thing we figured out was we could actually remove one of the test devices, so you could just use another of the Wi-Fi, underwater Wi-Fi devices, and then just use it as both the generator and the recorder. It's just the way our devices work. It allows us to do this and just makes it a little bit easier to do. So this is a test of setup. This is a photo of a setup that we had last week. So this is one of the devices that's being tested. This is sort of the golden device, and then there's a host computer set up somewhere up there out of the picture. And then we're basically driving this guy, getting this guy to send the right signals to this guy, and then this guy outputs the right signals back to here, and then we record it back on this, and then verify if everything is working fine. awkward but doable, and allows us to sort of do some amount of continuous software testing on our devices. So back to the question I asked at the beginning, can software best practices be applied to hardware development? Hard, but not impossible. I think if you get creative, you can extract the essence of the best practice and apply it in context of the hardware. I think there's a lot of scope for doing these things. The velocity that software teams usually can manage to get is much, much higher than hardware teams. And I think using some of these best practices in hardware development, we can try to close the gap and develop hardware at a much, much faster pace than traditionally what's being done. So that's all I have for the talk. A quick plug. If you like to work on hard problems, if you think underwater wireless is interesting, we're hiring, so come talk to me after the talk and I'll happily tell you about what we do at Subnero. So that's all. Questions?
Thank you so much. Sam, do you want to lead the Q&A?
Yeah, sure. Let me open up the Q&A real quick. But I guess most of the folks here are more like software based on your survey, so I'm not sure.
Yeah, I have a question.
Yes.
So nice to meet you, Chinmay. So one question is, I think you have used LT Spice, right? So it only went for Allspice or like.
So Allspice is not. It's a horrible name. It's a startup that does basically Git for electronic schematics.
Okay.
So it's not related to LT Spice, which so Spice is an electronics simulation program. They use the name, but it's unrelated. Yeah.
Okay.
I've not actually used Allspice that much, but I think they are doing the right thing, and I think that's the direction we need to go to be able to use some of these tools and techniques in the hardware world.
So I know about LT Spice, but Allspice is very new to me.
It's a startup based in San Francisco. Yeah.
Thank you.
Yeah, I don't see many questions. If you have 5 minutes, you want to do a quick plug for. Oh.
One question.
Yes.
You mentioned you had to test it on the device.
Yes.
Is there any way to simulate that?
Yes, and I think I kind of wanted to talk about that. I didn't get much time to talk about that since exactly what I wanted to talk about. I don't have internet connection, but I think emulation is another big part of the story that I didn't get a chance to cover. I think that's the other bit where you can get some really, really interesting things going. I think it's a very nascent area though. I think good emulation is still very hard, and if you want to look at the whole product, you need to start emulating the electronics, the software, the mechanical side of things if need to be, and that gets very, very complex. But I think if we push down that route, we should be able to get a lot more in that direction. I think that's a great direction to definitely go in.
So there's no Chrome dev tools for Subnero?
Well, we do use Chrome dev tools. Let me see if I can bring up Walkui.
I'm actually very curious. Like, what does it work? Because it's like underwater Wi-Fi, is it?
You want to talk about that? Yeah.
Yeah, I want to talk about that. Underwater Wi-Fi. It's fascinating.
We have 2 minutes to plug. 2 minutes to plug.
All
You have 2 minutes.
till I pull up Walkui. Underwater Wi-Fi. So we use acoustic signals. So we use effectively sounds, similar stuff that dolphins use. Except we send bits and bytes instead of sending, dolphin talk.
What is like the practical applications of this?
Underwater sensors, underwater robots.
So is it like sonar? Sorry, I'm just asking a lot of questions.
It's like sonar, but traditionally sonar was used for imaging.
Right.
Or similar kind of stuff, but this is more used for comms. So
like Wi-Fi.
Sending
Right.
quick one. So Sam talked about, somebody talked about Walkui. So this is a super cool emulator if anybody is into hardware. This is actually a freaking awesome thing. So this actually emulates the entire hardware setup here, including all the buttons and the buzzers and the LEDs and everything in software in your browser. And you can write code which I think goes to the server, gets compiled into the actual binary of the processor that is running on this emulator. And in the processor's emulator runs that binary code and then emulates everything on this thing. It is.
You can write your own firmware and
yeah.
run it.
So yeah, you can. I'm not sure if you can just hear it. Yeah, something's happening. All right. Anyway, do play with it if you're interested in hardware kind of stuff. I think this is kind of toyish, but I think from a more industrial perspective, going down this route is exactly where we need to go.
So I mean, like, there's also like games you can play. Shanghai I/O is very fun.
It is. Yeah.
Wait, I thought it was
Shenzhen
Shenzhen.
I/O.
Is it
Shenzhen I/O, sorry, Shenzhen
But
I/O.
Shanghai doesn't have the
that's more. That's more. I'm not sure if this works, but that's more. That's more fun stuff.
It's a fun game. So it's a game
It
where
is.
you pretend that you are a Shenzhen engineer trying to steal people's code. That's it. Steal people's technology. Yeah.
All right.
I have a friend who was playing it, so I was fascinated. That's why I play with it.
Cool.
Okay, so we are gonna move on. Thank you so much for your round. Another round of applause.
I think the Shenzhen IO not sponsored.
Shenzhen I/O not sponsored. It's just my only experience in hardware, which is it's in the software form.
So thank you, Chinmay, for the hardware talk. Looks like the workshop selection folks have really blessed me. So the next few one is about security and hardware. Finally, something I can understand. Thank you, Ambrose. Yeah, so now we'll be talking. Waita will be talking about understanding the TLS ecosystem by probing the internet. So if you're all familiar with Nessus, or maybe he'll be going through in deeper detail. He analyzes the current state of the TLS ecosystem, as well as how we can improve the TLS ecosystem in the hot mess, TLS version 1.1, 0.2, 0.3, 0.2.1. Alright, Waitak, do you want to do a mic test?
Hello, Mike.
Okay, so before anything, this track will be track 0. Will be doing TLS system. Will be probing the internet. It's security stuff. Sam can talk more about it to introduce. But if you're like me, more interested in like programming and stuff, right? In track 1, they'll be talking about Python 3.11, which is a new release. It's about 25 to 60% more faster than Python 10. So if you're interested in that, track 1. Right, so it's simultaneous. So you choose one. I personally will go over there. So yeah. Python 11 is speeding up. So Ken Jin is actually a C Python contributor. So
what's going on in the next track? I heard you don't care about this one, right? You want to go to
yeah, I
track
don't
1.
care about this one. So I'm going. So the next track is about Python 3.11. So it's about Python actually speeding up. So Ken Jin is actually a contributor to C Python. So speed is actually coming to Python after so many years of like basically people like dunking on Python being slow. So Python 3.11 is about 25 to 60% faster than Python 3.10, thanks to a lot of contributors. So he will be sharing the technical details on what these like things will be. But if you want to stay here in track 0, it will be about TLS ecosystem and like how they analyze port 443. I have no idea, man. Sam, take over.
The speaker will be taking over, you mean? Okay, go and enjoy your Python 3.11. Let's see if it becomes faster than C++. I'll watch the recording, which is also available, folks, watching in on live stream. So anyone here handles the actual like network security, knows what TLS is? A bit. Enough to make the errors go away when I try to refresh the website. Alright, let's go right up.
All right, welcome to my talk on understanding the TLS ecosystem by probing the internet. I'm Waitak. I will be presenting this talk. Thank you for staying for this talk instead of looking for Python. You guys are awesome. You guys are the best.
Python is boring.
I love you guys. I promise this talk will be interesting. Hopefully more interesting than the Python one. So let's have a little introduction. Who am I? Why it's me? I do pen testing for a living. It's an actual qualification. I get to hack stuff. I get paid for that. Thank you. Yes, Mom, I actually get paid to hack. It's a good job. But in my spare time, I do a PhD part-time in machine learning. These two properties have nothing to do with this talk. This is just like something I did for fun. I just decided to scan the internet. I previously attended Geek Camp all the way back in 2014, so it has been 8 years. I'm glad to be finally giving back to the community that I really enjoyed. Some things about me, I like beer and I play CTFs. Okay, so let me give a rough structure to this talk. So this talk will be about these things. I need to baseline everyone so everyone knows what TLS is. Then I'll share about how I did my scan and what I screwed up on. So this is like not a perfect scan. Reason why I'm sharing this, well, the reason why I'm sharing this is because, well, I guess it's hanging. That's not what it wants to do. Technical difficulties. I may be getting hacked. It's okay. We have technical experts here in this room, which is everyone. Thank you for coming. Okay, yeah. So I did the scan. There are some things wrong with the scan. I'll talk about it. You guys will know about it. And then you guys would know that these are things not to do and what are the things to do. But I did collate some interesting results. We actually collected over 9 million certificates from the scan. I did some data analysis. I'll talk about some of the things that we see in the internet now, and is actually representative of what industry scans have been actually reporting. I share some of the trends, and I conclude this talk by sharing with you why this ecosystem is so weird. Okay, so level setting the audience. What is TLS? I'm not going to go through like the entire TLS handshake because everyone will be bored to death. Okay, no OSI either, but we'll be basically looking at what the average person knows as TLS, right? You go to a website, your bank, Google, you see this green lock, and this is essentially what TLS is. Of course, what does it actually represent? What does it actually give you? And just to illustrate the process of what it looks like, let's say you're Alice, you're trying to communicate with your bank. Maybe you want to invest all your money in Dogecoin, that's the thing that you like. But you don't want people to know about your preference for Dogecoins. So you want your traffic to be in the secret tunnel. And essentially TLS provides us that. And adversaries, like this man right here, will see just rubbish. And that's a very simplified view of what TLS is. We'll go a little bit deeper now into the properties that it actually provides. So firstly, let's say on the internet, you are trying to log in. You need your username and password, right? So by default, on the internet, if you don't use TLS or you don't have the HTTPS lock, you essentially are passing your username and password in clear text. Your ISP, your neighbor, if you're on public Wi-Fi, will be able to see your username and password. And obviously, you don't want your neighbor to know that Bob is your oppa. So the TSL tunnel provides this protection that prevents anyone from knowing what you're sending across the internet. So your ISPs don't know what your password is, which is good. You don't want your ISPs to know your password. Another property it provides is integrity. What integrity actually means is that whatever transactions that you made on the internet, you want to make sure that you click that button, it is what you think it is doing. So let's say you make a transaction to sell 100 Bitcoin. You don't want it to suddenly change to something else. You don't want this malicious fella to suddenly, buy 100 Bitcoin when it's already falling by a lot. And so TLS provides the guarantee that anything, if it was tampered with, if the traffic was tampered with, essentially the other party will actually know and then reject that traffic. Finally, the last property that TLS provides us is authenticity. So how the internet works is that you need to be able to navigate to a website, but where is the website hosted? So where is google.com hosted? You need to talk to a DNS to resolve an IP address so that your computer knows where to route that packet, and you can talk to your bank or whatever service that you want to use. So you would ask the DNS server very nicely, hey, I want to visit bank.com. The DNS server would give you back an IP address. This is not a valid IP address in case someone tries to visit. And then you will make the request directly to the bank. But how do you know that this thing is destined for the bank and that the bank is the one talking to you. You actually don't know that for sure. Someone could be in the middle and say, hey, I'm actually the bank. What's up? And you're kind of screwed. So if you have TLS, what actually happens is that you have the same process. You ask the DNS nicely. They give you an IP address. You talk to the IP address, and this protocol actually defines a way for the bank to prove that it is the bank. And this proof, right, cannot be reproduced by someone that is evil because they don't have that secret that the bank only has. So just to recap, this is pretty important properties of TLS that this protocol provides. It provides us with confidentiality, integrity, and authenticity. So TLS is pretty important for the internet. If you don't have this, like, how do you even trust what you do on the internet, right? People can just change what you do. They can see your password. They can see what you're doing. That's not. So it is a very key cornerstone of the internet. But with all that, right, it's like all beautiful, you know, it's like the most magical protocol, but there's actually a lot of weird things that happen in this ecosystem. And the world isn't all sunshine and rainbows, right? And to understand what's really happening under the hood, we actually have to dive deeper. So that's the superficial background that we have to go through. Everyone knows what TLS is. Now we have to go into a bit more technical detail. I promise not too much. So there's a very technical diagram there. It's the simplest technical diagram I could find. But we're not going to talk about too much about this. But essentially what we have to know here is when we talk to a service like Google or your bank, they actually provide us with a certificate. That certificate has a public key that allows us to encrypt our communications to the server. And there's some symmetric crypto as well there. And to prove that we are talking to the bank, we can actually check whether the certificate is actually issued by a trusted third party. How we do that is that there's a bunch of things in our operating system that essentially it forms the trusted store. So these are the certificate authorities, the people that distribute the certificates. They actually provide their information, and we are able to use that information to verify that the certificate is indeed issued by someone that's trusted, so we can trust that the certificate is actually issued by someone that is trusted. And then with that, we can actually trust the server, because if they prove that they have the private key that's associated with the public key, then we know that they are who they are. And the adversary won't have the private key, and this is essentially the cryptographic primitives, or TLS, in a nutshell. Of course, in the middle, they decide what cryptographic protocol they want to use to talk to each other. And this actually differs by version, right? Because every few years, crypto is broken, MD5 is broken, SHA-1 is broken, SHA-256, it hasn't broken yet, but who knows? So different versions ship with different cryptographic protocols, and all these things actually have some issues related to this. So because of all these core primitives that are being used, there are problems that actually plague TLS. So back in 2011, remember I talked about this trusted store. So who checks that this trusted store is a trusted third party? They can sometimes be compromised, and this is actually a case. And this is very recent, like just 10 years back. So a trusted certificate authority was actually compromised and was used to create a fake certificate for Google. So that adversary was able to impersonate as Google. So all the properties that we talked about earlier, confidentiality, integrity, authenticity, all out of the window just because one certificate authority was compromised. And not just that, right? We'll talk about the cipher suites that are negotiated. There's a huge historical baggage that comes with TLS. So it goes all the way back to SSL version 1 to version 2, version 3, then TLS 1.0, 1.1, 1.2, 1.3. Sometimes you need backward compatibility because you want to support more customers, and maybe that's not a good thing. So it's a really quite a painful history in TLS because there is a history because essentially every upgrade is a fix of a previously of a vulnerability that was found in a previous version. So in recent history, there are attacks on CBC. If you were in the crypto talk just now, CBC padding Oracle has been exploited to death in TLS, and in fact, it is. You will find out that later it's completely removed in the latest specifications. There are also compression side channels, where if you compress plain text, you can use the length as a side channel to actually find out what is the content of the plain text. RC4 is broken. That was the previous stream cipher that was used in TLS. And there were additional implementation issues because coders make mistakes. Everyone makes mistakes. And even the specs has mistakes. So as you can see, version 1 is missing from this timeline because it was never released because it was too broken. So that's a great start. But version 2 is deprecated in 2011, version 3 in 2015, and in version 1.1 and 1.2, because they supported roughly the same ciphers, they were deprecated around the same time. So currently, we are at a state where we have TLS version 1.2 and 1.3, which have support for ciphers that can be used in a safe way. And TLS 1.3 is this new specification, right? This new exciting specification that promises to solve all our problems in TLS. It adds like magical new stream ciphers called Cha-Cha-20. They prohibit the use of all the broken stuff that was implemented in the past, which is like finally, right? They make things super fast because they allow, instead of your typical handshake, which takes like, I don't know, 3 round trip, they promise like, hey, you can do it in 1 round trip time right now. And they drop all the, I wouldn't say useless features, obsolete features that were actually harmful for the ecosystem. But you have a new release, but who's going to upgrade, right? And how long does it take for them to upgrade? We actually don't know this. So I sought out to actually try to figure out what is the real adoption of this on the internet. So in this next section, I'll talk about descan. So before you even start scanning, right, you have to think about this. If I do this, why go to jail? It's an important question because I'm also bonded, so I'll have to pay damages. But other than that fact, let's see what other people have done already in this space. So the EFF has actually done the first worldwide HTTPS scan in this project called the SSL Observatory. So no one went to jail there, so that's great. In 2016, someone scanned the entire IPv6 internet. I think all of them are still alive and not in jail. Someone scanned a different service for robotic research, and there's actually paid commercial services that provide this data called Shodan. And so it seems like if we are doing it for science, it should be fine. But again, I'm not a lawyer. Don't quote me on this. If you choose to do this, right, my PSA here is don't try this at home. It's the same as what they propose on WWE. Of course, no one follows that, but yeah, don't try this at home. And there's actually real ramifications behind this. So there was an internet scan that was done in 2015, and that person that scanned it, or that organization that scanned it, actually received 12 active hostile responses. So what does it mean by hostile responses? So A, they were actually sued by other organizations, and secondly, or at least threatened to be sued by other organizations, and secondly, there were actually hosts that actually try to have retaliatory DOS traffic, denial of service traffic. Essentially, they flood your device with traffic so that as a form of revenge. So don't do this on your machine. Obviously, don't do this at home unless you want your whole Wi-Fi to go down. And also, these kind of scans actually trigger intrusion detection systems because you're scanning the whole subnet, right? And people will see this IP is scanning my subnet range, and maybe your organization is Google. So you're like, what is this guy doing, right? Well, can I find out who this guy is? And if they're lazy to find out who you are, they may just block your IP address, and then you'll never be able to access Google again. So your mileage may vary. You take your own risks, YOLO, etc. So now that you are mentally prepared to take the legal risk, you start to look for instructions online, right? Because like Google is your best friend. You'll find this article, like how to scan the internet in 5 minutes, and you open it and it's like a scam because they teach you how to use Nmap, which is not what you need. But then you encounter this software called ZMap on GitHub, which claims to be able to scan the entire internet space in under 45 minutes, which is about the length of this talk. So imagine if you start scanning now, maybe you can finish by the time you finish. So it says like, oh, it's either 45 minutes or 5 minutes. This is like, so when I first read this, right, I thought, this is gonna be easy, man. I'm gonna be finishing this in like a day, collate the results, write the talk. But unfortunately, there's a extrapolation right here. So there are a lot of factors that come into play in scanning. You can't just scan 3 holes and then expect that to that kind of performance for the entire internet, for example. And you can't expect to have like an increase in one wife or one husband and expect to have more husbands and wives. Trust me. So there are lots to think about in scanning. I'm just going to list some of the factors or things that you think you have to think about here. So firstly, you want to scan fast, right? You want to utilize all the threads that you have on your machine, all the cores, that you spend on your expensive machine. But for every thread that you have, you realize that it's a connection. A connection is also a file. And I hope that you configure your Mac's open file handles correctly, because if you don't, you may start getting errors, and then you have non-reliable scans. Next, you're scanning the internet. The internet is worldwide. The world is very big, in case you didn't know. It takes 16 hours to fly to the US. But of course, your packets will take a lot shorter time, but you have to think about how much timeout do you actually need, right? If you want to get reliable scans, you need long timeouts. But if your timeouts are too long, then you're going to wait forever for the scan to finish. Then I cannot give this talk. And even if you decide, hey, let me fix this timeout value at this number, let's say it times out. Do you retry? And if you do retry, how many times do you retry? Because each time you retry, it's a factor of increase for the time that it takes for you to scan. And there are a lot of hosts which are not accessible, so you're actually increasing your time by a lot. And you need high bandwidth. Unfortunately, local ISPs cannot give you the bandwidth that you need to do this kind of scanning quickly. So you have to utilize something in space or in the cloud, whatever. And TLS handshakes are actually way more expensive than the typical kind of scannings that ZMap reports or whatever scanning speed records, which is usually a ping scan or a SYN scan, which is just like the first part of the TCP handshake. For a TLS handshake to be established, you need to have the TCP handshake, which is your SYN, SYNAC ACK. And then you also need to have the TLS handshake, which depending on the version can be 1 round trip time or 2 round trip time. It's roughly about 3 round trip times in total. And of course, when you're actually doing this, there's actually computational costs as well, because there's cryptography involved, and some computers are slower than others. You don't want to be doing this at home literally, because legal ramifications, potentially being blocked from the internet, that's probably not good. So when you are faced with all these variables, right, the thing you should do is just do it, because just try to start with a initialization for the variables and see what happens, and then just iterate until you find a good fit for the parameters. That's like machine learning anyway. So now that we have a way of thinking about our scanning, we need to define what we actually want to scan, right? And of course, we're scanning the internet right here. Is that simple? Just scan the internet, right? What does the internet mean to you guys? Is it just a number? Or is it more than a number? Because I can start scanning from the whole IPv4 space. Maybe I focus on 443 because that's where all the HTTPS servers are. And I can scan from the whole range, right? Of course, I am simplifying here. You obviously omit some ranges because they are not valid IP address ranges. But 2 to the 32 is a huge number. It's approximately about the number of humans that have ever lived in this entire world, minus a few billion. And that's a lot of humans, if you think about it. But then that's a lot of hosts. That's my point. And does anyone see anything wrong with this sort of formulation to just scan the internet looking at IPv4 addresses? Of course, that's a rhetorical question. I don't expect you to know. But you see that my results of 9 million hosts seems a bit little, you know. Like, there should be more internet websites in the world than 9 million, right? So I have to admit here, I messed up a little bit. Just a little bit. And what you come to realize is that, and this is obvious, like, when you think about it retrospectively, but at that point of time, I was like, oh, yikes. Different websites can have the same IP addresses. This is like, whoa, yikes. So I'll give an example from our favorite website in the world, which is Stack Overflow and superuser.com. Everyone visits those sites. If you dig for their IP addresses, they have the same IP address. I bet you didn't know that. I didn't know that before this talk either. But if you actually visit the sites, right, they actually present you with 2 different sites. So what's actually happening behind the background? Magic, sort of. It's a concept called virtual hosting, or related concept is called domain fronting. But essentially, because in that TLS handshake, what happens is that the client will actually request for a particular server. In this case, the server name is included there. And on the back end, right, it actually routes and serves different responses based on the server name. So this is actually what's happening in the background. And by scanning IP addresses, we are actually not capturing all these different backends that are not accessible via IP. So that was a little mistake, but it's also, you know, just happy little accident. It's fine. It's not for production use anyway. So just to recap, the internet is not just IP addresses and ports, but you also have to think about domain names. Now, the real question is, how do you actually get all the domain names in the world? You can't. You can't just go to a DNS server, knock on their door, say, hey, just give me all your DNS records, A records, easy. If you do manage to do that, please call me. I would like to know your name. Or you can try to ask someone that knows, maybe Google. But here we are going to take an approach called approximation. Since we can't really get all the domain names from a DNS server, we can try to get as many as possible. And there are actually 2 data sources that we can actually get this from. I'm going to caveat this and say that this is left as an exercise for the viewer because I did not actually use these data sources for this scan. But you can actually look at the certificate transparency logs. So when you actually register for a certificate now, you actually have to push your certificate to a certificate transparency log. So websites will have their certificates on this particular database. You can search it up. The issue with this is that you register it, but what if you don't use the certificate? Then it's actually not hosting anything, right? It's not hosted on the internet. So there can be false positives there. So you want actual concrete things that you can hit on the internet. So that's where the common crawl data set comes in, where it crawls the internet for hosts, and you can see what's being, and essentially it collects all the domain names that can be reachable from the web. And these are 2 very good data sources for domains. And just to give a sense of how much we're missing just by only scanning IP addresses, this is from a paper to get a complete view of the certificate ecosystem. If we just do an IPv4 scan, which is what I did, you will only get 3 million out of a total of 16 million certificates. So it's essentially 75% missing. So there is a serious miss there. This probably can't be, like the work I'm doing here probably can't be published in a paper, but I can give a talk about it. So, okay, now that we have our target, we need to have our weapon of choice, right, to scan the internet. So there is mmap and then there's zmap. Z is lower in the alphabet than N, so we choose zmap. Of course, that's not the real reason, but zmap is written in Go. It's good for concurrency. It serves a different purpose in that it's for scanning and enumeration and not for vulnerability assessments. mmap has that vulnerability assessment component, so a bit more heavy duty. We don't need something so heavy duty right here. We will use zmap. And in particular, we'll actually use zgrab2, which is built on top of zmap, and it allows us to do more complicated handshakes like the TLS handshake. The caveat about this is that if you actually go online to all the data sources about scanning, you actually realize that if you look specifically for servers that only do TLS v1.3 handshakes, that they reject TLS 1.2 and below, these aggregation sites actually do not have those sites in their database because right now there is no good tooling to do TLS v1.3 scanning. So as a caveat, this tool that I show you here does not come with TLS v1.3 out of the box. You have to do some tricks to make it work. I'll leave this as an exercise for the viewer. So you have the tools. Now you need to make sure that you don't blow your wallet trying to do this, and you don't have to wait forever. So I just did a small experiment on 200,000 hosts, and this is the average time to scan. So 17 seconds for 2 to the 16 hosts, and maybe 30 megabytes for 2 to the 16 hosts, because we're actually storing the certificates. And if we were to scan the whole IPv4 space, it will take 300 hours and 2.1 terabytes using our Scratch calculations here. In reality, it's much less space, but it's about the same amount of compute hours. But to deal with this number of compute hours, what we can do is just spin more instances because we have the cloud. So that's what we'll do. So once we have that, right, all we have to do is just bootstrap the input into an EC2 instance and create our own hacker ETL pipeline because like hacker. And then we just have to repeat for all /8 subnets. We dump the result as a JSON, and then we just send the file over to OpenSearch. This post is not sponsored by AWS. So in posting that file, right, imagine you have so many hosts. Like, what could actually go wrong here? So the file is actually really huge. You can have 10 gigabytes worth of data per file. And so you have to do some buffered reads, and that's just an aside. Cool, let's look at the results. This is going to be quite short. So this is the number of hosts we scanned, 9 million. We ingested 96 gigabytes. We collected these amount of certificates. There are 5 million certificates. There were 300,000 expired, 900,000 self-signed. The satisfaction in scanning is priceless. I didn't go to jail. That's also priceless. And this data was actually gathered in March 2022, which is quite recent. So if we look at the 5 million valid certificates that we have, we actually didn't do that bad of a job. I think I did pretty decently. I had more than what they scanned in 2010, which is expected because of the HTTPS adoption. So that's nice. So what we are interested in is the adoption of the newer specs, the TLS v1.2 and 1.3. So this graph shows like the aggregated data of the different ciphers that are supported in the different hosts. This is the maximum level of TLS that they can support for those hosts that were scanned. So this TLS v1.2 is an aggregation of both 1.2 and 1.3 because of some issues in the underlying application of my scanner. But essentially, there are 98% or 8 million sites that actually use non-deprecated TLS. That's a great thing. Yeah. But we want to zoom in into specifically TLS v1.3. And to do that, we just have to simply look at the cipher suites that were established or agreed upon by the server and the client. And for TLS v1.3, there are specific cipher suites that are supported only in that version. But before I go into that, I forgot the slide. Essentially, why is there so much support for TLS v1.2 and 1.3? There's two main reasons. A, if you go to your browser and you try to visit anything that has TLS 1.1, 1.0 and below, it's going to say, I don't want to view this, this is bad. Second is, there's also a huge industry push from PCI compliance, etc., to say, hey, don't use this version anymore, otherwise you won't be compliant. So that's nice. But specifically TLS v1.3, we actually have a pretty decent number. So, so the TLS 1.3 ones are the ones with Cha-Cha, Poly 1305. Those are the TLS v1.3 cipher suites. And we see that actually the biggest green part, which is Cha-Cha 20, Poly 1305, the TLS 1.3 ciphers are actually the top cipher suites negotiated. And from the scan of the entire internet, not just Alexa 1 million, we find that 52% actually support TLS v1.3. So that's okay, I guess, but you have to realize that this standard has been out for 4 years and it's only 50%. It's okay, but also like it's not too bad. But what I'm really happy about is that we are actually able to confirm the official estimates from SSL Labs. So they estimated 54.2%. We got a number that was quite close. So we confirmed their results independently. So that's pretty cool. And when you do all the scanning, right, you encounter very weird certificates. So this is a certificate with a very interesting parameter. So if you do RSA, you usually have to pick two numbers, n, which is like a factor of product of two primes, and e. So can anyone tell me what's wrong with this e right here? So this e, right, is not your very standard e. E is usually 65537, a much larger number. With a number like 3, you can actually just take the cube root of like whatever message that you exponentiate to. So this is like a horrible parameter to be used in RSA. But what do you guys think? Is this a valid certificate that's accepted by your browser? The answer is yes. And the exciting thing is there's more than one site like this. What gave them the idea that this is an acceptable parameter? I don't know. I don't work for any CA. If you work in a CA, please let me know why this happens. So there are a lot of weird things that happen. Of course, you see that some sites on the internet still use SSL v3, which is insane because this is like 4 versions below like what is the current standard. So what's actually happening there? Right? What is on this like wild west of the internet? Like what services are actually hosted there? So some of it is like innocuous services, like this house right here. I don't know what this is. If you understand this language, please let me know what this is. I think it's for some house. But you also see some interesting things that you probably don't want to see, like security system. And that's when I knew I had probably had to stop, so I didn't put more websites here. So yeah, I don't want to go to jail. So closing thoughts. So the problem with OpenSSL, all these TLS implementations is that, let's say you have a problem in the library itself. For example, the alpaca attack, which is an implementation issue. It's quite recent, happened in the past year. What actually happened was that you needed to update a lot of things, right? Even in their official disclosure, they say, oh, this bug is not simple. You think you can just fix the library and you can fix the bug. That's not true. You actually have to fix all the other, you have to fix the clients, you have to fix the servers so that they agree upon that standard. It's pretty insane. And recently there is this news on November 1st, I believe, OpenSSL will tell you you have to upgrade to this version, otherwise you are vulnerable to this, some vulnerability. So I don't know if anyone here has tried to upgrade OpenSSL, or like you have to do this across an entire organization, but it is extremely, extremely painful. Because a lot of code depends on OpenSSL. If you make a connection to the internet, you probably depend on OpenSSL. This is like mostly fine because usually if it's a security fix, there's no functional differences. You can just upgrade. But if you're dealing with legacy code and somehow the fix is not backported, now you have an issue. And not only do you have to update your own code, you have to update the dependencies as well. And you probably have a lot of dependencies that depend on OpenSSL. And you need to wait for the vendor to ship the fix, and it's a very sad situation, right? So you don't want that to happen. Is there a better way of fixing this dependency hell? I don't know. And of course, there is this interplay between clients and servers as well, because clients have the ability to reject poor standards in communications, right? And this is something that is two-sided. Servers have to upgrade, but clients, ourselves, we have to upgrade as well. Finally, let's talk about centralization versus decentralization. So certificates are becoming increasingly centralized. A lot of people are using certificates from Let's Encrypt. The good thing about this is that you have standardized parameters, you have a reduced likelihood of expiry, and people adopt TLS. That's all very nice. But let's say the root certificate is compromised. What happens to all these other leaf certificates? Will the internet go down? I don't know. I hope that never happens. Anyway, I know I'm coming to the end of my talk, so this is the end of my talk. I'm happy to take any questions. Yes?
So when you come to the field of cybersecurity, right? So how was it when you came new to the cybersecurity field and hacking stuff?
When I was new to the cybersecurity world, I guess I've always been immersed from young. So like played with cheat engine, the memory, changing values in memory. So I guess I don't have the best context to answer this. But I guess I always was interested in this kind of thing, and like, I mean, this is not really cybersecurity, but like, I think security itself is exciting stuff because it forces you to understand how all components interact, and you want to find the weakest link and how to chain multiple different vulnerabilities together to actually get something that you can actually exploit. I think that's really quite fun. It's like a puzzle, yeah. So. I will take more questions because I have 4 minutes.
3.5?
Okay, I have 3.5 minutes, so.
Any more questions from the audience? If not, this is going to be a one-to-one.
Yes.
Hey, Sam too.
What was the weirdest website you discovered?
What was the weirdest website I discovered?
Besides the CCTV.
This is. So, I guess some of the weird websites, it's not really like, I wouldn't talk about the content, but I'll talk about the private keys they were using, right? So, I think in a previous talk, Jules actually talked about Hyundai using sample keys. There were actually many sites. I mean, some sites were using sample keys from like some Kubernetes repository on GitHub, and they were hosting that site using those sample keys. So like, people take that sample key a bit too far. And they were hosted on legitimate domain names as well. So it's a bit scary, yeah, the way people use TLS or set up their servers.
So what's the final end percentage of websites that are somehow still on SSL3?
End percentage, it's less than like 0.01%. There's only like a handful, like 300, 400 websites. Of course, this is not an exhaustive scan. I think I want to caveat that because like to get reliable TLS scans is actually very difficult.
As you've mentioned,
also part of the messaging,
all the timeout, retries.
Yeah, exactly.
All right, thank you, Whiteout. Can we give him a round of applause one more time?
Okay. So we're gonna have a bit of a room swap again. So if you guys are interested in what is going on in track 1 or track 0, so introducing a bit of what track 0 is doing, using math, statistics, and JavaScript to automate solving of Wordle, so you never have to do it again. Or going to track 1, the L4 compiler, a toolchain for a DSL for law, right? So yeah, lawyers, programmers, stuff, right? So if you're interested, yeah, so that right, so as far as I know, Eugene's wife is really addicted to Wordle still.
Okay, some people are still addicted, okay? Scrabble
Okay,
is never old.
fine. Alright, so Eugene's wife is very addicted to Wordle and she's been bugging him to like try out every single day and try to compete for a better score. Right, so usually I try to get it in 2. Suck it. But you know, he sucks at Wordle. So using math, statistics, and JavaScript, he tried to automate solving Wordle, so he has never to do it again. Assuming he doesn't like solving them. But puzzles is great for me, you know. So.
Okay.
Anyone here still play Wordle? Wordle? Fake fans.
So I'm gonna give a few minutes for toilet break. Go clear your bladder and stuff. Meanwhile, those who are here, you can grab a drink at the pantry.
Yes.
Yeah, that's it. But yeah, so like the L4 compiler, toolchains for DSL for law. So it is said that programmers and lawyers do basically the same thing. They anticipate scenarios and try to say what is and what is not supposed to happen, right? But English, so lawyers program in English, but you know, a CS. What if CS was invented before law? You know, what would lawyers be programming before in instead, right? So if you're curious, track 1, right? Else, come, you can sit here, move forward, and listen to
Wordle solver.
Wordle solver.
Not enough of those on Google. Why take the easy way out when you can do the mathematical JavaScript
So
method?
usually, right, you try with the letter E because mathematically, the letter E is the most common letter. Am I spoiling anything? Partially, right?
Alright, take it away. Oh, okay, yes. Our lovely video person is still away. Yeah, we can do some crowd work.
Yeah, do some crowd work. Come, like.
Also, yeah, so please.
So those who are standing, take a seat. Come, chill.
Let's take a picture of the.
Sorry, what? We're gonna do crowd work. We are not gonna like
come
sit
back.
down. Come.
Jody, come back.
Oh, what?
Come, 拍照, 拍照.
拍照, okay, I will 拍照. I look very dead. Okay, cool. Everyone gather. Come. Sit down. Why stand? Why stand? Right, true. That's true. Cool, you guys can stand for a while and sit down when you need to. Right.
Come, crowd work, volunteer work. Sam, how's you finding the event so far?
Very good.
How are you? Okay, you're one group, right? Got vibes.
Right, so
how's it going so far?
I'm just gonna shout out sponsors. Oh, platinum sponsor, SP Digital, IM Token for food. Gold sponsor, Cake DeFi. Silver sponsor, Pro Life. And our partners at Engineering SG, Geeks Hacking, Go SG, Hackerspace SG. Python group, user group Singapore, Ruby Singapore, CSS Singapore, JavaScript, iOS Conf SG, right? And all thanks to our organizers. Whenever we feel ready, I'm still waiting for the videographer to come back. So yeah, so. So it's almost the end. So I'm just gonna ask, like, how you guys feeling? Oh, there's still energy somehow. Woo! So thank you for the energy, right? So I guess we'll gather up the last few of our energy and give it out to our last speaker. But yeah, I'm waiting for my. Oh yeah, my videographer is here. So we're ready. So I'm passing it off to. Cool, take over.
Okay. I opened this last minute, so need close.
Come, warm welcome for Eugene while he sets up.
Okay.
Clap.
Okay, so Wordle, or more like using math, statistics, and JavaScript to automate Wordle, so I'll never need to do so again. There'll be a few code examples, and if anyone wants it, you can always go to the Git repo. However, thank you for lasting until the last talk. I know a lot of you are very tired. So to clarify, right, this is not going to be a code walkthrough. You do not need to know JavaScript knowledge, and you're not required to have a statistics degree. I won't be covering complex statistics. It will just be simple counting. So don't worry, it'll be easy. An alternative for my talk would be to call it using math, JavaScript, and aggregation to automate the solving of Wordle. And by aggregation, I really mean aggregation because I'll go through what's the difference between the hard math and the approach that I took later on. So part one, the background context, which the MCs actually have shared in part. How many here have actually played Wordle before? Woo! I see a lot of hands. How many of you are still playing? Wow, good. How many of you do not know what Wordle is? Oh, I saw a hand. Yeah. Yeah, that's very suspicious because that person is probably an imposter, okay? Okay? So yeah, if you've never played Wordle or heard of it, that's hard because it was everywhere. Even the government got involved for some reason. And like every alphabet soup of the agencies created their own Wordle. So, and we had so many variations, be it in Malay, in Chinese, in Hokkien. Shout out to Chian who created the idiom version, Chengu Wordle. Did I pronounce it correctly? Okay, but never mind. And it was the #1 social game until the New York Times acquired it. But however, like once it got acquired, like every other major social game, it started being forgotten to the oblivion. But still, good to see that there were many people who played. But why did I want to automate Wordle? As the MC shared, I sucked at it. And not just my wife, I had friends and relatives who were very competitive with it and like to, hey, what's your score? Hey, what's your score? Shit, I actually failed to solve it. So that kind of sucked, and I was still trying to solve it daily. Most of the time, my score averages 5 to 6 if I'm lucky. So that's how bad I was. Yeah, effectively, this is what I felt like. Where everyone was like doing 2s and 3s. Like, how do you get 2s? So I decided to one-up it. I decided to automate it instead. But what is Wordle? So for all the imposters among us, right, I'll summarize the key rules so you can blend in better. You have 6 tries to guess a single 5-letter words. Each try, the characters you use will be highlighted with green, which is an exact match. Yellow means you got the correct letter but it's in the wrong position. And gray character does not exist in the actual word. As a slight footnote, if there are double letters, there are some edge cases regarding yellow, but I'm not going to cover that. If you guess it correctly in less tries than your friends has covered, you get to convert it into bragging rights, quite literally. You get to rub it in the face of other people. And a new word is generated every day for you to compete on. So, how do we solve Wordle? This will be covered in 2 major distinct parts. One is the solver algorithm, which is more towards the math and the computation. And the other part is the UI automation program. For the solver algorithm, there are 3 major categories, and you can probably find articles on each major category on how to solve it. The first one is the AI route. The second one is the hard math, the real correct route, information theory. And the third one is the route that I took, which was a simplified math route. I'll explain why later as well. So for the first route, right, the AI route, right, unfortunately, you need a lot of data, and the only data I have was me. and I sucked at it. So the AI will probably suck as bad as me. So that was a no-go. Then that leaves the two remaining route, which required math. So I needed to study up on it. So that led to information theory. This was the hardest part of the whole thing, but yeah, I'm going to simplify it, so don't worry. If anyone wants to read the full math and understand the full thing, this is the simplified version from semi-simplified, which from 3 blue, 1 brown. If you want to hear the full thing, you go do a PhD. Because in essence, what information theory is, right, is branching out all the probabilities and all the possibilities out there and computing it so that we know what's the best option for you. And this actually manifests itself in ways that you may not predict beforehand, and I'll show why more. Because what you can view it is you actually brute force the entire decision tree, every single combination out there. And from brute forcing the entire decision tree, you know that, hey, if you take this path, you are more likely to lead to your success. So this can lead into very weird behaviors, at least from an AI point of view, or not AI, more like the computer point of view from information theory. So take, for example, this case, Saint Moher. I might be butchering the pronunciation, I'm sorry. Somehow, when you are processing it through the large decision tree for the information theory, the computation may decide to give bleep. And I'm like, what the heck? It's like, why did you give it this? Like, for most humans, right, we'll be trying to like figure out words that ends with an R. Maybe we'll try to put an E in the first 3 letters to like try to get a better guess. But no, the machine already knew. It saw all the possible answers, and all it needed to confirm was B, L, Y, or P, whether it was in the letter, whether it was in the word, and once it confirms it through its computation, it already knows its answer. That is how the decision tree and information theory works. And you can think of it like a professional chess player who's multiple turns ahead of you. At every part, right, basically once it gets the result from the input it gives in, part of the tree gets chopped off until all it has left is one answer. Basically, before the last letter was already put in, regardless of what was the result, green, yellow, or gray, it already knows the possible answers already. And like literally, what famously said by Sherlock Holmes is, once you remove everything that was impossible, all you're left, however improbable, is the answer. And that's how it does it. So it will give very weird words for the sake of optimizing the information it gets. So yeah, that's how it does. And so, as you already alluded, this is brute force. And in Wordle, brute force means 2,315 possible answers, assuming standard Wordle. This is before the New York Times changed stuff. There was some stuff that got changed. Along with 10,657 additional words. This gives a total possible options, right, of 12,972 words to the power 6. This math formula is not correct. Information theory uses a more complicated formula, but it gives very close numbers. So what that leads into is 4.7 iota, septillion, or quadrillion, or what is probably more comprehensible for most of us is 4.7 million. But it doesn't make sense, for example, if the AI just says this all the time. Sane. Or it doesn't make sense to use, like, I can't pronounce this right, Ali, I guess, because it's double A and double I. It's just not useful and to spam this. So in concept, some people have already attempted to optimize this approach on information theory to reduce it down to 2 million, to about 2 million, 2 iota, around there, by getting rid of the really unneeded words. Still, that takes basically forever to compute. And by forever, I mean like a day or two by most modern computers. And basically forever for me. So I wanted it to finish in minutes, not hours. I needed it to compete with my relatives when they say, hey, what's your Wordle score? I needed the answer immediately, not the next day. So that leads me to the simplified math route. What I call the agar-rated information theory. It may not be the very best Wordle solver on earth, but it's better than me, and that's all that matters. So, but then some people will be like, isn't agar-ration cheating on math? And in a way, yes, but in a way, no. It's all about use cases. And I want that to sink into every developer, to you, like remember your use cases. You don't need the perfect O1 or ON answer all the time. Your use cases are important. Because, take this for example, this is from the NASA simulation of landing the Mars rover. They use several supercomputers to compute every single variable and factor just to make sure that even if there's a small pimple on the surface of the vehicle, it doesn't burn up into a ball of flames. And that's important because you're sending a multi-million-dollar craft with millions of man-hours and man-days, all preparation in several years in advance. One mistake that happens, you can't undo it, you can't redo it, at least not easily. On the flip side, there was Kerbal Space Program, which used a simplified math and physics model to bring joy to millions of people as they launch their rocket and as their rockets explode due to the bump on it. Different use cases, accordingly. So, cheating is fine, as long as you somewhat keep to the spirit of it. And in my case, I will still keep to the spirit of the information theory and the math. So automation ground rules. We are allowed to know the full and there's a lot of experimental code, so you can see all the random trial and errors I went through there if you want. In version 4, basically it ran through what was the refined version that I went through. When it detects a duplicate character, I don't score that letter. So that already automatically bias any other character that is not duplicate. Likewise, if it's already in a known bad character, I don't score it. It's important to still allow these characters to be allowed to be inputted. The reason is because there are cases where the wordle of the day has duplicate letters. So if I were to outright say no and negative, I will never solve those situations. Likewise, if I already know the position, I skip accordingly. However, what actually made it break into getting it 100% right was this. Whenever I enter a situation, right, where let's say a specific column I already know the answer, what I do instead, right, is that in that column, I try as much as possible to match against other positions what is the most probable letters and use that accordingly. Basically, I'm trying to get yellows here, and I ignore any other letters that I already know are yellow. I'm trying to get new yellow blocks in this tile, and I optimize that accordingly. So to run this respectively, I can run it again. Has this finished? Yes, it has finished. So I can run this at V4. Where's my V4 version? Oh, I think it gone to the wow. Let me copy this. Rename, copy. Yeah. For the convenience time, once again, I'm just going to skip to the actual answer. And in this case, for the V4 version, it finally hit the 100%. And that was to me like, yes, success. But like, what was more amazing for me, like actually digging in the code and seeing it run continuously, right, was actually trying to understand how it works. So I'm just going to go further into like explaining it in details. How the solver approximately works step by step, because like prelude, the blight thingy, it's confusing. But once you have the code, you can start computing all those scenarios. As short, I can dump the game state at any point in time, and I can dump the statistics at any time. And that's what I did. So this again, how did it get answered? So at the start of the game, as I already ran through, sane makes sense. It was the only word that covered as much of the top letters as possible. So you see, 5 out of, it covered most of the top few unique letters, and it covers all the top letters, almost all of it at the top here, except for the duplicates. And it only found a partial match E, but it found that there was no match with SAIN. Using that alone, right, from the total possible of 2,315 words, right, it got sliced down to 187 possible words using that information alone. And from here onwards, right, because I know that E existed somewhere, but not in the last column, right, basically it was just trying to find any words with it knows that if the E has to exist somewhere in the first four. That's why you see a very strong bias there. However, but if you remember back in the code that I ran through, I avoided rerunning letters that I already knew. So what I tried to do is pick M-O-U-R. In fact, at this point, it doesn't even care what's in the middle column anymore, apparently. So M-O-H-U-R. And the chosen word is that because, but if let's say I score anything here, it will score very highly between the remaining words. And when that happened, when M-O-H-U-R ran through, from the remaining score, right, from the known new information, it reduced the amount of words known left to 12. At this point, you can already see the answer here. This is the remaining word sample. So this is a sample of the 12 words, the list of the 12 words. And you can see why it tried to use blight. Because in one shot, right, if any of these letters match, right, it knows very clearly. Like even if let's say P matches here, you can see there's only one word here with P. So it already knew the answer approximately at this point already. It just needed to know which version of it. And likewise, as L was matched, there's only, as you can see, there was only two possibility. But if you were to look through all the other ones, so where was the other one with L? Also other bluer. Bluer. If you realize it couldn't be bluer, and from then on it just guess its also respectively. So this is what I mean by reducing the information space based on the guesses. You can see a much faster example. For example, when it uses the same approach to literally guess from sane, once again, straight away with the information it has at hand, from the greens and the yellow, it reduced the information down to 12 possible words. And from there on, P ranked very highly, and U and T. Once it ran that through, the information gets basically reduced down to Pluto. So yeah, that's how it works. The solver works at a high level. But at this point, it was not enough, because you see, not all my relatives are tech, you see. And I can say, yes, I got the best solver, but then if I show them command line output, it's no fun. So I needed to show them screenshot. And I needed to automate this part. So that's the next part, integration with the UI. It's actually just taking the same approach, using a ranking function to solve the Wordle, but on the actual website. And how do we do that? So, live debugging with the Wordle code. Where was it? Okay. I'm using the mirror because this code is actually not updated for the New York Times version. So you can actually get all the information you need in the HTML. You don't even need to extract it from the JavaScript. There has been some approach to getting the information out of JavaScript, but that's not really important. So let's say I just do sane here, for example. As I type it out, you can actually extract the information here accordingly. So you can see for the row and the column, I can get whether it's correct, absent, present accordingly. And I can even double check that I input the characters accordingly. This is all the information that I needed to check, and it's all about literally doing the respective XPath, CSS selector, jQuery selector, whichever preference of choice to extract the information out. And that's basically what I did. So for the selector, you can see it here. So you can literally see from the query selector from the game app, take from the shadow root because it's a shadow DOM, game team manager, board, game row, extract the absent, present, correct information. Using this information, likewise, in the very same loop that's shown previously, get game state, feed it into the solver, rank it, run it, rinse and repeat. And once you have that, all I need to do is just piece everything together in an easy way for me to just share with my relative. And that's the last start, where I can just run it as a snippet. So if any of you would like to play around with this, right, you can write your own solver function. You can write your own ranking formula, choose accordingly, modify accordingly, and then once you generate it, you can generate a snippet where it's running live. So in this case, as you can see, it's running. This is today, Swirdo. It's still running, but once it gets the solution, I can just take the screenshot and send it to my relative. And please don't fail me today. Yes, it's solved. Okay, yeah. Woo! I did not check whether it will work, so I didn't expect it to reach 6. Okay, so yep, that's about it. My name is Eugene. You can ask me anything from this point onwards. I go by the handler Pico Creator. You can find me on Twitter, GitHub or Stack Overflow, mostly on Twitter. I've been working in various companies and startups for the past 12 plus years. My open source projects, my most popular one is GPU.js. Another one that's fairly popular is Inbox Kitten. I'm currently the CTO at UIlicious.com, so forgive me for shamelessly plugging it in. It's an online platform that does web test automation, and I believe that internet testing should be a piece of cake. I talk too much about internet infrastructure and software architecture, so feel free to reach out to me.
Yeah.
Okay.
If Cypress was a company, wait, it is.
Okay. Any questions?
Any questions? I'm gonna look through like the online Slido. There's nothing on Slido. Hi guys, anyone? Any question want to shout out? This is someone who is very like. I'll pass you the mic. Give me a while. Let me slowly walk over. No more energy. Sorry. Yeah, here you go.
Going all the way back to the 3 blue, 1 brown video. I watched a similar video and actually made a similar project after watching it.
Flex.
No, not Flex. It was probably worse. A lot less complicated than this one. What do you think of... I used something called entropy in the information theory. Did you experiment with that at any time?
Actually, yes. So basically, like, right now what you saw was a lot more simplified version. I actually did try to do the approach more similar to what 3 blue and 1 brown did. I actually started this project before this video came out, but when I launched the article and then his video came out, so basically everyone just kept diverting me to here. So I decided to reference it because he covered it way better than I understood it. In fact, my understanding of information theory was, I would say, garbage until I watched this video. But I did try to do the similar approach on it, and I just started realizing it was just taking too much compute. And yeah, you can take that into account, but if you realize like what I showed in the numbers, right, I'm just basically abstracting it away by just using the highest scoring number. According to information theory, what is probably the best option, right, is not the highest scoring. Because the highest scoring is information that you already know is probably, because if let's say I'm oversimplifying the math here, so if let's say you already know 80% chance that it's going to be the letter E in the 4th column, why even bother trying to guess that? Maybe it will be better, right, to find something that's at the 70% chance and you input it in there. But that became a snowball effect until like it became more complicated, and I did experiment with it, and I keep finding my algorithm keep performing worse and worse. It may do a better score, like it may even make guesses in like 3.1 or 3.2 on average, but it can never get the 100% solving rate. There was always that, and it could be my math error. So even for 3 blue 1 brown, for example, right? There's actually a follow-up video where he found his math error, and it's very hard to get the math correct. And literally, there are PhD students writing papers on it till today on how to get the math right. So I'm not going to claim to have succeeded in any stretch. But yeah, they try to go through that path, find it that it was less efficient than this, and somehow scored less. So I was like, you know what? I got this working. Go for it.
Yeah.
Yeah. That's why back to approximation.
Awesome. Thank you so much.
Cool. So fun fact, you can actually solve like Wordle in 1. There used to be like the answer sheet in the JavaScript if you know where to find.
That's where I extracted the word list.
Yeah, just use the answer key. Is there any more questions? Can be about the person itself. It's running a UIlicious, right?
Sure.
Actually, very curious about like how. Oh, crap. Cool. Wait. You wait.
This is online. People online needs to hear.
Yeah.
Okay, so you said you're like the CTO of UIlicious, right? So what made you like join UIlicious, or what's the purpose?
Oh, so I've been working in, like I shared, I've been working in the industry for like over 12 years. And I guess there were too many late night deployments. Or for me, the worst case was, there was one time where I was working on a project as a vendor, and the CEO of that company, of that bank, right, decided to announce, hey, we're going to launch said mobile app 1 month ahead of schedule. And they basically told us to just speed up everything. Testing and testing will be just an afterthought. That was a complete nightmare. There were so many late nights just running tests, getting things to work and all that. And I'm like, we are doing this manually. We should automate it. And that's why I wanted to build a test automation tool. And that's like another topic on its own. We try to make it easy. I didn't want a test automation tool for engineers because in that scenario, the PM was like, engineers are too busy launching features. We cannot use them for testing. So we decided to make a tool that manual testers can write test automation for.
Oh, so this is actually a tool for like test engineers, not for...
Both test engineers can use it and manual testers can use it.
Right. Cool.
But in this case, I'm writing off that tool. So if you can see the command, the commands are actually very simple. At least until I throw in all the math solver, it's literally I go to, I see, and then it goes, starts, I click. Yeah.
Right, like that's cool.
Yeah, that's until you throw in the giant JavaScript on how to solve Wordle and on the Wordle dictionary list. Yeah, and yes, the answer list is in here.
This is the answer list, by the way.
Yeah, correct. But I set the ground rule. I'm not going to cheat. I'm just going to reference this as the dictionary.
Why not cheat? It's so easy. Always solve in one. Okay, any more questions? Else it's going to be a wrap. Right, like cool. So, it's no one taking over the mic from me. Where's Ambrose? Exactly. I guess like we'll just wait for like track 1 to finish and then we'll do a wrap up over here. Meanwhile, you guys can just chill around here, right? Just have some time and network. There are a lot of fascinating people. I hear people who are working from every field here, right? Personally, I am not working, so if any company wants to hire me, I am available. Yes, so, but you know. But yes, network. But it's almost the end of the day, so you guys can like just have a rest, have dinner.
Wait.
The birds are flying around. Yeah.
Hey guys, thanks. Can I have everyone's attention? I'd like to thank everyone for coming. First, I'd like to give a shout out to our venue sponsor. Everyone clap, thanks. Thanks SP Digital. They're hiring. You can visit their LinkedIn page for more information. IronToken is also hiring, careers.irontoken.im. Thank you for sponsoring the Platinum tier. We have our Gold sponsor, Cake DeFi. They're also hiring. And so you can probably search them online and they'll have a hiring page or something. And then thank you ProLife for being our silver sponsor. Visit prolife.co to learn about their services. And again, I'd like to thank our donors and the entire GeekCamp organizing committee, my fellow organizing committee. Can you give a hand for them, because they've done a great job and they've spent a lot of effort. So thank them if you see them. And some final things, follow us on our Twitter, Instagram, Facebook, YouTube. And finally, I'd like to seek your feedback for GeekCamp. So you can just scan this link, bit.ly/GeekcampSG 2022 feedback. And please fill it up for us. All feedback is appreciated. If you're interested in volunteering for us too, you get free shirts like all the other volunteers here, and food, and and other things. So you can also go onto this link. The volunteer form is linked there too. You can open it and leave your email behind so that we can get in touch. With that, I'd like to thank everyone for coming. Thank you for coming to GeekCamp, GeekcampSG 2022, and Barcamp SG 2022. If Pritam, do you have any words to add?
Okay. Hello. Okay, thanks for joining everyone, and thanks to the GeekCamp guys for hosting us. You know, we were probably never going to do Barcamp until one day they invited us to join them, and now we are probably going to trouble them every year.
Okay. That's awesome. That's awesome. Yeah, we look forward to working with Barcamp some more, because I think I missed I missed most of it, but I was really interested in the topics that were put up there. With that, that's it. Sorry. Oh, it's his. Well, okay. Thank you everyone for coming, and see you soon at GeekcampSG 2023. Woo! Okay, one more thing.
Okay, so there's a few more things. Okay, first is if you guys want to stay back and help out, we will love that. So free labor, we will never say no to that. But if you guys want to take a leave, you guys can, slowly stream out, but also take free stuff before you leave. Thank you. Cool. Also, it's apparently Pritam's birthday. Is it? Is it? So do you guys want to sing a birthday song for Pritam for Barcamp? Yeah. Okay. Right. Ooh, okay, 3, 2, 1. I don't know how to sing, but. Happy birthday! Okay, so there is no after party, but you guys can informally try to organize one inside the Discord. Yeah, that's it. Cool. Bye. We also need free labor, so if you want to stay back, stay back. Okay, cool.